Hi, everyone. Welcome to the Messier Marathon 2022. My name is Wesley Sonamaker. I am joined here by John Compton. Hi, it's him, John Compton. We are looking at, first tonight, my eternal nemesis, the moon. This is an evil, big, dumb rock, and it's very reflective. Do you have anything further to say about the moon, John?
I like it. Beautiful. It's a sweet baby boy.
Horrible, absolutely not.
We're not going to keep talking about. We're not going to keep looking at it tonight. I love it. The moon, my favorite chunk of rock that came off the Earth. Looks gorgeous. It's got a beautiful dark mar and the lunar highlands, and yeah, it's gorgeous.
It's very pretty, but we're not here to talk about the moon. We're here to talk about one French guy and his very long catalog of a whole bunch of non-stellar objects. The moon is also a non-stellar object, but it's not in his kit. Going past that, there's a guy named Charles Messier, and he's from France, and he's a comet hunter, and he's trying to find these really bright comets in the night sky, and so he looks for all kinds of different just bright spots that he can see that aren't quite star-like with his telescope, and he finds not a lot of comets. He finds very, very few, but he finds a whole bunch of other stuff that is really bright and that he can tell isn't a star, and so he makes a big catalog, and they're all very, very pretty, and we're going to talk about a whole bunch of them tonight. How does it make you feel, John?
Well, how cool is your job that you're looking for comets, but you find, spiral galaxies and globular clusters, and then think like, oh man, I'm gonna write this down so I don't have to find it again.
Yeah, I'm gonna write this down so I know this is not what I'm looking for.
It's a cool gig. Yeah. Like that you can accidentally stumble upon galaxies and things,
right?
And, and be disappointed by them.
Yeah, that's something disappointing to you. All right, so we're going to try and go on to our first Messier object. Scott, our telescope operator. Scotty, would you please move to the Pleiades or Messier 45? These all have a numerical M number series thing. And so they're just in order of when they were found by Charles Messier. So this is the 45th thing that he found that wasn't a comet.
101. Let's do this.
Now we are waiting as either Scott or Juan. They are both operating the telescope. Give us a better picture.
I saw a star for a minute. Star light, star bright. First Messier object I see tonight.
Oh, that was
the
cute.
Pleiades.
It's the Pleiades. These are an open star cluster, so they're all very hot, bright blue stars. They're also much younger than a lot of their other star cluster cousins. Stuff like globular star clusters are much, much older. These guys are relatively very young. By that, I mean they are only several million years old.
Yeah, little baby mermaids.
Itty bitty things. I also guarantee that you've heard another name for this object before, John. Do you know what it is?
The 45th Messier?
Subaru.
Oh, yes. Subaru.
Mm-hmm. That's the Japanese name for the Pleiades. Yes, like the logo. Learn something new every day.
So yeah, the Pleiades are, on a dark night, they get this little bluish tint to them, and they're often associated with water or other things like that in lore. So mermaids, sea nymphs, sometimes kids trapped in a bubble. Either way, they're beautiful, but that blue tint kind of is owed to this gas kind of that's in the way. That's kind of.
It's mostly the fact that they're just really hot. They're B-type stars, so most of those are blue. They're not B because they're blue. I don't think B because they're blue. There's a whole bunch of, there's a letter classification system for stars. These ones are mostly B's. I don't think that stands for blue. I think it's just coincidental that B-type stars are blue. Don't at me on Twitter. Or do, I don't know. They're still pretty, you can't see a whole lot of them right now. That little star over on the side is them. But there's not, it's still pretty light outside right now, and we're contending with a quarter moon, so that's the best we got right now.
We're going to catch them all, though.
We are going to catch all of them.
We're going to try and catch them all.
We will be catching all of them, yes. And then we're supposed to write our names on this board with one of these markers now.
Yeah.
For everyone we do.
Let's do it. I
would like do you want gold or silver?
I don't.
Okay, I'm going to go with silver then. Accomplished. Hopefully done.
Oh, I'm also scared. Go nuts. It's me, John Compton.
Nice. It's him.
All right.
Compton.
You want to check out another one
Yes, please.
while we're here?
Scott Andor 1, M52, please. This is an open star cluster in the constellation Cassiopeia, the Queen.
This is one of the pretty constellations that you can see, fairly easily. It's got a fairly distinct W, and it's one of the good ones for finding the North Star. And it's a beautiful little star cluster in it, little open cluster.
Again, very difficult to see these things right now, but our genius telescope operators, Scott and Juan, will do their best.
Yeah, so, I don't know too much about the particular Messier object. I just believe it's just a general open cluster. I could talk about Cassiopeia all day. She's the evil queen of the story, and that makes her kind of fun. Classic Disney villain type situation. She's. I believe that the subject is somewhere around her throne. It would have to be. That's the whole constellation.
That's yes. That would.
So,
yep. Mm-hmm.
In the lore, she's kind of tilting around and around, dipping into the water, because she did some bad things. She's being punished.
Don't feed your kids to sea monsters.
Don't do it. Don't do it, y'all.
Don't do that at all.
And yet you're blessed with the 52nd Messier object in your vicinity, like the royal jewels, royal crown. I don't know if we're going to be able to get this one quite yet.
Yeah, this one's not working quite yet. We'll try and circle back to M52.
I'm not going to write it down yet. Then.
Not going to write it down. Can we get?
We should try one other.
Yeah, I'm just M103 is just in a very similar place to M52, so I don't know how well it's going to work. Anything here that looks like it's going to work well? Not particularly, no. All right, well, Scott Andor 1, can we get M103 pretty please? Could you give me a shot at that one? This might work a little better. I don't know that I'm convinced. Just a little further away from the horizon and therefore the sun.
See what we find tonight and try and circle back for anything that we can't. But it's better to try and get through.
This is very true.
To get some ones right now while the getting's good, or while the getting exists.
While there is getting.
While there is getting.
We're just gonna keep making funny faces at the camera.
Sorry, that's my go-to. It's just
all the faces that I make are funny. So.
Get anything in here? Not quite.
Let's
take a little break. Yeah, so we're basically looking for another.
Oh, is this the one with the red giant in the middle of it? Is that one?
Yes.
Right. Yeah. So this one has it's an open cluster like the last one, so it is mostly big, bright, hot blue stars, but it also has this really cool red giant that you can see. That's sort of in the middle of it. I think it's really just like in front of the thing when you're looking at it, but it still looks really cool. And so that red giant's a lot cooler and bigger.
I believe the red giant is part of the cluster.
Is it?
Yeah. I'm 75% sure.
I believe that.
Hey, that's
certainly. It's more than 74% sure.
Yeah.
That's not a lot. Okay, let's try for maybe. Let's try for M34. How about M34? And we'll circle back to anything we miss a little later when it's a little bit darker. Sarah, our boss, says that we got a few stars, so we're allowed to check off M103. M103, not M52. Okay. No M52 yet. There it is. Oh, where am I? Okay. Trying for M34. This is in Perseus. Perseus is in the Greek tradition the hero that attempts to save Cassiopeia's daughter, Andromeda. Oh, there's some stars.
Hey,
there are
that
stars.
feels like a solid win.
That looks like stars. I'll take it.
That. Yeah,
Take
yeah,
it.
yeah.
Way to go, gang. Nice job, everyone. We did it.
It's mostly white dwarves, right? Some other cool ones in here. But again, it's just an open cluster. A nice little pretty open cluster out there. Perseus is kind of a fun one. It tends to look like either a sad face or the symbol for pi, or anything but Perseus the hero.
I think it looks like a guy holding up a sword.
You think it does?
I think it does. That's just me. I think, well, it looks like a stick figure. Let's not get ahead of ourselves.
Fair.
Is this one? Is this the one that's one of the double clusters? Please tell me. Maybe my computer made a bad.
It is part of the double clusters. Perseus is a fun one. It's got Al in it, which is my favorite star.
I love the Demon Star. Big Demon Star fan. It's not one of the ones in the double cluster.
No? Okay. Well,
those are both non NGC catalog.
Mm-hmm.
NGC catalog, but saying that might be doing the La Brea tar pits.
Mm-hmm. Do we want to check this one off then?
I think this counts. We saw stuff. We didn't even have to have Sarah tell us that we saw stuff.
Yeah.
I've seen stuff in this one.
Saw it with my own eyes.
I saw it with your own eyes too. This one is going to be dubious at best. Can we try for M74, please? This should be a spiral galaxy in Pisces. I have already in the notes over here that we probably won't be able to see this, and we'll have to go back to it later. Survey says.
M34 is also known as the Phantom Galaxy, and it is
M74. You mean?
Oh, sorry, yes, M74, and it is definitely evading us with its phantom presence.
That's a good one. That's a good one. You got jokes.
I barely have.
But you have them, much like we are seeing this object right now.
The only joke I really had prepared was the Starbright one, and that's over. And we're done now.
And that's no, we're not done. Please don't leave.
No. We're done with my jokes. I got nothing left.
Oh, okay. Just here to be my hype man now.
Yeah. Do we want to look for maybe some brighter star cluster ones instead then?
Yeah, so we're gonna move on from M74 and to we're gonna go to M31 next. This is the Andromeda Galaxy. It's the closest big galaxy to us. I think it's where the aliens in V are from, if I remember correctly.
Fun fact: when Andromeda and the Milky Way collide together, it will be called Milkdromeda.
Milkdromeda.
Sounds awful.
I have to hope that by then all astronomers will have been long extinct, so that no one will be allowed to call it Milkdromeda. Mm-hmm. Got about 5 billion years for that, so got some time.
Sounds like a
That sounds horrible.
Yeah,
that sounds awful. I would never
horrible.
Want to consume milk and gummy bears simultaneously. Certainly not one mixed into the other. That sounds like a war crime, probably.
Like the weirdest boba. But yeah, Milkdromeda. Have fun with that thought.
Trying to suck just a whole Haribo gummy bear through a straw.
That's been with milk and ice cold. Yeah, so we are kind of fighting with daylight right now. So we were hoping to go in order, but a lot of these are going to be.
Yeah, we're going to do our best too.
Grabbing them while the grabbing's good when we can get them.
Yeah.
Let's see. What do we want to try for next?
So let's try M52 again. Hopefully we'll get M31 soonish. It may not be for 30, 45 minutes or something like that. But hopefully we'll get it eventually.
So right now we've got 34, 45, and 103.
Uh-huh.
All right. looks a little darker. Nothing quite yet. Oh, hey, a thing.
Oh, good, a thing.
Hey, it's a 50-second thing.
Great.
I am not disappointed with it.
I love this. This is great.
It's not just, you can see some interesting structure, probably.
Yeah, you can. This is obviously Messier 52. I'm sure you don't need us to tell you that. Yeah, Messier 52 is an object we tried to see a little bit ago. And this is a star in it. It's an open cluster. Yes. Haha, look at me. I'm a genius. This is an open star cluster in the constellation Cassiopeia. It's one of the ones we missed a little bit earlier. But that is a star in it.
Yeah. Balance. It'll pop out a little bit better. But it is there.
It is there.
The 50-second Messier. If you had to come up with a name for this Messier object, I wish there's not many of them. Right? There's 101. Like
there are 110 of them.
110. What?
That's 9 more than you thought.
That's somewhere between 100 and how many Pokemon there are in first gen. Like that's an easy.
What a great number.
That's an easy amount, right? I believe.
As a physicist, John, all numbers between 51 and 499 are 100. So
there's less Messier objects than first gen Pokemon. That's all I'm saying.
That's true.
And they came up with names for them. We need to come up with names for Messier objects.
So I hear what you're saying, and if I could just yes and you a little bit, I think we need to create a series of critically acclaimed RPGs for the Nintendo series of consoles based on Messier objects. We will have to create more of them, and that will pose some technical difficulties, but I think it's nothing that we can't fix.
I can make a galaxy. How hard can it be? Tell them where to build an anticipate.
How hard could it be? Let's see. Vamp for a second. I'm going to do math.
Okay. So all I'm getting at, folks in the comments, is these ones. This is M52. No, it needs an interesting name. It's an open cluster, right? So little stars that started together and are kind of drifting out in the universe, separating, going their own way, but they're still a little family. This one's in Cassiopeia, the evil queen of the story. What's a good name for this thing? We got to come up with. So I think the royal necklace, right? Or like the royal crown.
Okay, that's good.
Cluster. Something to do with the queen. Or the royal court cluster, right? This is like maids and squires and things running around doing stuff for the queen.
Yeah.
And now they're leaving. They're spreading apart because she's bound to a throne and being tortured for trying to kill her kid.
Yeah. Okay. Yeah. All right. This is now what did you call it again?
The Royal Court Cluster.
The Royal Court Cluster. Great. Fantastic.
By my decree.
By your decree.
John Compton's decree.
This is Compton 1 then, I guess?
Sure.
Yeah. All right. Well, I have run. Oh, we get to put our names on.
Yeah.
Yes.
That's the best part.
Yes. Yeah, I got it right there. Wow.
All my initials are the same shape.
I have lots of very disparate ones. There's a secret A in the front that I never tell anyone about.
Hey, do we want to pop back on Pleiades for a second?
I would love to pop back on Pleiades for a second if we could, please.
Take a peek.
We will now be taking a peek at the Pleiades, or Subaru. It's called the Seven Sisters. There's an old story about this being there's lots of different like objects that you can see in the naked sky like this. And this is a lot bigger than even we'll be able to see through this just because we're zoomed in so much. So you can see it with your naked eye. There's a couple of different things like this that were used as like ancient eye tests. And there's this old story about the Seven Sisters being used as an eye test for pirates. If you could see 5 stars in them, you had good enough eyes that they would like sign you up, they'd take you on their ship. And if you could see 6 stars in them, you had good enough eyes that they would put you in the crow's nest to be a spotter. And if you saw 7, you were a liar and they made you walk the plank. You can't see 7 with your naked eye. There's actually like 30 some odd of them in there. I don't recall off the top of my head how many actual stars we think are in this open star cluster. But there's only 6 that you can see with your naked eye. Yeah. And we have a few more of them now.
So if you're a pirate, just remember to say 6.
If you're a pirate, just remember to say 6. That's the real. John, what's a pirate's favorite letter?
I believe it's R.
Nay, the sea be his first love.
Solid.
Thank you. Actually, liquid, it's the ocean.
That's how they get you, though.
That is how they get you, is icebergs.
Because you're like, oh.
Yeah. Dang, ice having a lower density in a solid form than this joke isn't funny. I'm just gonna move on. So we can start to see more of those big bright blue stars in there. Problem is color's still really hard because now we're in this sort of weird twilighty phase. And so we can see stuff now, but color's still a little difficult because the camera has a hard time telling what is what. So this is about the best we're gonna get for a little bit. We'll come back to this later because it's very pretty. It's very, very pretty.
You do get a chance to go outside and take a peek up there at the Pleiades. It does have this really nice bluish kind of or like bluish whitish halo around it.
It is very bluish.
That little gas cloud out there hanging out, being illuminated, and it does look like a little grotto or cove or inlet where
a grotto or cove or inlet.
Yeah, a little area where mermaids might hang out, comb their hair with forks.
Do real mermaids comb their hair with forks, John?
Yes, fact.
Fact. Proven. You heard it here first, folks.
You want to check out another one that we? Yeah, let's. Do you want to try for 103 again?
Yeah. Let's try for 103 again. Let's see how well this works out.
Do you happen to know the field of view you were seeing?
Currently, not particularly. This should be, I think that little, there's those sort of 3 stars there. I think the one in the center is the red dwarf that's in the middle of this thing, or the red giant, excuse me. It's in the middle of this thing.
Hey, yeah, right there it is.
Yeah.
Ah. Oh, beautiful. Beautiful. Yeah. Little red giant in the center. Yeah. It's not often you get to see something like that. That's one of these beautiful little Messier objects all together. A little really open cluster.
A pretty open cluster. It's about.
So what are we calling this one then?
What are we calling this one then?
All right. It's an open cluster. A big giant in the center, right? Again, it's in Cassiopeia. So this is just one of the royal court then.
This is just another one of the royal.
Another one of the royal court.
Should we like assign each of the royal court a number then?
No. That feels too much like this list.
That's a good point. Okay. Should we assign them a type of gemstone?
Okay. Oh, well, I mean, I thought you had something.
No, I'm just the idea guy.
No, I think that's a bad thing. I don't like it as much.
Okay,
I'd rather say that this is like the I don't know, what's the position?
A duke?
A duke, the Duchess.
Sure, great.
Or the Duchess cluster.
The Duchess cluster. Another addition to the content catalog.
With a red giant sparkling ruby on the crown.
I thought we weren't doing gemstones.
Well, I'm not naming it after.
Okay, saying, all right.
The gemstone can be part of the crown feature.
Okay, all right, I'm on board. Do dukes and or duchesses wear crowns? My boss and yours, Sarah Bircher, just said we are looking at 41.2 times 27.6 arc minutes. So that's how much of the sky we're looking at. It's very, very tiny. It's very tiny. Those are all, an arc minute is a division into 60 of a degree in the sky. We're looking at 180 degrees of sky at a time because half of the, and the moon is coupled with 1 degree, I think. So a really tiny area of the sky, a very small subdivision of an already small division. Can we try? Let's take a look at M34 one more time, just because I want to try and actually see some in good detail. Now that we are starting to get actual normal sky, the sun has been entirely put away.
We're barely 30 minutes into the
We're
stream.
barely 30 minutes into the stream.
We got all the time in the world.
We're 25 minutes into the stream, John. We got 11 hours and 35 minutes left. I am a physicist. I can do math quickly.
Whoa! Look at that.
That's a whole lot more stuff.
Looks like a 34th Messier to me.
That looks like a 34th Messier to me as well. I would agree.
The one in Perseus.
Uh-huh.
Yeah, nice little open cluster. It's a lot of what we'll end up seeing are little open clusters because they're pretty and they look blurry until you get in close and see them, and then you're like, oh, it's not a comet.
And if you have a really mediocre telescope in the late 1700s, you might look at it and be like, ah, dang, I thought that was a comet.
Yeah.
If your name is Charles and you live in France, then.
Now they're not uncommon occurrence.
No. Woof.
So what do we call this one?
It's in Perseus.
What's Perseus known for besides just?
Well, the other problem is there's already a couple star clusters that are his sword, and there's already a couple star clusters that are the head of Medusa, and those are both pretty big.
They're better. We could call it the lesser Perseus.
This could be like his shoe. I don't actually know if it's close. He could have his shoe off. This one's his shoe.
Yeah.
I don't feel like we'll get any pushback on that.
The lost shoe.
The lost shoe
cluster. Oh, it's coming off of Algol. Okay. I keep wanting to go to crowns. I don't know why, because in my mind, it's Medusa's crown.
Well, I think the watch Perseus.
Perseus's watch.
Yeah.
Well, because we've got him, and then here's Algol hanging down, right, and that's supposed to be her rotating head.
Yeah.
And then it's like over here. Maybe he dropped his watch.
Yeah. His watch was stone, and it was too heavy, so it fell off of his
stone watch cluster. Stone watch cluster.
Got it in one.
Yep. No edits. Nailed it.
Fantastic. Yep. Don't need to revise that in the slightest. That was perfect the first time. What else can we look at? I don't think we'll be able to see triangle yet, so we're going to go a little bit out of order. We're going to try and do, we get M76 maybe? This is the little dumbbell. It's a planetary nebula. Doesn't have anything to do with planets. It's just that an English guy this time, not a French guy, looked at these things and thought that they were vaguely planet-colored and shaped. Because again, it was the late 1700s and their telescopes were bad and we hadn't made cameras yet. I don't
clarify. That's not it.
I don't think that's it. No, I think that's a star that's nearby. Yeah. Buoy.
We'll definitely catch this by the end.
Okay, nothing yet. Yeah, we got a whole bunch more time. We'll be fine. Yeah, this guy's real pretty though. A real good one.
Now, I had heard, maybe correct me, definitely correct me, because this is a rumor I had heard, that planetary nebula were called planetary nebula because people thought that they were like a planet forming or something like that.
That may be true. I'm not sure. I know that they're nebulas because they looked nebulous. Yeah, which just sucks as a thing to have to say. I believe
it comes something to cloud.
I think it's Greek for cloud. I think the word nebula is Greek for cloud. I'm going to consult the internet
There are plenty of types of planetary nebula. Well, you know, several ways you can get them, but I thought the original idea was that people,
according to space.com, which I don't know. William Herschel saw a bright star in the heart of this planetary nebula. He realized he wasn't looking at clusters, but through gas and dust. As a result, he coined the name planetary nebula. That sounds not true. I don't know that William Herschel was able to see, because talking about the Ring Nebula here, I don't know that he was able to see it in good enough detail to, or no, this isn't.
that
Yeah, this is whatever this thing is. Okay, I'm falling down a rabbit hole of looking for things.
would you like to try for that?
Sure, yeah.
So let's try the 31st Messier. Messier. Hip hip. Hip hip. All right. Stat jokes on it. Until they kick us out.
Yeah, something like that. More until we kick ourselves out, really. Okay, apparently no, yeah. They're planetary nebulas because William Herschel saw this one planetary nebula that looks like this and was like, this looks like a star, but surrounded with a gassy atmosphere. It's not entirely correct, but
oh, the stars nearby.
Yeah, I think this is intended to be Andromeda, but it does not.
We're not quite getting it right now.
Yeah.
So.
We're going to take some longer exposure shots and see how that works out. Scott and Juan are doing their best to work some magic on it. Oh, this is, we're still trying for M76. Can we try for M31, gang? So this is the Andromeda Galaxy. It's the closest one to us.
I thought it looked really similar.
Gave everybody a spiel about it a little bit ago.
Hey. There's a little cloud.
I believe that's the Andromeda Galaxy. It's very faint right now. That's a little better.
Well, for your money, that's the most stars we've seen all night. And that tiny little view there.
Very, very tiny.
Plenty of stars right there. It's an entire galaxy. I'm going to write down.
I think we can call that. That sounds. I am furiously Googling, trying to figure out if. Wait, hold on. That's silver. You got to do it in gold. Oh, come on. Come on, John. Unbelievable. We did it, folks.
So, are we going to be able to get the other ones in there? We're only just getting Andromeda. We're just kind of seeing a central area right now anyway. Andromeda, our nearest galactic neighbor.
I can't figure out if this is where the aliens from V are supposed to be from. The V fandom wiki does not say. I'm very sorry, everyone.
Nerds.
So there are a couple of little satellite kind of objects around M31, the Andromeda Galaxy. M31 is the brightest, so I currently would not put too much money on us being able to see the really, really tiny stuff around it, but we'll look at this for a little bit longer and then I'll ask if we can try that. There's some other Messier objects nearish this, just other really bright things.
Look at as hard as I can using 100% of my brain.
100% of your brain?
100%.
Wow. I hardly ever use 100% of John's brain.
Look for M110 and M32 in here somewhere. We can.
Oh, they wouldn't be in the same. We'll have to.
You don't think they'll be in the same show? I don't actually know what the field of view.
Well, because I mean, like, here's a picture of it, and we're looking at like that much of it. It's a real tiny chunk. I think we'll have to move it. If we don't have to move it, then we certainly will not be able to see them. Can we try for M110, guys? I would not put my money on this.
There's Andromeda again.
Well, but that's the frame from last time, I think. There's this. I can't tell. This is too faint.
Not quite there yet. It's getting darker out though.
We're trying again. It is getting darker out. No, Matty Mooney is running the streaming software right now. That's Mooney.
Oh, but we're kind of getting the moon's glare, aren't we?
We're still not quite at astronomical twilight, which is when it'll be like good for viewing this kind of stuff, which is in about 24 minutes. I'd say that's currently probably our biggest problem.
Mm-hmm.
It's just that kind of stuff. I can't see anything.
Well, it's gonna look like a star, but slightly blurry.
I got nothing.
Oh,
is that? I can't see it.
Oh
my God!
Ha!
That's. Oh.
Hey, there we go though. Messier.
Go team. I can't tell if that's Scott or Juan. Yeah, come on, don't use my pen. Talk about it. I can't tell if that's Scott or Juan in there, but good job.
Yeah.
Good
Awesome.
Lord.
Awesome.
This is an elliptical galaxy. It's a satellite galaxy of Andromeda, which is the nearest one to us. This is Messier 110. Yeah, let's try for 32. Why not?
That was M110. Andromeda's Pal Galaxy.
That's another one of Andromeda's galaxies.
Trying
to figure out.
I still want to keep going with royal stuff. I don't know.
I think someone else might have discovered this before Charles Messier, or was this one of the ones? This was apparently discovered by Guillaume Le Gentil in 1749. Sorry. It's about 6,700 light years across, so it's real tiny. Oh, there it is. Itty bitty tiny guy.
Hey, that's even better than the last.
That's even better than I say we certainly get credit for this.
Yeah.
Oh, yeah.
That's a solid win.
Most definitely. Incredible.
Not a big old spiral boy, but a beautiful little elliptic
satellite galaxy. Finch Harper, when that killer CME hits, what is the first thing you do? CME, Matty Mooney just said in our chat that we have to talk to each other. Not sure what CME stands for and hoping it's not inappropriate. We are in luck. It stands for coronal mass ejection. That probably didn't make you feel like it wasn't inappropriate, but it means when the sun shoots out a big ball of stuff that's bigger than the stuff that it is always shooting out. Basically, the sun has all these giant magnetic field lines in it. It's okay, Maddie. That's what we are here for. Where's it? It is so the sun has all these magnetic field lines running through it because it's made of plasma, and as we all know, plasma means. That's exactly right. It's just electrified gas, basically.
Pretty common plasma. Whenever kind of raining out,
or whenever you microwave a grape.
Whenever you microwave a grape, I'd say lightning is more common than microwaving grapes.
I don't know how many grapes you microwave, John.
0.
Well, you're missing out, John.
Yeah. So what are we doing? What's the first thing you do? I am gonna go, hey, what's that?
I don't know. What'll it do? Just not like driving into the forest and starting some sort of cult that I'm the leader of. That's probably step 1. I don't know what step 2 is. Step 3 is profit. I know that. I've seen enough to know that, but I don't know what step 2 is. Yeah. None of that is anything to do.
Let's see if we can get anything else.
Yes. Have we? Is there anything we haven't seen? Can we try the Pleiades again? This is Messier 45. It seems really funny that he didn't put this one in his catalog until number 45. Because that one's just like, you can just see that. You know what I mean? Doesn't add up. Charles, Chuck. Chuck, can I call him Chuck?
We still need kind of like the bottom part of the list, correct? M33, M76, things like
Oh,
that.
right, yes.
So now we should be able to catch some of these. So we might have to kind of go through them quickly.
Yeah, so this is the Pleiades here. Can we try for M33 real quick, gang? I know I just said to go to the Pleiades. I am so sorry. Oh my God. This is the Pinwheel Galaxy. This guy's pretty faint, so our mileage may vary. It's also called the Triangulum Galaxy. Near the constellation Triangulum. You can even see it right there. That triangle, that's Triangulum. This thing is near it. Beginnings of MM are about speed. I don't know what that message means. That's what we're doing right now. Thank you, brain.
Are we still? I think we're reflecting along right now.
I think we're waiting on.
There we go. Okay, now we switched.
Yeah. So. So we're gonna try and get a long-ish exposure shot of this.
We could also just but we'll let them adjust the curve and see.
Yeah. So Scott and or Juan are just playing around with what all the parameters of the camera are, so that we can bring stuff out a little bit. Everything you're seeing is true color.
Hey.
Are you telling me that this is this galaxy? Is this Triangulum? That looks like Triangulum.
Yeah.
Can't see any of the galaxy bits, but
we've got the
arms are.
We can definitely see the stars in it, and we can see little bits of the arms. So hey,
I'm saying
let's
it counts.
do it.
Yep, nope, that counts. If we write our names down fast enough, Sarah can't tell us it doesn't. So there we go.
Right.
That's
what's next?
perfect. All right, M76, the little dumbbell. It's called the little dumbbell after the regular dumbbell, which is a very similar looking and similar kind of object, but that's not up right now. But this is the little version. I don't actually know if it is smaller, like physically. It just looks a lot smaller. Is that a farther away thing? Let's see. I think so. Okay. This thing says that the little dumbbell is 0.617 light years across. Let's see how long across the Dumbbell Nebula is. Dumbbell Nebula, 1.44 light years across. So it is actually bigger, probably. Huh.
Fun fact: the dumbbell, like with weights and stuff, created after this galaxy.
Named after the galaxy. Yep, that's very a thing that you said.
It was invented after this galaxy.
Well, it was named after. Well, the galaxy was named after John.
That's a good one.
John P. Dumbbell.
We're getting some colors in there.
Question: Finch Harper, can this observatory see black holes? I have an obnoxious answer and a less obnoxious answer. The obnoxious answer is no observatory can see black holes. The more obnoxious answer than that actually is that no one anywhere can see black holes, because you can't see them because they by nature don't let light bounce off of them and they don't emit any light. The answer that is probably in any way at all helpful to you is that that picture of a black hole that came out recently was taken by something like 100 different observatories around the world, and they composited all of their data so they could get that. It's really far away, and even in that picture, you can't technically see the black hole because the black hole looks black in the picture. It's just orange stuff around it is this accretion disk around the black hole. It's this big spinning cloud of stuff outside of it. and that's what you're actually able to see. So can this observatory see black holes? No. That's the most direct answer I can give. I am paid to be a pedant. Still needs 74 and 77. Okay, let's try for M77. I don't know how well either M77 or M74 are going to work out, but we're going to try. We're going to do our best. We got like 5 minutes.
Well, we'll do great.
It's more of a sky thing than a time thing.
Mm-hmm.
So from a certain point of view, it is a time thing.
Mm-hmm.
I'm just gonna loudly sip my tea after that bad joke.
That's the way to do it.
Yeah.
It's not a podcast that we're on, but you know. Hey,
if you like podcasts, come check out Star Stuff Space Pod.
Which one is this we're taking a look at?
This is I think M74. This is 77. This is 77. Okay.
Yeah.
Sarah says it's good. Sarah says we get to count it. This one is a spiral galaxy, I promise.
Yeah.
Can you see it? I can't.
I can. It's in Cetus. It's just a little sea monster galaxy.
It is a sea monster. That's true.
Yeah, that makes sense.
It's very adorable. Yeah. So what we're seeing there is the galactic bulge. I hate that word. At the center of the galaxy, that's where most of the stars are concentrated, just because it's the middle of the thing, and so it looks really bright. And can we try for?
Oh, you can see little spirals in it.
Oh yeah, there we go. That's a little spirally.
Cool.
Nice. Can we try for M74? See if we can hit all of our attempts. 77 was cute. I can't agree more, John. I could, but I won't.
Save it for the second.
I'll save it for the second. You know, I don't want to give all my secrets away just yet, John. You're welcome, John. What's the G stand for? Oh. All right, doing our best for 74. This should, I think, be another spiral. See if I can frantically click between all of my different notes to find where the. No, apparently I can't because I'm very dumb. How did I do this myself?
This is 74.
I believe that this one is the.
Oh, this is the Phantom Galaxy.
Yes.
In the equatorial constellation Pisces. It is about 32 million light years away from Earth. That is very bright.
For spiral.
This is a grand design spiral, John?
I believe it is.
Uh-huh.
Not the Grand Moff Tarkin.
Not the Grand Moff Tarkin. Not the Grand Moff Tarkin. Tragically, not the Grand Moff Tarkin Galaxy. Is this M74?
I believe it is.
Oh.
Well,
No. Oh, is it right next to the moon right now? Oh, apparently not. Okay. Sure. Yeah, no, I can very clearly see M74 there. That, yeah, no, totally. Yep.
Hey. I believe in my heart of hearts that they're gonna get this thing to just pop right out. And it's,
if there's any two people, I believe
it's Scott. You can see some of it. What more do you want?
Yeah, there's some stuff. Yeah, this thing is really dim.
Yeah,
it's kind of a miracle we're able to see this much. And Scott and Juan are just that good.
It's perfect.
And we are also here, providing moral support. All right, well, that about brings us up to our first break. I'm going to run up to the telescopes to operate them a little bit. My boss, Sarah Bircher, says M74 is widely regarded as the hardest one to get in a marathon, which I believe that thing's real faint.
You're welcome.
You are welcome, folks at home. John and I got it just for you by telling some other people to do it. someone will be back to fill in for us in roughly 10 minutes, and then we'll be back in roughly an hour after that.
Question mark. Okay, we're good now. Okay, so I'm not sure at what point we lost audio, but we're back, so that's good. But we were just talking about M79, which is a very nice globular cluster up in the constellation of Lepus. And Juan was just telling us about how M79 was actually stolen from another galaxy.
Yeah, so doing research on this one, we kind of got the distance at 41,000 light years for this dwarf galaxy called Canis Major. And that was really confusing at first because, you know, we all get taught that Andromeda is the closest galaxy to us. So we did some investigation and it turns out that the Canis Major galaxy was a little tiny galaxy that is currently being eaten by our own galaxy, the Milky Way. We've got some galactic cannibalization going on in there.
Yeah, so we got a great picture of it here. Thank you for getting us that picture. So we're going to go ahead and sign off.
Our first one.
M79. It's over there in the corner. Nice J off for me.
And our next Messier object is going to be number 37.
So yeah, so Wesley, if we could move over to M37. This is a very nice open star cluster in the constellation of Auriga. Yeah. Here we go. Alrighty, here we have it. So I got a lot of star trailing going on. That was because the camera of the telescope was moving as the exposure was being taken. So as Wesley tunes things up here, we should get a nice view of M37. It's a very nice star cluster, especially through a telescope. This is one that I definitely recommend if you're at home doing a little Messier Marathon. This is definitely one to shoot for. It's fairly bright and it's fairly big, so it should be pretty easy to find, but it's about 4,500 light years away from us. It has over 500 stars in this cluster. And it's in a very interesting part of the night sky because the constellation of Auriga has many, many star clusters and many, many objects that are in the Messier catalog. So we'll check out some more of them later. But is there anything in particular about Auriga or about M37 that you want to mention, Juan?
No, just another open star cluster. Lots of open star clusters in the Messier catalog. One of the things he would really try and distinguish between things in the night sky are what are comets and what are not comets. So basically everything in his list were things that kind of look like comets, but he wanted to make sure he didn't confuse them as comets. So that's why we are running into such a deep patch of star clusters, and we'll continue to see them throughout the night.
Yeah, and this is a very nice photo, Wesley. I see you've got some moon rays or something going on there. Your nemesis, the moon, is probably putting these off. But yeah, so M37 is a very nice little star cluster. Do we want to move on to the next star cluster in the group and sign off on?
Yeah, let's sign off on M37. Next one up is M36.
Yeah, where's 37 up there? It's right here. So M37. Go ahead and sign that. All right, now we're going on to M36, which is another very nice open cluster. This one has another name, though. Many people call it the Pinwheel Cluster. And I'm not sure if we're going to be able to see this, but there's a very interesting star in this cluster. So while we wait for Wesley to get a picture of it here, I'll tell you just a little bit more about it. This one is also about 4,000 light years away, very similar to M37 in a very similar part of the sky. This one we suspect is about 25 million years old. And yeah, there's a very interesting star in here. I don't know if we can see it in here. It should be in there. Wesley, can you zoom in a little bit on the star cluster? Yeah, there should be a star that almost looks like it has a tail to it. It might need a little longer of an exposure, but
Maybe
there's a weird looking star in here.
Yeah, it may be that our telescope might not be able to pick it up either, but what we're supposed to be seeing in there is this really like red star with kind of a tail trailing off behind it. And what astronomers actually think is that we caught a star in between the formation of when you were just embedded in the nebula versus when you got the stellar disk going on. So this one's really weird. It's a star with a globular shape to it. It turns out that it's multiple different stars actually being made at once. So kind of interesting.
And another little interesting thing about this one star that's forming in here is that it's actually kind of separate from M36 as a whole. It's actually quite a bit closer, and it's part of this other stellar nebula that's kind of off to the side of M36. So it's, even though it's in the frame of M36, distances can be quite deceiving when we're looking out into space. And that's little star trail in particular it's quite a bit from a different distance from the rest of it. But yeah, I'm having trouble seeing the fuzzy star in here. But we can go ahead and mark this one off of our catalog here. So this is M36.
Ooh.
So right next to.
And it's finally dark enough so that we're actually just running through these at this point.
Yeah, it's finally dark enough that we can actually see these objects. So since we are probably going to have a little bit of extra time, I don't know if we can go back to the Andromeda Galaxy real quick. I know it's a great object to see at this, at this time of year. And I'm sorry we couldn't get you a better photo back when the sun was still out. But now that the sun is set and it's dark, we should be able to get a very nice photo of it here. Here we go.
Wesley's favorite word is the milk dromeda.
The milk dromeda, yes, that's his favorite word, and everyone should mention to him next time they see him. Oh, he's saying no. Yeah, it's taking exposure right now. Should just have a few seconds, and here we go. There it is. That's way better than the picture I was able to get. We can see that very bright core in there. We can see a lot of the stars that are making up the outer edges of the galaxy. And then we can almost even see a bit of a dust lane kind of running through there. I don't know if Wesley, if you could zoom in just a little bit on that dust lane. Yeah, look at that. It's gorgeous.
And this is the closest galaxy outside of our own, the Milky Way. This one's at about 2.5 million light years away.
Yes, yeah. So it's really, really far away. It's, millions of light years away from anything else in our galaxy. But it is our closest galactic neighbor, at least the closest large galactic neighbor in our universe.
And it's on a path straight to us. So it sounds kind of scary, the whole galaxy heading towards our own. But you don't have to worry. We still have quite a bit of time, at least 5 billion years before the actual merger happens between two galaxies. Later on, you'll have an example of that with another Messier object, but that's something, astronomers are definitely looking for.
Yeah. Set your calendars, guys, for this grand collision. But even though it is going to be a collision, it's going to be a very dispersed collision, simply because even though there's, billions and billions of stars in galaxies, there's, way more empty space than there are stars. To think that even just to get to the nearest star in our, galaxy, we have to travel a couple of light years. And so when, our galaxy and Andromeda collide, there's not really going to be any direct head-on collisions. It's more of the gravity of both our galaxies is going to swirl everything up, and planets are going to get kicked out of the orbits of stars, and star clusters are going to get thrown around, and all sorts of stuff is going to happen.
What do you think?
Quite an event, yes. I'm looking forward to it. Again, that's only in about 4 billion years or so. So time's ticking. Yeah, and that's a very nice picture you got there, Wesley. There's lots of dust starting to pop up. That central core is getting overexposed, and of course that's what you would expect because there's just billions and billions of stars in there. And that central core is actually so bright that on a dark night in a dark part of the world, you can actually see the core of the Andromeda Galaxy with your naked eye. It's in the constellation of Andromeda, of course, and it's definitely one of the coolest things to look for if you are at a dark sky site like we have here in Flagstaff. Yeah, so the Andromeda Galaxy. Yeah, I think we can move on to the next object now. What do we got next one?
So next up in our list, we are looking at Messier object number 35.
35. So
another open cluster in the constellation Gemini. I told you, we're going to see a lot of open clusters.
Yep.
As Wesley is moving that little bit on this cluster we're about to see, it's about 2.8 thousand light years away from us. So relatively close. This one is an interesting one. I want to wait till we get the picture of, but it's a star cluster that's close enough that astronomers have actually been able to measure or show how this mass of stars actually move through space. I'm just waiting for that to come through.
Yeah, wait for the picture to come through, and then we can. This is Messier 35 that we're going to. Sorry if you missed it earlier. I know there's lots of people up at the Godo right now, and so it can cut part to the cameraman to hear us occasionally. So yeah, M35. Thank you.
Okay, we got a question from George. Any chance you are using or can you as a focal reducer on these larger objects?
Well, I guess we could, but it would require us to take the camera out of the telescope, put on the reducer, and then put the camera back on, which is something that at least tonight we are not doing. But that would be something I would love to do, at other times, because things like the Andromeda Galaxy or the Orion Nebula or many of these other very large objects in our night sky. Our telescope is great for viewing parts of them, but it'd be great to see the whole picture.
And there's a nice good view that Wesley has got of us for the Messier object number 35. Again, it's another open star cluster in the constellation Gemini.
So yeah, this is also kind of very similar part of the sky as those other clusters we were looking at in a different constellation, of course, in the constellation of Gemini. And since this one is only 2,800 light years away from us, I know, Juan, you mentioned it earlier, but this is one of the closer star clusters to us. And since it is so close, we can actually measure kind of how the stars are moving in it. So we like to think that the stars don't move in our night sky, but they actually do. Oh, we are using a focal reducer. Oh, thank you. To answer that question earlier, we are using a focal reducer. Sarah just let us know, but she doesn't know any of the other specs offhand. But yeah, so the stars, they do move in our night sky. The problem is they're just so far, far away from us that we can't really measure it at all. But the stars in M35 are close enough that if we, watch the stars over the course of a couple years, we will actually see them move just a tiny little bit, around. And that tells us, how the stars in the cluster are moving. It kind of tells us that all the stars in the cluster are moving together, and that proves that this is in fact a cluster, not just a bunch of random stars. And it helps us with dark matter, which I don't know too much about, but then again, neither does anyone, I really suppose. Do you have anything to add, Juan?
Yeah, well, dark matter is this mysterious thing that we always talk about in astronomy and astrophysicists that a lot of people have a hard time wrapping their head around. For the most part, we do not see the effect of dark matter until we get into the galactic scales. But for the longest time, we asked the question, do we see any evidence of dark matter in these little star clusters? And the question is, no. There is enough mass in this star cluster to basically explain the movement. And that basically gave us the idea that we really only see dark matter at these large galactic scales, not even in the scales of, smaller things like these open star clusters. Not that they're small and any general aspect at all, these things are huge, but no dark matter is needed there, at least, to explain the motion of these stars.
Alrighty, well, yeah, I think we can go ahead and find this one.
I was M36. Wait,
M35.
M35.
Yes.
We got 36 already.
Yes, so it looks like we're getting a bingo right here or something.
Oh, yes.
And a whole bunch of them in a row, right across the center of our board. And we are on our way to the next object. So that is going to be M38, which is, you guessed it, another star cluster. This one also has a common name. It's called the Starfish Cluster. I've never been able to see the starfish myself, but someone said it was there, so that's That's the common name for it.
You know, a lot of these things, the common names are made by some guy who looked at the object through a little tiny teleskeleton.
That'd be something.
Little tiny telescope, and to them, they were able to make out these shapes. But you know, in our field of view, I do not see the starfish in there at all.
No, I just see a whole bunch of stars.
You definitely have to use your imagination in astronomy, that's for sure.
But yeah, there's definitely going to be some objects later on that Juan and I are going to talk about that do not look at all like the common name for them. But we'll get to those later. But yeah, this is another very nice star cluster up in our night sky.
It's the constellation Auriga. It's sitting at about 4,200 light years away from us, and another heavily populated area of the night sky with these stars. Really pretty to look at these type of things.
Yep, and definitely another one to try and shoot for at home if you have your own telescope. M38 is another big bright star cluster that'll look good even in a small telescope. So if you're playing along with your own telescope, I commend you for that. Good luck. But yeah, definitely one for one good one for the eyeballs.
Now, Wesley, maybe I can get you to show us this object really quick, but there's another star cluster right next to this one. It is NGC 1907. And like I said, it's another star cluster. But for a while, it was thought that these two clusters, Messier 38 and NG 1907, might have originated from the same area of the night sky. And astronomers were interested in trying to figure that out. So we started to measure the two, and it turns out they are completely unrelated. They are actually moving in opposite directions. But it's kind of cool because it's basically experiencing a nearby flyby. So these two star clusters are right next to each other. I'm sure there's interactions there that we cannot see from, ground-based telescopes, but there it is. Yeah, there it is. Nicely, heavily dense cluster.
Yeah, whenever I look up pictures of M38, you can always, if it's a wide field, see this little cluster next to it. And I always would get, at least when I was younger, would get confused about what was actually the Messier object. But Charles Messier, I suppose, couldn't quite see this little blob in his telescope back in the 1700s, which I'm not gonna judge him for that. But we can go ahead and sign off on M38 now.
That's another one.
Another one for the long line we've got here. We'll almost have a whole row. Although just looking at it, I know some of these objects aren't going to be shot till much later in the night. So it'll be a while until we fill out that whole row, but we're on our way to the next object. The next object we're looking at is a fan favorite of many people, M42, the Orion Nebula.
Fancy stuff now.
So yeah, this is going to be probably the coolest thing we've seen in so far tonight. Besides maybe the Andromeda Galaxy, this is a star-forming region full of hydrogen gas and interstellar dust that's forming little baby stars. So we'll see as Wesley gets a picture here. Looks like we're looking at just the core of it right now, but as he ups that exposure time, we're going to start to see a whole lot more. And what I really like about this is, even though it doesn't look like it right now, this thing takes up the whole frame of the camera. There we go. Yeah. So we're getting a lot of that very beautiful red hydrogen gas and a lot of that really dark interstellar dust that makes up this nebula. It makes it such a beautiful object to see, whether you look at it through a telescope or with a camera like we're doing tonight. So,
like you mentioned, this is the closest stellar nursery to us here at Earth at about 1,300 light years away from us. And it's not necessarily the biggest stellar nurseries in the night sky, but it is the closest one. So that's why, it takes up such a big field of view. But gosh, it's amazing to look at. So what you are seeing here is this huge complex of gas, clouds, mostly ionized hydrogen, the main component of what stars are made out of, and is basically being illuminated by that center mass of stars right there. We call it the trapezium. It's a cluster of baby stars. That's basically what we were looking at earlier when the exposure was set a little bit lower. But it's one main star that's really illuminating that whole area of the night sky. It's a giant O-type star. And if we look at the classification of stars, O is the biggest and hottest type of star. That is what is causing all that illumination right there. It's the bright one in there, but trapezium is at least 4 or 5 stars that we can really make out. And yeah, this one is a fan favorite, an awesome target for people doing astrophotography.
Yeah, and while we're talking about, I mentioned earlier that you can see the Andromeda Galaxy with your naked eye. This is another Messier object that you can actually make out with your naked eye. It's in the constellation of Orion. So if you're familiar with that, you know Orion's belt is those 3 stars that are in a line. If you look below his belt, there's another little 3 stars that are perpendicular almost. Yeah, here we go. Thank you, Wesley. And you kind of think of that as being the sheath for Orion's sword. And if you look at the little middle star in that little, triplet, you might see a little bit of fuzziness around it. And that fuzziness is this huge Orion Nebula that we have up in our night sky. And yeah, I just absolutely love the dust that we see in this particular nebula. I don't know, Wesley, if you could zoom in on some of the dust. Oh yeah, it's good stuff, good stuff.
So we're looking in the optical wavelengths of light, what our eyes would be able to see. Of course, through the telescope, it looks kind of gray because in all reality, our eyes are kind of like Capri cameras. Not as good as the cameras on these telescopes that are taking in a lot longer time to collect that light. But one of my favorite facts in here is that the Hubble Space Telescope has discovered at least 150 different protoplanetary disks. So these are disks around stars that are basically going to become planets. So they are seeing the formations of all these brand new solar systems. Kind of makes you think that, solar systems in general are a lot more common in the galaxy, in the universe, possibly. Yeah. But one of my favorite things to look at, I am waiting to the day that the James Webb Space Telescope looks at this object, because, them looking in the infrared, they're going to be able to see so much stars and little protoplanetary planets embedded in there. It's going to be exciting. And yeah, Wesley's just doing a great job of really bringing that out.
Real nice photograph there. We see lots of that hydrogen, lots of that dust. And I'm going to say we saw this, so I'm going to go ahead and mark this one off. And we can still talk a little more about the Orion Nebula, because we're actually have 2 objects that we're going to have to look at in a second.
Yes. So we are looking at M42, yeah, but you are also looking at M43.
Yeah, so Wesley, I don't know if you could jog the camera a little bit or just go to M43 so we can maybe center that one up in our view here. But yeah, so the Orion Nebula is only 1/2 of 2 Messier objects that Messier decided to distinguish. So M42 is the Orion Nebula proper. That's what we were just looking at. And M43 is this little offshoot of the Orion Nebula. And we're going to have it here in a second, but you can already see it. It's that little bright spot at the top there. So this next photograph should have it a little more centered. But yes, so this is a completely separate Messier object from M42. But it, of course, is still in the Orion Nebula. It's the same distance away. It's part of all the same dust and gas. And it's being illuminated by stars, and it itself is a star-forming region. And what I absolutely love about this star-forming region is its interactions with M42. So I believe a paper came out in 2018 that studied how these stars were moving, and pretty much came to the conclusion that this, object is crashing into the Orion Nebula. And not only is it crashing into the Orion Nebula, it's sending all these gravitational shock waves into it. Into all that hydrogen gas in the Orion Nebula, and all that hydrogen gas is starting to compress, and that compression is essentially what forms stars. So a lot of the star formation in M42 we can actually attribute to M43 crashing into it, which is a paper that came out in I think 2018. But I'd love to see some follow up on that research. I think that's a very interesting idea that they put forward. And the James Webb Space Telescope, of course, will be looking at the Orion Nebula and trying to determine some of the stuff for itself and give us more data. So we can kind of zero in on why exactly these stars are forming in the Orion Nebula.
Yeah, one thing I kind of want to remember is that when we look through the telescope and look at the pictures, it looks like a 2D object to us. But in reality, this is a big complex of 3D molecular gas. It's huge. So M43 is illuminated by a single star in there. It's a B-type star. So on that classification list, B-type would be right under O. So it is very, very hot, very, very bright. That's why we're basically seeing all of this nebula illuminated. I'm pointing at the computer like you could see me pointing at it. But it's kind of cool that we can actually look inside of the nebula itself. So it's basically this round shape that is actually being caused from this baby star. This star is so hot and producing so much energy, it's basically blowing out a shell of solar wind. And that shell is basically producing this cavity. And that's exact same thing that's happening in the larger M42 aspect of it. It's this big shell that is being blown out by the trapezium stars.
And I think we still have a few more minutes, right, to spend on M42. So Wesley, I don't know if you could maybe stack just a couple of M42 photos for us. We can show off the stacking feature that we have in our MallinCam software, which is one of my favorite things to do with the camera when I have it all to myself. Is what I do is I take a whole bunch of pictures of the same object and then overlay them on top of each other. And when we do that, we can really reduce a lot of the noise and bring out a lot of the details in the nebula. So what Wesley is going to try and do for us here is stack just a couple exposures of the Orion Nebula, and we can compare to how just one picture looked. And I think with the Orion Nebula, especially just 2 or 3 pictures, it really sharpens up the image in a way that makes it look like you're ready to send it off to a magazine or something to get published.
Yeah, it's really fun getting to use this telescope up here at Lowell Observatory. We get to use it every single night as long as it's not cloudy or terrible weather conditions. But yeah, definitely a great time.
Yeah, and I don't know if I don't believe we've mentioned what type of telescope we're using up here yet, but we are using a 14-inch plane wave telescope with a MallinCam camera attached to it rather than an eyepiece. And that 14 inches, that's a really big telescope, and it really gives us a lot of light gathering power. And so even the dimmer objects, like some of those dim galaxies that we were looking at earlier, we can still see them fairly well, even when it's bright outside, simply because we have such a big telescope that's really allows us to bring out a lot of the fainter parts of the stuff we're looking at. And then, of course, when we combine it with the fact that we can stack images and that we can play around with our exposure times and our gains, we can really just dial in these astronomical objects and then really get some good astrophotos that way. Yeah, so here we go. So you can see they're a little offset there, but you can see there's a lot of dust and stuff that is really sharpening up between the two photos. Yeah, especially kind of where the picture starts to overexpose. You can really tell that there's not as much noise going on between this photo and that last one. So that's one of the great things I love about this. So I think we can go ahead and sign off on M73 right now. M43, my mistake. The Orion Nebula's little brother. So we'll go ahead and sign that one.
It looks like we are doing okay on time for now. So maybe we can look at some other things before we hop back into the Messier list. Just kind of want to mention that what you are looking at right now is part of the larger Orion molecular cloud complex. So the Orion Nebula has a lot of really cool things in it. You just saw M42 and M43, but there are things like the Flame Nebula and the Horsehead Nebula that are right next to that. So Wesley, if you want to show us something like the Flame Nebula really quick, just so we can highlight all the cool things that are in Orion before we say goodbye to it.
Yeah, the Orion part of the sky really just has absolutely a ton of molecular gas and hydrogen and dust. And if you were to take, it's 2024, I think, NGC 2024. Sorry, Wesley asked. Yep, that's it. But yes, so where was I? Yeah, the Orion constellation just has tons and tons of stuff in it. And whenever you take wide angle photos of Orion, you start to see all of this cool stuff. So not only do you see M42 and M43, the Flame Nebula will pop up. It's right by one of the bright stars in Orion's belt. You'll see the Horsehead Nebula in those wide angle photos. You'll also see one of the coolest things in the night sky called Bernard's Loop, which is this huge thing of hydrogen that extends all the way from Rigel at the foot of Orion all the way up to Betelgeuse at the shoulder. But yeah, we are looking at the Flame Nebula right now. Just as a quick offsite. This is not part of Messier's catalog, but it is definitely one of the coolest nebula up in the constellation of Orion that many people overlook because there's just so many other things.
I wasn't even sure this was an object when I first started working here, and someone told me about it, and I'm like, I don't believe you. You have to show me it first. And I saw this, and I was completely blown away. It's quite amazing that the universe could make such pretty things like this.
Yeah. There's just all this very beautiful gas that's being lit up by the stars that's near the gas, and there's all that beautiful dust running through it, making it really look like a flame.
Cool. So we got a question from Tessa 760.
By the sea.
What? What did I say?
I think it's by the sea. It might be Bethesda.
Bethesda. But yeah, she was asking, what is a star nursery? What is a stellar nursery?
Yeah, so a stellar nursery is an area where stars are being formed. So stars are made out of hydrogen gas almost entirely. And when we look up in space, we see all these clusters of hydrogen gas like the Orion Nebula. And pretty much that hydrogen gas, through gravity will condense in places and become, it'll suck in gas, and then it'll have more mass, and that'll give it more gravity, and it'll suck in more gas all around it. And eventually that little ball of hydrogen gas will become so dense, and there'll be so much hydrogen in such a small place, that the atoms of hydrogen will smash into each other so hard that they actually go through a process called nuclear fusion. And at that point, they turn into hydrogen gas, and they give off light. And so when we say that stars burn, it's not quite accurate. It's be more accurate to say that stars nuclear fuse. But yeah, that is what a stellar nursery is. It's a place with enough hydrogen for stars to form in it. And those stars will give off light and illuminate the gas around them for us to see. I don't know for a fact whether the Flame Nebula is a stellar nursery or not, or if it's just a reflection nebula. Kind of the difference there is, in a stellar nursery, all the gas creates the stars, whereas in a reflection nebula, all the stars light up the gas and reflect light off the gas and allow us to see it, which is a little bit different. But yeah, anything to add?
No, that's a good question. Nebula is a really broad and obscure term just because there's so many different types of nebulas. So for example, a stellar nursery is a type of nebula. What you are looking at right now, the Flame Nebula, is a reflection nebula. So you kind of get more specific. If I say, hey, did you see that one nebula? It could mean so many different things.
Yes. And 10-minute time check. Alrighty, so yeah, so we have a few more minutes, so we'll go on to the next object here, which is M78. So if we can go over to M78. This is another nebula in Orion, another very nice one. I think this one gets overlooked a lot simply because the Orion Nebula is so big and bright. But this is a very nice one, and it shows off a lot of what we say when we talk about nebulas. So we'll see how the picture turns out with Wesley here. But this nebula is a great example of all the different types of nebula we have in our night sky. So the type of nebula that stars are made in, those stellar nurseries, those are often called emission nebulas because the stars are lighting up the gas around them so hot because it's so close together that the gas itself glows and emits light thanks to the stars. And then we have, of course, reflection nebulas. and that is, you know, light hitting gas and reflecting off. So it's not heating it up and making it glow, but it's making, you know, light reflect off of it. And then there's a third type of nebula, which is my personal favorite, called dark nebula. And I'm not sure how well we'll be able to see this in M78. We might need to take a bit longer of an exposure or just stack a couple pictures, whatever we can do, we'll try. But dark nebulas are areas of the night sky that are full of interstellar dust, which is tiny little dust particles that are dense and don't really reflect or give off light. And so when we look at them, we're looking at the lack of starlight rather than starlight itself, which is, I think, really cool. So we have a little bit of M78 right here. Since this is in Orion, it's kind of the same distance as these other objects. It's about 1,600 light years away. We can kind of see, ooh, there we go. Yeah, so we can see some of the inner stuff. That's the reflection nebula, where light is reflecting off of all of this gas and dust in the nebula. And then we can also see some of the dark nebula, which is the dark stuff where light is, you know, not coming through it because there's all this dust in the way. So yeah.
It's doing a really good job at actually pulling this one out. This is one of the fainter nebulas in the night sky. And our camera that we're using right now is actually optimized for the short exposure time. So I don't think Wesley is doing any more than 30 seconds. These pictures that you see online where they come in super detailed and just spectacular are taken over the course of hours, sometimes even days. So this is just a nice little quick view of it. We are still highlighting some of the really cool spots like the inner reflection nebula right there, and you can see kind of that dark nebulosity surrounding it. But yeah, like how Scott said, these are areas in the night sky where it's just so dark because of the lack of stars. We're not seeing any stars come through it or behind it, so it really just looks like this pitch black darkness in the night sky.
Yeah, so I think M78 is definitely a really cool object. I wish we could spend more time with it, but I think we're going to have to move on here to the next Messier object, which is M1.
Lucky number one.
The first object in the Messier catalog, and it often goes by another name, the Crab Nebula. And this one's going to be right next to the moon, so it might get a little washed out, but let's see if Wesley here can show us the crab, the shape of the crab in the Crab Nebula. I wish him luck.
The moon's definitely gonna draw some of this out. You know, Wesley's favorite object in the night sky can't get away for the night, so gotta deal with it, but hopefully we can still get it pretty good. So Messier object number one, Crab Nebula, is a supernova remnant. It's another different type of nebula. So this is an example of nebulas produce at the end of a star's life, but not just all stars, these supermassive stars. And I'm talking about stars anywhere from 10 to 20 times the mass of Earth. Usually when our stars, you know, reach the end of our life, they go through an event called a planetary nebula. But for instance, this one is a much more violent event. It's more of an explosion. And this is actually something that humans saw in history. So in about 1054 AD, the people alive during that time saw a bright flash in the night sky that lasted about a week. It was the second brightest object in the night sky, right behind the moon. And, you know, people all across the world observed this. People from Japan, China, Europe, even some tribes here in America depicted this object in some of their petroglyphs.
Yeah, this is definitely something that I think left its mark on humanity. You know, if I was a feudal peasant in 1000 AD and I saw something brighter than the moon just appear in the night sky, I would think the world is ending,
Apocalypse, yeah.
Or you know, some terrible thing was about to happen. Luckily, nothing really bad happened for them, unless it was coincidental. But yeah, so the Crab Nebula is, a very nice supernova explosion. It's the only supernova explosion that Messier cataloged. And I imagine, you know, since this is, you know, in 1000 AD, it was so bright that, you know, you could even see it during the day. It was the brightness of the full moon. back in Messier's day in the 1700s, it probably still would have been very, very bright. And as time has gone by, it's starting to dim down a little bit. And that's really interesting because it's something that we can actually observe. So, the Crab Nebula was changing, as it dimmed down, and, Messier saw it in a way that we are not seeing it today, simply because we're looking at 300 years in the future to what he saw. And since this is an explosion, it's still going out into space. And so it's probably not quite the same as he saw it.
So I think the term is expanding supernova. And what you were actually seeing are layers of the sun that are actually, or not the sun, the star. The star that went supernova, that basically went through the explosion and being shot out through space. And a quick shout out to one of the astronomers in Lowell history, Carl Otto Lampland. He was actually observing this supernova remnant here at Lowell Observatory back in 1920. And he published a paper and he basically said that the supernova remnant has changed over time. And that was really interesting. A lot of other astronomers looked into it and they basically figured out that, yes, this object, in fact, is still expanding. It will continue to expand through the next hundreds to thousands of years. So basically it is sparse and far away enough from the core that remains so it basically doesn't get illuminated anymore.
Yeah.
But for now, we got this pretty object in the night sky that definitely does not look like a crab to me.
Yeah, I don't see the crab either. Even if you look at like NASA Hubble Space Telescope photos, I don't see the crab at all. But you know what I can see? I can see M1 on our board, and I can also see M78 on our board, which we forgot to sign off on. So we'll go ahead and sign both of those right now. All right. Right there.
Cool. Okay, and we are making our way through this list.
Yeah, we are making some real progress here, guys.
I think we're about 22 objects found, and now counting M1 and M78, 20. Never
20
mind.
objects, yes. So 20 objects in 2 hours. I'd say that's pretty good. That's a pretty good pace we've got here. We'll go ahead and read them off for you guys, so you guys can see which ones we've got. We've got M1. We have M31, M32, M33, M34, M35, M36, M37, M38, M42 and M43, M45, M52, M74, M76, M77, M78, M79, M103, and M110. So yeah, that's quite a mouthful. We're definitely jumping around here. Messier didn't order his catalog in a way that was very nice to show it in this format, but definitely we've got a lot of really cool objects we've already seen. We have lots more really cool objects to see here in the next. How long do we have? Another 10 hours?
10 hours.
8 hours? 10 hours? Quite a long time to go. But we still have a few more minutes left with you guys before we jump back on the camera and Wesley comes back and talks to you guys about the next set of objects. So I guess in the meantime, is there anything in particular we want to shoot for? Actually, Wesley, would it be possible? Oh, we're going on break? Okay, we're going on break. All right. Wesley's probably getting pretty cold.
It is a cold
I was seeing my breath before sunset, so it's definitely a cold night out here in Flagstaff, but definitely a nice clear night. So we're still able to get all the objects we want to tonight. So
we would see you in 10 minutes.
all righty. So yeah, everyone have a good time. Lowell's going to go on break and we'll be back in 10.
There we go.
There we go.
Hi, hello, we're back.
Hey pals, thanks for coming back to or sticking around for the stream with us.
Or coming back.
We're back.
We are back, yes.
yeah, we're here to check out some more cool Messier objects. We got a lot of fun ones that they got to do.
Indeed. Yes.
And we're back to clusters.
We're back to clusters. Got a whole lot of clusters.
All day.
Is this this is M41? Yes. Okay. So we're looking at something called the Little Beehive Cluster, or Messier 41. It was apparently it was discovered by Giovanni Battista Hodierna before 1654 and was perhaps known to Aristotle in 325 BC. Says this thing I found on the internet. Who knows?
And then Messier said, "I got it. Let me name that."
Yeah. It's in the catalog. I don't know if the catalog's really claiming credit for finding it first, even. I don't know. I don't speak French. I certainly don't speak 1700s French.
Yeah, so this one is in like around Canis Major. And I don't think this one is technically in Puppis. Yeah, no, it's not. It's in Canis Major, the big dog. Let's see.
Yeah.
Do we want to try out? Well, let's
just go to the big beehive?
Well, I was gonna say.
Well, we got to write our names on it.
M90.
First.
Yeah, we got to write our names.
We
We got that one. Easy, too easy. Back to clusters. Yeah, let's try out M93. Whoa. Yeah, so now we're going to M93. This one is in Puppis. It's also just kind of a cool open cluster. There's several in there.
You've skipped over an incredibly important fact here, John.
What?
The constellation Puppis is the imagined poop deck of the legendary Argo.
That's true. Yeah, because they split it up. There's like the sail and the keel, and then what used to be the bridge of the ship, I guess. The aft.
Is that where the forecastle is?
I don't know what a forecastle is.
It's spelled forecastle. It's on the.
Oh,
page, right?
no. So the poop deck is the aft castle.
Oh, yeah.
Yay, sailing.
Yay, sailing. Your hat looks vaguely nautical.
Yes.
Oh.
But family of sailors. Yeah, this one looks really pretty. I'm digging this one. I don't know too many interesting things about it.
I don't know too many interesting things about
except
it.
that it's a beautiful, sweet baby. Do we have an interesting name for it? Yeah. At me in the comments. Find an interesting name for this thing.
We established earlier that our shtick was that you would assign it an interesting name.
I want the people to help.
Oh, all right, sorry. Yeah.
We got to come up with it together.
There are 6 Gamma Doradus variable stars in it.
Oh, nice.
It has a Trumpler class of I3R, L3R, one of those. It's unclear what the capitalization situation is.
Yeah, this one's definitely coming out. Like now it's darker out. These are looking gorgeous.
Yeah, no, that's real pretty.
Really, really bright stars. It's a very close together cluster there.
Yeah, that's why it's called a cluster, John.
But it's supposed to be open.
We like
it's
to
an open
have
cluster.
Fun. Well, it's not. I don't know. It's just in contrast to globs, which are. Don't look at me. I didn't name this stuff.
Let's see. Let's get to some. I believe there's another one like
M46. This is another open cluster in the poop deck of Argo.
We have 3.
That's a lot of poop decks.
So there's like the captain, and then there's the first mate, and then the lieutenant.
Would they all be on the poop? I didn't know you were British.
I mean, no, that's French. Whatever.
Unbelievable.
It's from playing too much.
Yeah, no, that checks out. I believe you.
The lieutenant, not the captain. But yeah,
this is M47. Have we made it, Scott? Are we there? I think we have. Scott and/or Juan. I have no idea who's out there right now. It's impossible to know. Oh, this is M46.
46, yeah.
Oh, I'm done.
Perfect.
I'm very done.
Perfect.
Just one less than M47.
Yeah. Again, a nice, beautiful open cluster. Don't know too much interesting about this one either.
A whole lot of big break blue guys.
Yeah. We're kind of in the clustery phase of things. I think the most interesting fact is that it's the poop deck of the ship.
That's pretty interesting to me.
There is.
There's a little, what is that? That's a planetary nebula. That's Planetary Nebula MGC 2438.
Hey, I'll take it. That's
So-
gorgeous.
Planetary nebulas they have nothing to do with planets. What they are in actuality is these big clouds of gas that are expelled by stars that are around the mass of our sun when they die. So what happens is there's sort of two forces keeping stars together. There is the pressure it's creating from all the energy that it's making in its center, and then there's the gravity that it has because it's made of stuff, and stuff has gravity holding it together. And stars die when one of those two forces overcomes the other one. In this case, the outwards pressure gets to be too much for the gravity to contain, so it just kind of pops like a balloon and then makes this big giant explosion. It's all the bluish stuff you can see in that planetary nebula is oxygen and ozone and stuff like that.
Beautiful rainbow coloration. All the things
They're
being
extremely
exploded.
pretty.
Yeah.
We're gonna do some fun histogram stuff here and try and tease out some more of these colors. Our camera wizards doing some camera wizardry.
Ooh, pretty.
So very nice.
So I think one of my favorite things about planetary nebulas is, you sort of have the death of a star. And those gases kind of like spread out there and seed the next generation of stars in, planetary nebula. I like the idea of it sort of being like this ancestral kind of, what do you call it? Like passing the watch off to the next generation or whatever, which I think is really cool.
No, the watch was the other cluster.
The other cluster?
Mhm.
No.
That was the watch.
I mixed them all up.
The watch was.
I'm sorry. I believe
It wasn't an actual one. It was one of our. It was one of our.
No.
Sorry. Were you actual?
No. I just like the idea of it being like this heritage of star formation.
Yeah.
That's why everyone's like, oh, they're really pretty, but oh, it's a star to look at. I like the idea of it like passing on the heavier elements to the universe, and then those being incorporated into the star fuel to create the next generation of stars out there that might have planets. Planetary nebulas leading to stars with planets. What? That's crazy.
In the long term, they do have something to do with planets. Then, what you're saying.
Yeah. Right? Big brain energy.
Not to take too much flack away from William Herschel, who was responsible for the name. He did try to call the planet Uranus George, and I think he deserves no end in his torment for that. He did.
I don't think
hand God.
I don't think it was on him. I feel like they're pressure. I don't think he was like, I'm gonna name it George. I think he probably wanted to name it Planet Herschel.
I think he did at one point want to name it Herschel also. Yeah. Which John, I don't think that's. I think if anything, that's worse.
That's fine.
I googled the wrong person's name. My brain doesn't work. It doesn't matter. Can we? That's M47. Can we go to M47? The next one, please.
M46. I really do want people in the comments to name these things for us.
Yes, I would like everyone to name these things.
It doesn't count, but you can do it.
It counts as much as those websites that say they'll let you name a star after someone. It counts exactly the same. If anything, actually, because we are a scientific institution, it counts a little more than those. Really, actually. Still nothing.
Yeah.
But it's 0 times 2.
Yeah, exactly. It's double or nothing.
It's like when my parents would tell me they'd pay me twice as much for doing the dishes, which was still 0. So this is Messier 47 now. This is another open cluster in the mildly southern constellation of Puppis, this one says. This was discovered by 3 different people separately, apparently.
Yeah.
Giovanni Battista Hodierna in 1654, and then Caroline Herschel, and then Charles Messier.
Yeah, because this is one of the lost Messier objects.
Weird.
I think we're actually going to see a couple of them, and it's because he swapped a minus sign and a plus sign, and so people are like, "There's nothing there. What? That's crazy. And what happened?" And then they would be like, "Oh, look, there's this other one over here. I found that one." So it was like re-verified by Herschel's sister. It was verified, and then later on that they realized that if you took it based on where like the pointing star he had, if you just
flip the
plus and minus, it's right there.
That's so weird.
Which is kind of cool.
That's so wild. It is about a degree away from M56, which is much older and much further away. Neat. Very neat.
It's a nice, pretty one.
Well, that's all I got on this one. How about another open cluster? We've got a whole bunch of these on the docket. Can we go to M50, please?
Oh, we have not been signing the board.
Ah! Oh no! What goblins we are. Okay, did we do 93? Did we do 93? Okay, we did 93.
Okay.
We do 46. We didn't do 46. All right, cool. M46. Yep, totally remember to do that. And then 47, and then everything's fine.
Okay.
Incredible. Go team.
Come on, comment section. Where were you?
Someone yell at us more.
Yeah. So we are moving into Messier.
As a 50?
50.
Is in Monoceros.
Yeah. The
unicorn? Yeah, it is a unicorn.
It is the unicorn.
Yeah.
You know, like Triceratops, but one,
yes,
but one Ceros instead of
just
3
the one Ceros. Yeah.
Yeah.
It is somewhat described as a heart-shaped figure or a blunt arrowhead.
You know, I guess
Why does it have to be a blunt arrowhead? That feels rude to this.
It's like kind of rounded off on the top.
Lots of arrowheads are. It doesn't mean it's blunt. It could be made of obsidian and they've like chipped it.
That's true.
How our grandparents used to do in the old days.
Obsidian leaves for this.
Yeah.
Nice scalpels. It's true.
1,000 years ago.
Yeah, so this, I mean, it's another beautiful.
It has 2 chemically peculiar stars in it. Which ones do you think are the chemically peculiar ones?
The ones with the weirdest metallicity.
You know, you've got me there, John.
Thank you. I'll be here all day.
You will be here all day.
2 of the ones on the screen.
We'll get off the stage.
Yeah, so I guess the probably not located in the horn of Monoceros, but kind of interesting to think about, like the hard Monoceros or
like that.
the
one of its eyes, maybe.
Could be, or like because the angle to it, you know,
yeah,
kind of like the angry eye of Monoceros.
It's a charging. Well, really, unicorns are rhinoceroses.
Yeah.
So you know, rhinos charge at things. That one would have to assume that. Survey says.
No.
Well, no, that's Canis Major. Okay.
Way off to the side. But that's cool.
Interesting. Okay.
Yeah. Big unicorn. Like this little.
Maybe an arrow that someone shot at the unicorn that missed and fell on the ground.
It swatted out of the sky with the horn.
Yeah. As unicorns are known to do it. Got it in the 1. Perfect. I don't think we need to worry about that anymore. But we do need to sign this thing. Yep. There we go. Perfect. Okay. So that's Messier number 50. Can I get an M48, please? Messier 48. Also known as NGC 2548. Very fun. Just put a 25 in front of it. Also in Monoceros.
Yeah.
Near Hydra's westernmost limit. I think this is another one of the. This is another one of the lost ones. Yeah.
Is it?
Yeah,
That's
it's
fine.
another one of the ones where he
Okay.
like put the wrong thing down, and then somebody else was like, and her nephew Caroline Herschel, the one who is sometimes credited for discovering it because Charles Messier can't be bothered to write numbers down correctly. So Caroline Herschel is sometimes credited as discovering it, and her nephew John Herschel wrote about it too. Lots of Herschels, evidently.
Yeah. Good for them.
Big astronomy family. Yeah. It has a tidal radius of 63.3 plus or minus 77.8 light years.
It's one of the ones that's kind of been disturbed by
Oh,
the galactic, kind of like being in the outer reaches.
interesting.
They say it's been kind of like pulled apart a little bit. It's just kind of fun. I mean, all open clusters,
Neat.
all open clusters kind of look perturbed to me. But this one is mathematically
Oh,
proven to be
Scientifically perturbed.
kind of like disrupted and broken up based on his kind of time out there.
The world was scientifically perturbed when Newton realized that everything falls at the same rate.
Not wrong.
They're not good jokes, but they
No.
are
But they are
jokes.
technically.
It's technically correct, which is the best
Yes.
kind of correct. Can I tease anything else fun out of this thing?
We've got all the clusters. They're fun in and of their
The-
own right.
The metallicity of the cluster, based on the abundance of iron, is a little bit lower than the sun. Just a bit. Touch. Less metal in it. That doesn't mean they're a little older, which is kind of interesting information. just a skosh. Shall we sign our names on Messier 54, also known as NGC 2548? Oh, this is my favorite.
What can we find?
Take us
Not a
to,
cluster, not a cluster.
take us to the bees. Bring us to
Oh.
the bees, Scott.
Yeah.
Bees time. This is to be actually helpful. This is Messier 44, also known as Praesepe, which is Latin for manger. Apparently.
That's fun.
Oh, this is the big giant open cluster in Cancer that you can sort of kind of see with your naked eye
Oh,
sometimes.
yeah.
That'd be pretty dark.
This
But
has been known
it
for
happens.
a long time. Long time. It's this little blurry thing out in
It's
Cancer.
among the first object that Galileo just studied with his telescope, apparently.
I know it's one of our closer ones to us, and we study a lot because I think a lot of them are kind of like Earth-like, or sorry, Sun-like stars. And I think they found a couple planets in it. They did.
That's really interesting.
I think they were hot Jupiters. So just,
Oh yeah, there are a lot of hot Jupiters.
but it's still
very
cool
popular planet.
around.
Well, no, it's
around-
hot actually.
Ah. Yeah, I think there were two sun-like stars out there in here that have planets, little hot Jupiter planets whipping around them, which is cool. And I think it was like one of the first ones identified like that were out there.
Yeah, this is really cool. Ancient Greeks and Romans saw this as a manger from which two donkeys that some of the Titans from the Titanomachy rode into battle were eating out of. Yeah.
This is one of the ones that you can just go on a dark night. You can just check it out. It's
Yeah.
huge. It's like the size of the moon
It's
in the sky.
this is like almost as it's not super easy to find, by which I mean all you have to do is find Cancer, and finding Cancer is the hard part. Because Cancer, all the stars in Cancer are really, really dim. So dim that they are about the same brightness as this thing.
Yeah. It's like one of those things like I don't know, whenever I see Columbury,
Oh, look, it's
kind
there.
of cool blurry
Yeah.
patch stuff.
Any of you who are Cancers, please pop off in the chat.
But Beehive is one of the ones that most people enjoy.
It's pretty.
And you can easily see some stuff in it with a tiny little hand scope or binoculars or things like that. It's a great one to check out tonight if you're kind of checking these off on your own as you can.
I also like to point out that all constellations look like bees. So,
But this is a cluster.
well, sure, but all clusters look like bees.
It's true, but this one is in the shape of a beehive, maybe.
Is that? I just always make terrible jokes about how like, oh look, it's the bees. They look like a bunch of bees because they're dots. But I don't.
No, I think it's beautiful.
It's very pretty. Don't get me wrong. No. I just think it has a funny
I don't know
name.
why you hate astronomy so much.
Because astronomers name things poorly is why I hate astronomy so much.
What would you name it?
This, Jeremy. I'd call this one Jeremy.
All right, vote in the comments.
Do you think Jeremy or the Beehive Cluster?
B for beehive, or
J for
Jeremy, or something to do with a crown, because that's my go-to.
Okay.
Oh,
yeah.
They're
Oh,
trying to show us the part that's supposed to look like a beehive.
I mean, sure, but we're seeing like a small amount of the whole actual beehive cluster. It's very pretty. It's very, very pretty.
One of the big ones. I know this is quite well studied because it's huge, and there's not a lot of things in the way. There's not a lot of debris. Or
It's also, there's some stuff that's really hard to see because it's a common orbital path for satellites. So like the Orion Nebula is really pretty and really cool, and it's very like easy to get funding to study it because people are like, oh, that's so cool, I want to know more. And it's really hard to actually do anything useful on because it's like right in the path of where geosynchronous satellites orbit. Yeah. So it's a whole thing. Extremely fun.
I can't see the chat, but I hope you're voting, and I hope you voted for
Let's
beehive.
see. Videographer experience. Videographer. I can't talk. Good Lord. Videographer experience says it's full of bees.
Yeah.
So I'm gonna say it's a vote for beehive.
Yes, the bees.
That's
what I get out of it.
Can't tell you whether or not there are actual bees in there. Who's to say?
You know,
Someone presumably.
monkeys
Not
on a
me.
typewriter.
Okay.
Did not make any.
Juan, if it's still you on the camera, can we go to Messier 67? This is also named after one of the best games for the Nintendo 64. It's called the Goldeneye Cluster.
Oh yeah.
Or the King Cobra Cluster. That's fun.
Has a lot of Earth or Sun soul-like stars in it.
Soul-like stars in it.
Like
I
kind of
believe it.
comparable to our sun.
Sure.
It's kind of fun. But yeah, it's just a big open cluster in
Apparently it's got more
in
hot
Cancer.
Jupiters too.
It's got some extra hot Jupiters.
Yeah, some hot Jupiters.
Love a hot Jupiter.
Love
It's
a hot,
cold,
big
cold
hot
winter
Jupiter.
night. You need hot. You need
Gotta have a
nice-
hot Jupiter. Nice big,
hot Jupiter.
nice big mug of hot Jupiter.
Mm.
I wonder how dense a mug of hot Jupiter. Could you put hot Jupiter in a mug? You know what I mean? Yeah.
Let's just treat it like a Fermi approximation or whatever.
Yeah, sure. Yeah, that's just make stuff up. It's fine.
Get at it. Get at the comments.
Get in the comments. Go nuts.
Audience, you calculate real fast just for us, and then
You tell
we'll know.
us.
Then we'll know the answer.
We'll figure it out.
Because you
Yeah.
told it for us.
Yeah. That's yes. Let me see. Okay, how dense is a hot Jupiter? Can Wesley operate a computer? Answer no. Okay, there's a range. Low. Their density is low.
Okay.
I have no idea what that means in this context of this Wikipedia page. I was hoping.
Right.
Yeah, I mean they have like varying densities. Like at the center, they're like hot liquid hydrogen generally, because they're usually like almost stars. But I guess at the edge they're like barely denser than void, right? Because that's what the edge is.
So then, if you were to scoop a mug,
So pull
it out, it would depressurize, and
so what you're saying is, what's the best, like how deep into a given hot Jupiter do you have to be in order to be able to put it in a mug and drink it. Regardless of whether you survive,
I
if
don't-
you can go to that layer and scoop some out in a mug and then drink it.
My argument though
And that is
when you pull it
the
out,
Sonamaker Compton limit.
you're gonna move along that PTR. When you pull it out, it's gonna
You pressurize it. You
Oh,
like
seal it.
Yeah. Oh, and that's the Sonamaker Compton limit.
yeah.
The how deep you have to go into a hot Jupiter
For a
to get a mug of it.
Perfect mug.
A perfect mug.
Perfect mug.
Hot piping mug of Jupiter. Delicious. And so can people bring their own scopes to the Godo? I wouldn't recommend it. You could bring it there. We would not let you set it up and look through it probably. Nor really would you want to. The scopes we have up there are really nice. I wouldn't worry about it. Just come on up. We got the scopes for you. They're very fun.
Yeah, we've got some great ones.
There are some really great spots near here that are really great for taking your own scopes out to. If you go out down Lake Mary Road for a while and you just pull off on one of the Lake Mary areas, you can just set your telescope up there in the parking lot. I've done it a ton of times.
Near Kendall Peak is a really good spot. Out by that trailhead. It's very, very dark out there. And there's not many cars that go by. It's
Yeah.
like by the old church off the side of the road. Like the weird looking
Oh yeah. I think somebody was telling me about that. I've been
It's a
meaning to
good
go out
spot.
there. Yeah.
spot for study. If you're up here in Flagstaff with us, congrats. You live in a great city with great dark skies.
You have chosen wisely.
Yeah. Let's see. What do we want to check out next?
What do we want to check out next?
Let's check out a galaxy.
Yes. How about M81, please?
Oh.
Oh my God, no, we didn't. Which one? 67, yes. Pink Cobra. Goldeneye. Okay, checked off. All right. Messier 81 or Bode's Galaxy? Bode's Galaxy. Bode's Galaxy.
Found by Bodes.
Just the one Bode, actually.
One Bode.
And it's his. It is his galaxy.
Mhm.
I don't know why.
Back then you could just
You just got. If you found it first, you just got it.
do that.
Yeah. Should have claimed should have claimed just everything back then. Would have been much smarter. It's originally called Bode's Object,
I mean,
which is a much funnier name.
No.
I think it's very funny. It's
Little-
a
little
spiral
weird boy.
galaxy. It's very pretty.
Yeah.
That's
Beautiful
really
little spiral. Trying to think. I feel like this one has a supermassive black hole, but I can't remember.
Probably. Apparently, very recently in February of 2022, some new stuff came out that people think it's the source of fast radio bursts.
Oh yeah. Wow, that is a pretty good image.
Yeah, that's really nice. I'll wait for Scott and/or Juan to adjust this a little bit and get it finally tuned in. But that's very pretty. You can see all the big spiral arms coming off of it. They look really, really cool.
Yeah, that's gorgeous.
Speaking of
Good job, us.
just finding things recently, yes, good job, the two of us who asked Juan and/or Scott to take this picture.
You're welcome.
Go team. Where was I going with this? I was going somewhere, probably. I don't remember. This is another Grand Design Spiral Galaxy, John.
Is it? Oh,
Yes,
nice.
apparently.
I feel like this is one of the ones that you probably, on a nice day, or a nice evening, I guess, you probably make out. You could tell that it was there with some binoculars.
6.94? Yeah, you get some binoculars.
You
Yeah,
can tell
sure.
that it's. You
Yeah.
can tell that it exists.
You could tell that there's a thing there.
Yeah.
It would look like a thing. Probably got to be a nice night. Probably have to have binoculars. I don't know if you could quite do it with your naked eye. That seems a little.
Oh. Yeah. So we've been looking at a lot of clusters, and I don't think we've looked at any. Did we look at any globulars tonight? Did they?
I think they might have. I think they did. I think one of the ones that we looked at was a globular star cluster. I was just like listening for for just what the Messier designation was.
I just know that they study a lot of the globular star clusters in this one because
Oh,
they're easy to
neato.
see.
Huh, interesting.
It's got a bunch catalog and studying.
You
It's
know.
one of those very well-defined like textbook galaxies. So
Very cool.
it's beautiful though. Man, that image is really coming out great. I'm glad we kind of rushed through the other the open clusters.
Yeah, all the open clusters. So
really-
we can
so we can,
stay
like,
on
really
this one for a
appreciate some of
while.
these
Yeah,
things.
let Scott and Juan tease out all the really good pictures of
And the
it.
next one too.
I know it's really pretty.
It was beautiful.
Speaking, I remember what I was going to say earlier. We talked about how they found a fast radio burst in this. They also found a bunch of the dark matter recently. They found where all of the like stuff that like you and I would recognize as matter, not even the like weird particles that we're still looking for, but just the like missing like atoms of hydrogen that were lying around that we couldn't find. They're in an extremely diffuse cloud of gas between all of the different galaxies called the white hot intergalactic medium, or the WIM.
Cool.
And it's such a diffuse cloud of gas that there would be like a hydrogen atom over there, like 10 feet away, and then one over here.
Oh,
And that is how spread out this cloud of gas is. But we think that's where most of the baryons are.
Clouds between the galaxies. Yeah. I always heard that that dark matter was probably space vampires.
Well, we wouldn't be able to see them with most telescopes because we use a lot of reflecting telescopes now.
Yeah.
And as everyone knows, mirrors can't see vampires. Although my supervisor, Kevin White, likes to point out that generally it's considered that you can't see vampires in mirrors because they're silvered. It used to be the way that we make mirrors, and that's not the way that we make them for telescopes anymore. So if you are a vampire or if you know one, please contact us here at Lowell so we can point a telescope at you.
You know what metal they use on those little coils? I feel like it's silver.
It's probably silver. I'm 5.
It could not.
I have
It
no
could
idea.
be something else. I've got one in my office. I mean, I don't have one.
It disappeared?
I mean, I never had it.
Stolen. Never had it in the first
I
place.
never have a Springford coating mirrors. Anyway, yeah, we can really make out a lot of details in here.
This is very, very pretty.
Yeah, I'm glad we're on the fun galaxies and stuff. Do we want to check out the other one?
Yeah, so let's we'll probably switch between this one and the next one a bit.
Oh, aluminum. Thanks. Yeah, it's aluminum, not silver.
Yes. Okay. So we don't yet know if aluminum prevents one from seeing vampires.
Yeah,
Jury is still out.
I mean, I'd argue that aluminum's just high-tech silver, right? Like we're in a modern age.
I don't know if that's true. you have I think your degree makes you more qualified to know that than mine does.
I feel like aluminum is just
spicy,
just
silver.
2022 silver. You know?
It's chrome, right? Isn't chrome like the fancy metal of the future?
Who knows?
Talking a bunch of smack about chrome now, apparently. And anti-chrome activist John Compton. This is really nice. So apparently, this and M82 and another thing called NGC 3077 are really good candidates to study how different galaxies interact with each other, because you can really easily see gravitational interactions like pulling gas away from each other.
Supposedly that's why M82 is a starburst.
Oh,
Is because
neato.
the interaction
yeah.
with
That's really cool. Huh. Would you go to M82, pretty please? Yeah.
Oh, and these are both in Ursa Major.
Yeah, but I want to give him time to get a good picture of M82 also.
We're
In
nearby
the Big Bear. Near the Big Bear.
Big Bear.
Around-ish the Big Bear. Apparently it contains the brightest pulsar yet known, M82X2, which is a very fun name.
That's the second X.
That's the second X.
That's great. I don't know if I have any particular fun lore about these in regards to Ursa Major. I do like Whirlpool, because it's kind of coming off the tail.
I'm so
as
sad.
if the tail's being flicked.
Yeah,
and it's like
we're not.
spinning
We don't
around.
get to do the Whirlpool, and I'm so upset about it, because that is my favorite. That's my favorite just thing in the sky to look at, and I'm so sad about it. It's just behind the Godot right now. We'll get to it later tonight, but we just can't yet because it's still behind the Godot. Very tragic. stay tuned in and we'll get to it later.
Stay up all night with us.
I can even hear it. When will we?
Hey, there's Cigar
Wrong
Galaxy.
number. I can't count.
Messier 82, the second of the Messier objects.
Oh, we'll get to this one pretty soon. Even this one
cigar.
we'll get to in like an hour and a half, hour or two, something like that.
Yeah.
Yes, this is the Cigar Galaxy. It looks like a cigar.
Yeah.
Hence the name. It's really cool. If we had a camera that could see in different wavelengths, we'd be able to see this weird, like, sort of splurting out energy from either side of it. That looks really, really cool. You want to talk a little bit about that? You know about that? It's really cool. Well, it's so there's that. So it's like, so there's that thing, but then like perpendicular to where it is, there are these giant bursts of stuff that it's flinging out.
Little lanes in there. We're getting some more detail kind of coming in. I don't know what this means. Anyway, but yeah, this is considered a starburst galaxy. They thought it was just a weird, irregular one for a long time. But you know, it's called a starburst because it's got a bunch of stars being born inside of it at a weird, like an extra high rate.
High rate.
And they believe that that's because of the interaction with
Neat.
So,
very cool.
With,
this is a real pretty looking thing.
Bodes.
With bodes.
It is a sweet looking, not sweet like 90s sweet, but like sweet like delightful.
It is delightful. I would agree that this is delightful.
That
Prone to frequent supernova since it's a starburst galaxy.
makes sense, right?
Lots of stuff.
You make them real fast.
Yeah.
You got a lot of stuff
Gotta
going
get rid
on
of them
there.
real fast. Just chuck them out of there.
Man, this time's blown by.
This time has gone by. This has gone very fast.
So, are there any fun last minute questions for us in the comments?
Yes. Anybody have anything interesting they want to ask us about?
At the beautiful
Stuff you want us to go back to? We
Sorry.
can't go to new objects early because I don't want to steal that from anybody. But if there's any fun questions you would like to ask, please go nuts.
4 fun names that you've created for things. I really want this to catch
Or
on.
fun names that you would like to
I
call
want
John
this to
or
catch
I,
on.
or
I want us to name all of the objects.
I can't talk about my love of the moon because I hate it.
Why do you like the moon?
It's evil and it stinks and I don't like it.
It's beautiful.
It's a horrible, awful rock. I'm not a big fan of tide pools, so I just really like for all of the mollusks and small invertebrates in those to die. Ariel wants to know what my hair routine is. Currently, my hair routine is that I haven't done anything with it because I've been so busy this week, and so it's just a big poofy mess. I have some conditioner I put in there. Got real bad dandruff, so I have a shampoo for that. What is my favorite aspect of the moon? No.
You asked the guy that hates the moon.
Wrong question.
I love the moon.
Videographer experience. Hooking up to direct current early in the mornings is a very good way to achieve this hair. Real quick. Probably more painful than getting a perm. I don't do that. This is just what my hair looks like. I just came out looking like this. Maddie, I feel like you're abusing your power as the one who gets to comment as Lowell Observatory to tell me that the moon is that you love the moon and that I'm wrong. I feel like that's I don't know what it is, but I don't like it because I am not a moon apologist, unlike some people here.
Hey, I like things of the Earth. The moon comes from the Earth. That makes it great.
The moon is mostly a big rock that smacked into
helps
us,
us,
John. So you sound very anti-Earth
The
right
moon
now.
is not a big.
There was a thing that hit us and it splatted and took.
Yeah,
some
but
moon
it came
out.
from it's parts of the
Well,
Earth that came off.
some of it is, but I
Most of
think
it.
the moon is to blame for the initial collapse in the first place. Just saying. Nothing crashed into us.
This is not how science. This
Yeah.
is not good science. This is not how science works, Wesley. We don't just get to say that we believe. Oh yeah,
We found 30 objects now. Hooray!
Did we
We're going
send
to sign our names for M81 and M82 now. There we go. Lizard on a chair. Great. Go team. Way to go, everybody. Good job.
let's see.
Oh, there's so many more comments I missed.
Probably like a minute.
Are you team heat death or team crunch? Are you team heat death or team crunch?
I'm Team Death.
You're big heat death fan.
Yeah. No, I feel like it's just yeah. You know.
Would you tell us? Would you tell people a little bit about heat death?
Oh yeah, the heat death of the universe is the idea that everything just keeps expanding until it's just everything gets cooler and cooler because there's less interaction, and that's what happens. It just kind of the whole universe just spreads out to the point, but it's not. It doesn't come back together. It just kind of like dissipates, and then everything kind of falls into its like lowest energy states until everything is equally cold and equally distributed.
My favorite thing about heat death is that currently space is about 2 Kelvin, which is 2 degrees, 2 kelvins, not degrees, but 2 kelvins above absolute zero, the like full lack of thermal energy being in a thing. Space is about 2 Kelvin, so very slightly above that. At heat death, once all of the energy that's inside stars and stuff like that gets spread out into all of the universe, it'll be at about 3 Kelvin.
Fun. Yeah.
For context, it's about 300 Kelvin where we are right now.
Being like socially awkward. I like the idea of just kind of like spreading out. It's like kind of like just meander away from this party that is the universe, and then be off on my own.
This kind of vibe.
It sounds peaceful.
Why? So why not big rip then? So heat death is sort of in the middle. That's just like if you follow the line of how statistical mechanics and thermodynamics works. Eventually, just all of the stuff wants to be in its lowest energy state, and then sort of nothing happens. The big crunch that we talked about a second ago is everything slurps back together. Eventually gravity overtakes whatever is causing the universe to expand, and we just crunch back into another singularity, and it starts the whole thing from the top. And then the third option on the other end of the spectrum is that the expansion of the universe speeds up, and the fabric of the universe is torn to shreds. And it's not that everything reaches heat death, it's just that everything is so far apart from everything else that no 2 atoms can interact with each other anymore, which is terrifying. So why not that?
Because it feels like I'm announcing my exit. It feels like I'm saying like bye everyone, like it was me, I was here the whole time, and then no, I just want to like
that's fair.
Notices.
Anyway,
what's your favorite Messier object and why?
Not the moon. Mine is M51, just because it's really, really pretty. We'll be seeing that about 10:40 tonight. I just really like M51. It's 2 galaxies sort of eating each other. George Carlisle, without the moon, we wouldn't be here. Tides are essential to life being able to transition from ocean to land. No moon, no Wes. I couldn't agree more. I hate having to look at the moon. I wouldn't be here to hate the moon if the moon wasn't here. So that's just sort of a problem that solves itself.
My favorite Messier object is one you've seen. It's Crab Nebula. Thanks. Just because it's a cool story, and then also. They believe that there's like the tidal pool that increased the rate of natural selection in early, development of life, and due to the moon as well. So
horrible, awful.
Lots of little pools flooding and then distributing and flooding and distributing.
Sounds very gross.
Yeah, I mean, yeah.
All right. Well, we're going on break, so. Yeah. This has been very fun, everyone. I'm going to go operate telescopes. We're not going to, you're being fired into the sun, yes? Yes. I mean, you're just not going to be back for the rest of the marathon. Oh, okay.
I'm not
Well,
sure what's going on.
everyone say goodbye to John. You'll see me on the plane waves in just a little bit here. Goodbye,
It was
everyone.
great. It was great to see you all. Even if none of the other people want you to name the objects, you should name
Please
the objects.
continue naming them.
Please
Yes.
continue to name the objects.
They will
for
have
me.
more validity than anyone who's ever bought a star on one of those websites. So there's that.
Language is fluid. You can call anything you want, anything you want.
Words are meaningless. Nothing is real. All words are made up. You know that? All words are made up. It's true. That's a 100% verified Wesley fact. And you can take that one to the bank. They're not telling me that we're not on anymore, and so I don't know what to do. It's 9/11. We're supposed to be out at 9:10. I'm having an existential crisis as a result of this. Say bye and wave. Bye and wave.
Oh, bye.
Hi, hello
Hi.
everybody, welcome back.
It looks like we're live. Hello, welcome back to our live stream of the Messier Marathon up here at Lowell Observatory. My name is Juan.
I'm Scott.
We're educators both here at Lowell Observatory. And yeah, we're basically running through all the Messier objects. There's a certain time of the year in March where you can observe every single Messier object in the night sky from sunset all the way to sunrise. And yeah, we're in the midst of it. I would say we're still in the beginning. We got about, 9 more hours to go, but we've seen some pretty cool stuff already. A lot of star clusters, few nebulas, and now it looks like we're on galaxy time.
So we've shot 30 of the 110 Messier objects. We're about a quarter of the way through. So far, we've seen a whole lot of open star clusters. But over this next hour or so that we're talking, we're going to be talking almost exclusively about galaxies. So we have got lots and lots of galaxies up in the Messier catalog. This one in particular is called M65. It's a galaxy in the constellation of Leo, and it's a part of the famous Leo triplet. So one other object in the Leo triplet is part of the Messier catalog, but this one is a really cool galaxy. So it's about 35 million light years away from us, which is extremely, extremely far. If you remember earlier tonight, we looked at the Andromeda Galaxy. That was only 2.5 million. And so you saw how big that thing was. It didn't even fit in the camera frame. But this one's 35 million light years away. So over 10 times as far, nearly 15 times as far away. And so it's a lot smaller in our camera. But that's kind of nice because we can see a lot more of the structure to the galaxy. So we can see the bright core of it there. It's overexposing the camera because it's just so bright. There's just billions and billions of stars in that core. Additionally, we can see some of the spiral arms kind of going around. And then there's this very cool kind of disk of interstellar dust, or I guess in this case, intergalactic dust around the edge of the galaxy there. So yeah, a very cool galaxy. Juan, do you have anything to add?
No, just keep in mind, whenever you are observing a galaxy, you are seeing something outside of our own galaxy. So every time you go outside and look up into the night sky, all of those stars, those little patches of dust are in our own galaxy, the Milky Way. The only thing you can observe outside of the Milky Way are other galaxies, and this is one of those examples. But just keep in mind, whenever you see one galaxy, you're also probably going to see multiple other galaxies. Just because in the night sky, we sometimes find these galaxies in clusters. And there's kind of a preview to our next Messier object right there. Here in a second, Wesley's going to get that centered. But this galaxy right here is one of the 3 galaxies known as the Leo triplet. So it's 3 galaxies right next to each other. 2 of them look pretty stable, and one of them looks like it's had a rough time throughout its years. And that's the next object we're going to go to, Messier object number 66.
All righty. And while Wesley is getting a picture of that, we can go ahead and sign off on M65. First object that we've gotten in a little bit. It's somewhere. It's over here.
65, yes.
M65. Cool. Very nice galaxy in Leo. But I think the next galaxy, M66, is even a little bit cooler. Once Wesley gets the picture here, and you can even pan over to M66 in this frame while we're waiting for the next one, if you would like to. Yeah, we can zoom in on that one. There's some cool stuff going on with M66. It's you can see it's a little bit different than M65, and that's because it's facing a different way. So when we look at M65, it's kind of edge on, right? We're not really seeing much of it. But when we look at M66, it's kind of facing us. And so we can see those spiral arms a lot better, and we can see this weird kind of break in its spiral arms. And Juan, do you want to tell us about that break right there?
Yeah, so exactly like Scott said, this is a spiral galaxy. You are seeing some spiral arms there, but they're weird. They're kind of deformed. There's no real symmetry to the galaxy. And this is kind of indicative that at some point in the history of this galaxy, it interacted with another galaxy, possibly one of the other siblings that you find in the Leo triplet. But what you are basically seeing are some gravitational interactions, some spreading apart of those galactic arms there. But yeah, just like Scott said, I think this is one of the prettiest galaxies that we can see up in the night sky right now.
Yeah, Yeah, and it's definitely a nice one because you could really see that definition of those spiral arms. You can really see how it's like spiraling around itself there. But yeah, one of the very nice galaxies that we have here in the Leo triplet. I don't know if we know the NGC of the other object in the Leo triplet. If we can find that real quick, but there are 3 galaxies in the Leo triplet, but Charles Messier was only able to see 2 of them with his telescope back in the 1700s. So this third one here, we'll see if we can get the NGC number. Consulting the web.
NGC 3628, if you could, please, Wesley.
Yeah, 3628. Yeah.
More galaxies.
So yeah, so all 3 of these galaxies are right next to each other in the constellation of Leo, which is of course a giant lion up in our night sky. If you're in the northern hemisphere and it's nighttime, go take a look outside right now and see if you could see Leo. It's definitely one of the cool ones. There we go.
Yep, we got 65 and 66 right next to each other. They're pretty.
And we'll see if we can get this other one right here. So got a few more seconds on our exposure time, and let's see. There it is. Yeah, so you can see how this one's a lot fainter than those other 2, and that's probably why Charles Messier wasn't able to see this one with his telescope. It's just not as bright. And one of the reasons it's not as bright is because it has that very thick band of dust through the middle of it, and it's kind of edge on, so it's really obstructing a lot of the light that this galaxy gives off, and all those billions of stars that are shining in there, a lot of their light's just getting cut out by that very thick band of dust that we've got in the middle there. But yeah, definitely a very nice galaxy, and again about 30 million light years away from us. Just the same as those other 2 galaxies in the Leo triplet, M65 and M66.
Well,
yeah, so we got 66. Yeah, I'd say we got it.
Yeah, cool.
Go ahead and sign that one off.
That one off.
Yeah, we're really blowing through these
Yeah,
now.
yeah. I love these markers. They're like shiny. I don't know. I guess I just like shiny things.
Name in gold.
I got silver. Juan's got gold.
Alrighty. So next Messier object, we're gonna stick with the galaxies. We like the galaxies, but the next one is Messier object number 95.
Yeah, so this is yet another galaxy in the constellation of Leo. So as I mentioned at the beginning, we're shooting a lot of galaxies on this little part of the Messier Marathon. And yeah, this is just another galaxy. Again, about the same distance as the ones in the Leo triplet, about 30 million light years away. And it's, just a very nice galaxy that Wesley can try and shoot for us here.
Just like how we were kind of talked about before, how we found 3 galaxies right next to each other. Like I said, oftentimes you see a lot of galaxies next to each other in space. They're found in these galactic clusters, kind of like how we were talking about star clusters. Mm-hmm. Those were pretty common in our galaxy, but once you start looking outside of our galaxy, you start to see clusters of galaxies, mm-hmm. not stars. So Messier object 95, it's a barred spiral galaxy. And it is one of 21 confirmed galaxies. In our telescope, we'll be able to pick up, the major prominent ones like M95 and the next one coming up. But some of those stars that you are seeing on your screen right now might not even be stars. They are probably galaxies in themselves.
Yeah, some of those really faint ones in the background, those might not be stars at all. Those might be galaxies that belong to this one cluster of 21 galaxies. And ooh, we got a nice picture there from Wesley. Kind of looks like I don't know if those of you that have seen Star Wars, the like hyper rings that they have in Star Wars that like shoot ships through hyperspace, it almost looks like one of those. But yeah, this is definitely a very nice galaxy. M95, correct?
M95, yeah. Yes. And it's got this weird shape. It's almost got like a bar right across the center of the galaxy. And what we think that is all this deep nebulosity embedded in the galaxy where there's a lot of star formation happening. So Hubble's got a really pretty image of this one. Wesley's doing an amazing job right now. It is a fainter galaxy right now, but that's neat.
I don't know. Do you say we saw that one?
Yeah, I think we saw M95, so we can go ahead and mark this one off.
All right.
And let's see where we're at. M90, it's over here, M95.
Oh, look at it now. Yeah, it's coming in better.
Oh
and better.
yeah, that's nice. See if we can get a real nice picture of M95 here before we move on to the next object.
Let Wesley work his magic on the screen.
Yeah, yeah. So yeah, you guys have probably noticed, in Messier's catalog, there are a lot of galaxies and star clusters. And back when Messier was, making this catalog, he didn't really distinguish very well between the two of them. Through a small telescope or through a telescope like Charles Messier was using, these galaxies and these star clusters looked remarkably similar to each other. And the fact that they were just kind of like fuzzy little blobs in his telescope. He couldn't really resolve too many of the details. And, that's why Charles Messier charted them down. They were little interesting things in the night sky that he wanted to distinguish from what he was actually looking for, which we've mentioned earlier, but we'll repeat again tonight. He was actually looking for comets. And comets in the night sky are fuzzy blobs. And all of the things in the Messier catalog through a small telescope look like fuzzy blobs. So Charles Messier was really trying to rule out a lot of these fuzzy blobs. So when he was looking for comets, he knew whether he had looked at this object before or not. So, and then of course, nowadays we don't really use this catalog for comets anymore, but we do use it to look up some of the most amazing things in the night sky, because these are bright enough for someone in the 1700s to have seen. And especially through a telescope like we have here up at Lowell Observatory, we can really see a lot of the beauty and detail that maybe was missing to Charles Messier, but that astronomers have been studying for a very long time, since his days.
Right.
Yeah.
So, you're saying catalog, Messier numbers, something, NGC, blah, blah, blah. All of these are just numbers that we put under catalogs.
And Wesley, just a word of advice for the curve, just click on the middle and drag it up. So that'll kind of give you the best of the pure stretching, is grabbing the middle and bringing it up. But yeah, you're doing a great job there. You can really see a lot of that barred spiralness of this galaxy, as well as you can even see a little bit of the faint arms around the edges, just outside of that main ring, which is very nice job. Yeah, so I think we can go ahead and move on to our next object here, which is, surprise, surprise, another galaxy in Leo. Do you want to tell us about this one, Juan?
Yes, next one is Messier number 96. It is another galaxy, a spiral galaxy in the constellation Leo. And this one is kind of a companion to the last galaxy that we saw. It is in the same group of galaxies. We got one other coming up after this one that's in the same group. But this one's another special one, kind of like M66 like we just saw. We're going to let it come in. And it's different. Every galaxy is different from one another, just like how every single person on Earth is different from one another. They're all kind of got their own little characteristics and quirks about them that make them all a little special. That's what makes us special. We got our little quirks.
Yeah. Everyone's different.
But yeah.
We all got our own beauty, right?
That's right.
So yeah.
Just letting that one come in.
Here we go. That looks pretty good. So yeah, so you can see how this one, it's on a slightly different orientation from the other galaxies we've seen. This one's not quite straight on, but it's not quite perpendicular to us either. So it's kind of at an angle here. And you can kind of, see these spiral arms of this galaxy as well. So fine, shoot it here.
And as Wesley starts to get more and more detail, and we'll start to see those arms kind of pop out. And like I said, this is like Messier 66, that one galaxy with these irregular spiral arms. So a lot of these arms are actually deformed. The galaxy itself is not symmetrical. One arm is kind of get ripped around the other part, the other one's kind of stretching around the other galaxy. So we think this galaxy might have actually gone around one of these other galaxies and had some gravitational interaction. And Wesley's kind of showing that in there.
Yeah, he's pointing out the arms there for us.
He's getting more and more detail for us. But yeah, these galaxies, they're far away. They're something like 30 31 million light years away from us. Andromeda was only 2.5 million light years away for us. So much, much, much further away. That's why we don't fill up the whole screen of view, but you know, you really see all the detail with these smaller galaxies.
Yeah, there we go. A nice shot of the galaxy here. Ooh. Yeah, it's a very nice photo. Oh, we have a question from Paulette. Are you going to do long exposures of these objects tonight? The short answer to that is no. We have 110 objects to shoot over the course of the whole night, so we really can't spend that much time on each one. However, we do actually have 2 instrumentation scopes up here at Lowell Observatory. So the one that we're using right now, it's great for these shorter exposures, you know, less than 5 minutes of exposure time shooting these objects, and get a lot of good details that way. But we have another instrumentation scope. It's another plane wave telescope, but this one is a little bit bigger. It's 17 inches in diameter. And on that telescope, we actually have a CCD camera, which is a little fancier in the astronomy world. And that telescope also has a whole bunch of different instruments on it. So it has a spectrometer, it has a filter wheel, and so you're able to do a whole lot more stuff with that telescope. And that telescope is currently imaging a couple different Messier objects. One at a time, of course. I think they're doing about half an hour on each thing they choose to target. But we won't be able to see what those pictures look like probably until tomorrow at the absolute earliest, because once we take those pictures, we have to combine them and work with them in an editing program. And it's just a lot more time consuming of a task to get these long, beautiful exposures of stuff in our night sky. So yeah, great question.
Question while Wesley works on this. Question from Videographer Experience. I wonder if you're trying to keep the catalog at 100. I also kind of wish it was 111 objects, but I don't know which one not in the Messier I would like to add. Does anyone have a candidate? Okay, so I don't know if there's been any conversations of them adding to his catalog. I do know there has been conversations of possibly removing some, and we're going to show you a Messier object later that was in this conversation. But no, you know, Messier, I think he only did 100. Am I right?
Yeah, the Messier catalog that we have today was not the same Messier catalog that was originally published. Messier published his catalog, and then he found some more stuff, and he republished it. And then after his death, I believe, other people kind of saw some more objects and added them to his catalog, or they looked through his notes and saw new things that he didn't include, but decided that should be in there. For example, I think at least one of the dwarf galaxies around Andromeda was added later, after Charles Messier had already, you know, published it for himself. As for objects that should be in the Messier catalog, oh boy, there's so many beautiful Messier objects, or sorry, so many beautiful objects up in the night sky. I think one that I would include is the Veil Nebula. It's probably too faint to see through really any telescope, but it's an absolutely beautiful object to photograph, and it takes up a large portion of our night sky. So I think if we were to add anything, I would add the Veil Nebula to the Messier list, but that's just me.
One thing to kind of keep in mind, though, is that Messier was observing from France. So all the things he saw were visible from the Northern Hemisphere. So it wouldn't really make sense if we added some things in there that wouldn't be visible for the Northern Hemisphere. I know Veil, it definitely is, but that's why, you know, all the Messier objects look like they're in the same latitude of the night sky.
Yeah, I don't know. I think I'd have to disagree with you a little bit on that one. I think it would be great if we could include some Southern Hemisphere objects into the Messier catalog, like the Magellanic Clouds. I know there's some absolutely beautiful nebulas in the Southern Hemisphere, and I think it would be great to include those as well. Of course, then we couldn't shoot them all in a single night, but oh well.
We should start a new catalog.
We should start a new catalog.
The Lowell catalog.
Lowell
LC. How about that?
Yeah. All right. We'll send that to marketing, and they'll tell us if we can do that.
We'll get T-shirts. How about that?
We'll get T-shirts. Yes. So I think we can go ahead and sign off on M96 now. There it is.
Awesome. And that's a beautiful picture, Wesley.
Yeah, that's a fantastic picture. You really brought out a lot of that detail and a little bit of that, even that interstellar dust that's kind of going through it. But yeah, so next we're going to go over to yet another galaxy, M105, which is, I'll let you guys guess which constellation this is in. And yeah, it's in Leo. This is yet another galaxy in the constellation of Leo. But we'll get a good picture of that here. And again, this one is also about 30 million light years away. So, you know, all these Leo galaxies, they are all just kind of part of the same kind of cluster out in space. So yeah, it's a lot of great objects to shoot. And it looks like marketing approves of this idea to make a Lowell catalog. So I guess we'll talk about it and see where that goes. But yeah, ooh, here we go. Looks like we got a whole bunch of galaxies in this one. The Messier object M105 is that brightest one. It's like the fuzzy circle. Yep, that one that Wesley just moused over there. That's M105. And then there's also these other little galaxies in the group itself. So
yeah, and this is just another one of those galaxies in the same cluster of the last two we just saw. I mentioned there's 21 confirmed galaxies in this cluster. So, you know, there's a lot of galaxies, and just with this one little field of view, it's an awesome object to go outside and try to find yourself.
if you can, good luck. You probably need a pretty big telescope to see this one, but I can see it here, so I'm going to go ahead and mark it off.
There we go. Yeah.
M105, right in the corner where I can. Yeah. See if I can. Yeah, a little better.
But yeah, this galaxy is a little bit different from all the other ones we just saw. This one is an elliptical galaxy. So we kind of just categorize galaxies based off their shape. They're either spiraled, elliptical, or the weird looking one. I always forget that one. Irregular. Irregular.
Yeah, yes. Weird looking, irregular.
Funny, yeah, funny guy. And this one's elliptical. It's a really bright one right there. So you're actually seeing billions of stars. So much so that they're just overexposing the center of the galaxy. Even the Hubble space image that they took of this galaxy looks blown out just because there's so much stars in this galaxy.
I'd say I prefer this picture to the Hubble one. So I think we're doing better than Hubble in that respect. So if NASA wants good pictures of M105, they should talk to us.
Yes.
But yeah, so I think we can go ahead and move along to another object. This one is not a galaxy. It is also very strange in the catalog. This is going to be M40, otherwise known as Winnicky 4. And this is very different than everything else we've seen tonight. So we've seen open star clusters, we've seen globular star clusters, we've seen planetary nebula, reflection nebula, emission nebula, we've seen galaxies. This is an optical double, which is very weird.
What do you mean by an optical double?
An optical double are two stars that look like they're right next to each other, but in reality, they are very far apart. So let's see. I've never actually imaged this with the Malin cam, but I have to assume that it's these two stars right here. That does look very what I would expect from this optical double. But what's cool about it is, you know, when we look up in the night sky, there's all these stars. And a lot of these stars are actually binary systems. So it's when we see one star, we're not actually looking at one. We're looking at maybe 2 or 3 stars that are all orbiting kind of around each other in the night sky. And that what makes up a binary or a triplet system. And what we're looking at here is not that. This is an optical double. So it just looks like these two stars are next to each other. Now, this is a bit weird because we mentioned earlier that Charles Messier was looking for comets, and comets look like fuzzy blobs. And this is not a fuzzy blob at all. And kind of what happened here was someone had told Charles Messier that there was some like nebulosity or some kind of cloudiness in the night sky up in Ursa Major, the Big Dipper. And Charles Messier tried to find this stuff for himself. He looked up in the Big Dipper with his telescope, and he saw these two stars and said, they look fuzzy to me, and put it in his catalog. Later astronomers took another look at these guys and they said, well, there's nothing here. It's just stars. So this is definitely an odd thing out in the Messier catalog. But what's cool about it is the debate whether these stars were binary or optical doubles, went on for a long time. And it took a while for the technology of astronomers to catch up to actually determine whether this was an optical or a binary system. And we actually concluded that this was an optical system thanks to contributions from here at Lowell. So we have a Lowell astronomer by the name of Brian Skiff, and he actually helped provide some of the data to another astronomer called Richard Nugent, who wrote a paper who kind of definitively said that this system was not a binary system. And the data that they used to determine this is a little outdated. We have much better data nowadays, but pretty much they looked at the two different things. They looked at the parallax of these stars. And what that means is they kind of looked to see how these stars moved as the Earth went around the sun. So you can do this yourself at home, but pretty much, hold your thumb out in front of you and then close one eye and then switch eyes and kind of blink between your two eyes and see how your thumb moves. In the background, it looks like your thumb is like shifting left and right. And what's cool is using trigonometry, you can actually measure the distance to your thumb if you know the distance between your eyes and the angle that your thumb is moving. And so pretty much you can do parallax on these two stars as the Earth, is on one side of the sun and then the other side of the sun, and more or less determine how far away they are. And what they determined was that these two stars were actually about twice as far away. So one of these stars is about 500 light years away, more or less, and the other one's about 1,000 light years away. Now, that in itself is a huge difference. It's, there's no binary system that is, 500 light years across. That's just, the stars are not nearly big enough to do that. For instance, our closest neighbor star is 3 light years away from us. And, we're clearly not in a binary with it. But additionally, the other thing they looked at is how these stars were moving in the night sky relative to each other. And they're actually kind of moving in opposite directions. And the fact that they're moving in opposite directions pretty much confirms that this is actually an optical double and not, a binary system. So I know I've been talking a lot about binary systems. So Juan, do you have anything to input here?
No, I think you did a pretty great job. Like you said, this is something somewhere in the night sky that Messier looked at. This is where he pointed his telescope because someone said there was a little fuzzy patch in the night sky. He didn't find it, but he still put it down in his catalog. And like Scott said, this was different from everything else. So it really goes to show that Messier didn't really care about what was in his catalog. He was trying to find these comets. So much so that he left this optical double star in his list. And this was the one that I said that there has been debates about possibly removing it from the Messier catalog. But, we're so far down the line of when Messier originally made this. It's one of the original ones, so we kept it in there, but there it is.
So, yeah, go ahead and sign that one off. M40. Let's see, where's 40? It's over there. 40, all righty. It's the only picture with 2 stars in it.
Yeah, there's 2 stars.
2 little stars.
Cool.
All right, so I believe we have one more object to talk about here before we go on break again, but that is M97, otherwise known as the Owl Nebula. And I'll let Juan talk about this one because I kind of talked a lot in the last one. And I'll give you a chance to speak.
But this is the second planetary nebula that we see tonight. Technically the third because we saw one in that star cluster earlier.
Yes, we saw the Little Dumbbell Nebula, which was part of the Messier catalog. I don't remember which number. And then we also saw M46, which was a star cluster that just happened to have a planetary nebula in it. But this is a planetary nebula all on its own. So Juan, take it away.
Yeah, so this one is also known as the Owl Nebula. Those little points that you see in there are supposed to be the eyes of the owl. At least that's what the guy thought when he originally discovered it. The drawings that he made looked like an owl. Once we started getting some actual photography on it, it looked less and less like an owl, but we stick with the names that these astronomers originally gave it with. But yes, these objects in the night sky are great examples of what is going to happen to our sun here in the future. So planetary nebulas are the endpoint of the life cycle for stars that are really similar to our sun. stars that are about the same size as our sun or 10 times smaller at least, they reach the end of their life cycles and they go through an event called a planetary nebula. And this is different from those supernovas that we saw earlier, like in the Crab Nebula. A Crab Nebula was a big explosion, or the supernova is a big explosion in the night sky. You have a bright flash of light, and then all of the gas that made up the star basically gets shot out into space. But for planetary nebulas like this Owl Nebula right here, you are basically seeing the layers of the star that have been kind of let go softly, not violently, not like these huge explosions. The way I always kind of like to think about it is kind of like a bath bomb. You know, sometimes when I interacted with a lot of guests and I'm just drained at night, I go run a nice hot bath and throw the bath bomb in there. And you kind of just see it fizzle out. Yes, exactly. And that's exactly what happens with these stars. Layer by layer, kind of like an onion, you see the gas that originally comprised this star kind of fizzle out. So what you are seeing there is those layers of the sun. If we had a little bit more time to get some more exposure in here, we'd be able to get more color. And the first color that you would see around this object would be red, because that's primarily what the main fuel of what the star was made out of, hydrogen and helium. Those are the colors that are associated with those colors in the night sky.
Yeah, we often see this kind of red hydrogen right around like the edges of these planetary nebula, because again, that is kind of like what the outermost layer of the star is this hydrogen that kind of breaks off and goes out into space. But additionally, there's this bluish green, and that's what kind of makes up most of the nebula, and that is primarily oxygen gas. I don't know that we can breathe it, but most of this blue stuff that we're seeing in here is actually oxygen gas, and it's going through a process called ionization. So the little star that's right in the middle of it, the white dwarf star that's left over after this, after this star sheds its outer layers, this little white dwarf that's left over, it's still extremely hot. You know, we can think about stars as, being different temperatures, and kind of the temperatures are very similar to the temperatures of fire. So you kind of have like red fire is kind of cooler, and then you have like blue fire is very hot, and white is like super, super hot. And so this super, super hot star is lighting up all this gas and making it so hot that the gas glows, called ionization. And, it's lighting up all of this oxygen for us to see. And then I don't know if we can really get a little bit of the red around the edges. We'd have to boost the saturation, maybe try for a longer exposure. I'm not really seeing too much of the red, but there will be some very nice planetary nebulas later tonight that you'll definitely be able to see that red around. In particular, the Ring Nebula looks very nice. It's got this, beautiful kind of blue-green in the middle and this beautiful red around the edges. And then additionally, there's the Big Dumbbell Nebula. So the opposite of the little dumbbell, the big dumbbell, it is often called the Apple Core Nebula because it has this very beautiful red on kind of either side of it, and then this, beautiful stuff going through the middle. But yeah, so there's lots of cool stuff coming up tonight. I think we've got a few more minutes here, 5 more minutes. Are there any objects that we want to jump to in this time before we list off all the Messier objects we've seen so far tonight?
We got a question really quick. So we got someone out there asking that if these planetary nebulas are like star farts. What do you got to say about that?
I suppose, but it would be like if your entire body was letting off the fart rather than just one part of you. So maybe it's kind of like body odor. I don't know how much we should talk about this, but I think I like the bath bomb, simile metaphor better than that, but it's definitely a fun one to think about. But yeah, so got lots more Messier objects to shoot here tonight. What are we at? Like 40? How many Messier objects have we shot so far? Does anyone know? 37 objects. So we're slowly but surely making our way towards 110. These are the last objects that Juan and I are gonna talk about here tonight. We're gonna go. Well, Juan's gonna go. He's going home. He's gonna play some video games and have a good night. I get to stay up here and be in the cold and operate some telescopes, which I am prepared to do. But yeah, lots more stuff. We're going to be up here till 6 a.m. I won't be. and then we'll on. But some poor soul will have to be here till 6 a.m. We have another question. Is there a Titan in there somewhere in that system? I'm not sure I understand the question.
Titan from like Attack on Titans, or
Titan, the planet, or the giant?
Titan, the
or
Greek monster.
The Greek monster.
What type of Titan?
There's lots of
were you
Titans.
thinking? Yeah.
Titan from the movie Megamind.
Remembers the
starring
Titans.
Will Ferrell. Remember the Titans?
Yes.
Yeah, the football team.
Not really sure what you meant by that
Yeah,
question.
I'm not sure which Titan you talked about there, but I don't know. Maybe. But yeah, so
I've got a little bit more time to kill.
Hydrocarbons. Do you maybe mean like the moon Titan that goes around Saturn? I believe the moon Titan has some atmosphere around it that might have hydrocarbons. I don't know too much. I don't know too much about the moon Titan, but sorry, but yeah, there's lots of stuff I do know about, but that's just not one of them.
So it looks like we're going to take a break a little bit early and give enough time for a special presenter.
Oh, you're making a joke. All right, sorry, the joke just whooshed right over our heads. But yeah, we'll go ahead and call it a night. We've seen 37 objects. Thank you, Wesley, for bearing the cold during all that. You got some very nice pictures. Yeah.
Well, thank you very much.
Yeah, thank you very much. We're going to sign off. You guys have a good night.
Hey, good evening, everybody. Welcome to the Messier Marathon. My name is Bill Ferris, and I'm really thankful for the opportunity to speak with you tonight about my experience running the Messier Marathon a few times. I'm a longtime astronomy enthusiast from the early 1990s through the mid-2000s. I was active using 10-inch and 18-inch telescopes to observe and sketch every object in the Messier catalog, the Herschel 400 list, as well as hundreds of other faint little stinkers, as I call them, nebulae and star clusters and galaxies. I even worked a couple of years as a telescope operator for Lowell Observatory on their near-Earth object search. By now, you probably know at least a little bit about Charles Messier, a French astronomer who did most of his work searching for and observing comets from the 1750s through the 1780s. He observed and searched for comets from the Hotel de Cluny in Paris, France. And while doing so, Messier occasionally came across objects that looked like comets, but they never moved from their positions amongst the stars, and comets move. And so in short, these objects that Messier was finding, they looked like comets, but they weren't comets. And as explained in this quote from his writings, Messier was inspired to seek out and catalog these stationary, nebulous objects so that other astronomers would not be distracted by them, whilst these other astronomers also were hunting for comets. So today we know Messier's catalog of non-comets is 110 of the most spectacular deep sky objects. These are star clusters, nebulae, and galaxies that are visible from in the night sky from our northern hemisphere location. So what is a Messier Marathon? Very simply, a Messier Marathon is attempting to observe all the Messier objects in a single night. And how is it possible? How is it possible to do this? Well, when spring arrives in the northern hemisphere, the sun is in the constellation Pisces, and that just happens to coincide with a gap in the distribution of Messier objects in the night sky. So here we can see two objects, two galaxies, M74 and M77 to the left or to the east of the sun. And they set soon after the sun does on a March evening. And over here to the right, we can also see several objects, including globular star clusters, M2, M15, and way down here, M30, to the right or to the west of the sun. And they rise shortly before the sun in March. And this open space where there are no Messier objects, that means the sun's brightness isn't preventing us from being able to see these distant celestial treasures. As a result, it's possible for observers from generally more southerly latitudes, Arizona, for example, where Lowell Observatory is located, to observe all 110 Messier objects in a single night from sunset to sunrise the following morning. And this is the Messier Marathon. And what are the biggest challenges to observing all 110? Going beyond just the challenge of staying up all night to observe them? Well, in the evening, when the sun has slipped below the western horizon, the Messier objects nearest the sun can only be seen in a twilight sky. The sky will not be fully dark. And so, for instance, this galaxy M74 is considered the most difficult of the Messier objects to observe in the evening sky because it sets so soon after the sun and it's seen against a brighter sky, as well as M33, a galaxy in Triangulum, and M31 and its satellite galaxies. These are also a bit sporty to observe against the twilight sky. In the morning, we have similar challenges. At the end of the night, when you're exhausted and the eastern sky is brightening in advance of the rising sun, the most difficult object is a globular cluster M30, and it's hidden by trees in this illustration. So let's take the trees away, and here's M30 just barely skirting the southeastern horizon with no obstructions blocking our view. And so what this illustrates is that one of the most important advantages to any amateur astronomer trying a Messier Marathon is to have at your disposal, one, a dark sky observing site miles from the nearest city, and also unobstructed views to the northwest and southeast. And in 2001, over 20 years ago, I successfully observed all 110 Messier objects on back-to-back nights while attending the All Arizona Messier Marathon. And what follows in my presentation is the observing order and timetable I used that weekend and would be using tonight if I were doing a marathon. So we start the night by going after the brightest, easiest to find Messier objects, picking off the Pleiades Open Star Cluster M45, the Orion Nebula M42 and M43, well before the skies become fully dark. And I should mention just before I go any further that the sketches you'll see, and I have sketches of every Messier object in this presentation, were all made observing with a 10-inch Newtonian reflector telescope. But after these early bright objects, we tick off a series of open star clusters, M103, M52, M34, along with this small bright planetary nebula, M76, known as the Little Dumbbell Nebula. And we'd finish off our first 45 minutes at the eyepiece going after some galaxies, M31 with its 2 satellite galaxies, M33 in Triangulum, M77 and M74, that most difficult of the evening Messier objects. By 8:30 at night, the sky's almost fully dark and the observing gets much easier to see these faint objects. From now until about 4 o'clock in the morning, it's just a matter of tracking down, viewing, and checking off all the targets. Sounds pretty easy, right? So early in the evening, we spend most of our time in winter constellations, which are home to a wonderful selection of star clusters and nebulae. And this group includes M1, a supernova remnant in Taurus, the remnant of an exploding star. And that was the first non-cometary object that Messier encountered, the one that started it all. M79 is a globular star cluster in Lepus, M78, a reflection nebula in the constellation Orion. Now, M38 in Auriga and M46 in Puppis both share the field with other deep sky objects. So there's a small open star cluster, NGC 1907, that shares the field with M38. And in M46, we see the planetary nebula NGC 2438, sharing the field with that object. By 9:30 in the evening, the hunt moves into spring constellations, which are populated by galaxies and occasionally globular star clusters. So the list includes several northern hemisphere gems such as M65 and M66. These are galaxies that, along with NGC 3628, are known as the Leo triplet. They are in the constellation Leo. M81 and M82 are galaxies in Ursa Major, the Big Dipper. M97 is a planetary nebula known as the Owl Nebula, also in the Big Dipper. And M101 and M51 we're back to galaxies also in the vicinity of the Big Dipper. The odd person out in this group, as you may have heard just before the previous observing team went on break, is M40, a double star, and it's a boring object, let me say. If you like galaxies and star clusters, a double star like this, it's nothing much to look at. And some folks don't even acknowledge this as a legitimate Messier object. However, he did observe and measure a position for it. And my thinking is, if it's good enough for Chuck, it's good enough for me. So the clock is approaching midnight and we're still in the hunt for galaxies. M84 and M86 are 2 bright elliptical galaxies in the constellation Virgo. And these are the brightest members of a string of galaxies that are known as Markarian's chain. There are at least 16 bright galaxies in this group within reach of an 8-inch amateur telescope. Also, we have M104. Let's talk about M104 a second. It's known as the Sombrero Galaxy. It's also in Virgo. And a careful observation through an amateur telescope, you might notice a dark lane bisecting the northern and southern sections of this galaxy. And you can see similar structure when observing our very own summer Milky Way, a dark lane of interstellar dust bisecting a bright band of light. Hey, guess what? If you made it this far to midnight and through all those objects, you have time for a break. You can take up to a 2-hour nap and not miss any objects. So get some rest, gather your observing charts. The final sprint is going to be filled with a host of night sky jewels, such as when we get back to it at 2 o'clock in the morning, back from our break, the marathon has entered the summer constellations, home to brilliant nebulae and star clusters. M13, the great globular star cluster in Hercules, arguably the most magnificent such object that's visible in our northern sky. M57, the Ring Nebula, planetary nebula, and a preview of our sun's ultimate fate when the sun has exhausted its supply of hydrogen. Radiation pressure from the core will cause the outer layers to slough off and expand, and from a distance, it might appear to some alien observer as a ring-shaped nebula with a faint stellar core at the center. M27 is also a planetary nebula. It's known as the Dumbbell Nebula. And this list includes several impressive globular star clusters. The member stars of these clusters are thought to be the oldest known stars in the galaxy, many having formed billions of years, billions with a B of years before the sun even formed. Now, among the bright emission and reflection nebula found within the summer constellations are M16, the Eagle Nebula in Serpens, M17, the Swan Nebula in Sagittarius, M20, the Trifid Nebula, and M8, the Lagoon Nebula, both also in Sagittarius, and M22 among the brilliant globular star clusters visible in this part of the sky. It's also in Sagittarius, which is also known as the tea kettle. And by 4 a.m., we're ready to finish off the hunt to get the last 5 of Messier's 110 non-comets. And this last group of 5 celestial treasures includes 4 globular star clusters and M73. Like M40, M73 is just a stellar grouping, 4 stars to be exact. Messier described it as such, charted its position, and included this small cluster in his 1781 catalog, which included objects 46 through 103. And last on the list is M30. It's the most challenging of the group because of its proximity to the rising sun. When I ran my 2 complete Messier marathons in 2001, I started the search for M30 in Capricornus. I started at a bright star, used my finder scope, and I slew the number of fields I knew I needed to go to get to where M30 should be, and I was looking at distant mountains. I had to wait about 5 minutes for the cluster to rise above the horizon until I could barely make it out against a brightening early morning twilight sky, then check it off my list and finish the marathon. So why do a marathon? Why do this all-night observing session? Well, it's fun for the challenge of it. Sometimes pushing yourself can be a little bit of fun. Develops your observing skills, your ability to operate and use your telescope and detect faint objects. There's camaraderie in it if you're able to recruit some friends to join you for a night out under the star, and you'll see some absolutely fantastic objects. Now, if you're not up for the all-night session, why not make it a mini marathon? Go out for a few hours or maybe a half night and observe as many of these objects as you're able. If you don't have a telescope, or maybe you've observed all these objects with a telescope, try it with binoculars. See how many of these are visible to you in a pair of 10 by 50 binoculars. Do an imaging marathon. Set up a camera on your telescope and make images, as Lowell Observatory is doing tonight, of these celestial masterpieces. Or do it from memory. Maybe you've been observing so long and seen these objects so many times, you know how to get to each and every one. These are the ways that you might enjoy doing a Messier marathon. And so I'm going to go ahead and stop sharing my screen. If you have any questions, I'd be happy to answer those. And otherwise, I might get back to the observing. But thank you for listening and watching. Thank you.
right. Well, we are back live from the marathon side. We now have a set of new, fresh faces. My name is Matt, and
I'm Angel.
In addition to us, we have two new telescope operators as well. We have Gavin and Dylan, who are going to be finding all of these awesome objects for us. So the first object we're going to go to is an object known as Messier 108, or the Surfboard Galaxy. So
Surfboard. I'm excited for this one. I've never seen it through the telescope before. So let's go to M108. Check out this surfboard. And this is going to be a barred spiral galaxy. We're going to start out with some objects in Ursa Major. This one has a kind of central bar shape. Might not be able to pick it up in this immediate exposure, but you can see our operators are circling the center there. You can see it's more of like an elongated shape, hence the surfboard name, which is kind of cute. I like it.
yeah, this object is 46 million light years from Earth. It's always hard to comprehend that the light we're getting from this is from 46 million years ago, essentially looking back in time.
This one's just about 110,000 light years across, so just a little bit bigger than our Milky Way galaxy. So it takes light 110,000 years from one side to the other, across the whole galaxy like that. This galaxy contains about 400 billion stars, which is a lot of stars, I think. It's too many, I think, but still super cool. So you can see playing with the exposure time there, getting some more detail with the gas and dust in there as well. And this object has a black hole in the center that's about 24 million solar masses, or it's about 6 to 8 times the mass of our black hole in the center of the Milky Way galaxy. So significantly larger, which is super cool.
Yeah, and as they play around with the setting, we can see more features in the galaxy itself. Nice job, Dylan and Gavin.
That looks good.
It's pretty good.
Yeah, this one's so cool. Never seen it.
Yeah, when we were taking notes for this, we noted that a lot of the galaxies and objects in the Messier catalog didn't actually have names. This is one of the few ones that actually comes with a name.
I think we should just start naming them ourselves.
Yeah, that might be
Yeah.
something we can do through our portion of this, is to come up with new names for each, and we would love suggestions for names as well.
Put them in the chat.
All right, I think this was a successful image. Let's mark it up.
Oh yeah, I keep forgetting we get to do that. Okay,
M108 at the very end of the catalog.
There you go. So official.
Yeah. All right. The next object we have on our list is Messier Object 109, which is also a barred spiral galaxy, very similar to the Surfboard Galaxy that we just imaged.
This one did not have a fun name, so first thing that comes to mind when you see it, that's what it's going to be named, I think. This one is, you said, also an Ursa Major. This is one of the faintest Messier objects, so we'll see what can come through on the Malin cam right now, but we should still be able to get a little something in there at least.
Yeah, so they might have to do some adjustments when taking this image, because yeah, it is one of the fainter objects. They might have to adjust the time.
This one is about 60 million light years away. So further than the last one, M108, 180,000 light years across, so significantly larger than the last one, almost twice the size of the Milky Way. Oh, whoa, that's awesome. A lot better than I was expecting. All right. Nice.
Yeah, so this, if we compare this to the Surfboard Galaxy, the Surfboard was very much edge on. We couldn't see a lot of the actual spiral structure because we were looking at the side of the galaxy. But in this case, This is a lot more face on, and because of this, we can see the really cool spiral structure in it. And we can also see this really nice bar in the center. So spiral galaxies can have a couple of different structures. If we look at the center of this, I don't know if this will show, I think it will. We can see this bar-like structure in the center.
Nice.
Yeah.
That's a good one.
Yeah.
I like it.
Sometimes spiral galaxies won't have this bar, and thus they won't be called barred spiral galaxies. This one has this nice bar, and then it has these two really nice spiral arms coming off of it.
Yeah, very distinct. First thing that came to mind for me was this kind of name, Vortex.
Vortex?
Is there anything
It's
called
kind of similar
Vortex?
to Whirlpool.
That
I kind of want to call this.
That was the first thing that came to mind, but
I want to call this Beyblade. The Beyblade Galaxy. Yeah, looks like a Beyblade symbol.
I love that. That's the official name now.
All right, we're writing it down. Beyblade.
Let it rip. I actually never
Beyblade.
played with Beyblade. That's pretty funny. Yeah, this one's super cool. And we have written here, it has 3 satellite galaxies around this guy. So this is just the main galaxy. It's got some friends kind of orbiting around it. You can see.
Ooh, I don't think that's one of the satellites. I think that's just a
sure?
galaxy that happens down there.
Do you think?
Oh, there's a bunch of fainter
Yeah,
galaxies
there's
that
like
we can
little
actually see in the background of this
fainter
image, which
ones.
is really cool. Yeah, there's one to the left, there's one below it, and then there's one at the very bottom of the screen. Yeah, one right there. Good work, Gavin and Dylan.
Doing great.
Yeah, so
Wow, this one exceeded my expectations.
yeah, when I was
very
told it was one of the
stoked.
fainter objects, I wasn't expecting
Yeah.
as clear of an image. That looks
Beyblade,
awesome.
Beyblade Galaxy. Nice.
All right,
Awesome.
M109, sign off.
You're gonna have to keep reminding me to do this because I forget this is behind us. Nice.
All right, next up, we have a couple of spiral galaxies that we're going to look at in a new constellation, not in Ursa Major. We're actually going to go to, I always mispronounce it, so I'm going to let you take the
This
honors.
is in the constellation Canis Venatici.
Thank you.
That's Latin for hunting dogs. And this constellation is usually depicted as the hunting dogs of the constellation Boötes, who represents a herdsman. So we're gonna slew on over to M106. This one is 23.7 million light years away, 125,000 light years across. So we'll see what this one looks like in comparison to the other ones. But I think Beyblade is still my favorite so far. It's not what it's called, but should be.
M109. This galaxy that we're about to observe has some interesting properties and interesting phenomenons going on inside of it. Well, is that M106 and M94 in the same field of view? I think it might be.
Neat.
So imagine M106 is the one near the center and M94 is the one slightly off to the left. And another cool background galaxy hanging out just behind the two of them. But yeah, there's this phenomenon happening around the center of this galaxy. There's a giant gas cloud around the core of this galaxy. It's about 1 light year across. And this gas cloud is producing a lot of microwave radiation. So you have this electromagnetic spectrum of light where you have things like radio waves, visible light that we can see in, all the way up to gamma rays, some of the more energetic particles in the universe, things that can cause cancer, and based off the movies, the thing that gave Hulk his powers. But in the center of this galaxy, a lot of microwaves are being produced, similar to the microwaves that are produced when you heat up food in the microwave. And these microwaves are actually heating up the water molecules in the galaxy, and we can actually see these water molecules giving off light and giving off energy because of this radiation that's coming from the center of this galaxy, which is pretty neat.
Nice. Yeah, haven't heard anything like that before. We learned that the other day.
Yeah, the scientific name is Mega Mesar.
Ooh.
Ooh.
Mega
Mega
Mesar.
Yeah.
Nice.
So this one also does not have a name besides M106. Probably the microwave galaxy if it had to be anything, right?
Microwave galaxy. Yeah, sounds good. Go with microwave.
I love it.
Wait, oh, microwave.
Awesome.
And then are we sure that M94 is the one up to the left of it?
M94, that would be the Cat's Eye Galaxy.
I'll check real quick.
So they should be in the same field of view then. Yeah, they're both in Canis Venatici. And Canis Venatici is only 2 stars.
94.
But I do know that Cat's Eye Galaxy is quite small, or M94 is pretty tiny. I've looked at it through telescopes before, and it's just kind of a little smudge, but it still looks pretty cool. So yeah, M94, Cat's Eye Galaxy, also known as the Croc's Eye Galaxy, depending if you are Team Cat or Team Crocodile, I guess. So this one is 16 million light years from Earth and about 50,000 light years across, so it's tinier than the other ones.
I'm thinking that this one might be Cat's Eye, actually. The
Oh
one
yeah,
to the bottom
one
left.
lower one would make more
But
sense.
yeah, can we slew to M94 and center the image and get a confirmation on which object is actually M94?
Yeah. let's
But
do it.
while they do that, we can check off M106.
Oh yeah.
Which is
over here.
Yeah. We've already checked off 3 galaxies.
We are moving.
Oh, cool. And this part of the night sky is pretty fun because we have a lot of different galaxies. Ooh, that was not in the field of view.
Ooh. I like this one. This one's pretty cool.
This one already has a name, so we don't have to.
That's true. And I do think it looks like a cat's eye. You can kind of see the pupil, and it's like, shaped, eye-shaped for sure. Got a nice little halo around it. This one has about 40 billion stars. Again, lots and lots. All right. Yeah, that one looks pretty cool. Into it. You see cat's eye or croc's eye?
I see like
Whoa.
an evil eye.
Evil eye, yeah. Now that you
He's staring into my
exposed
soul.
it. I like it. I mean, that's what cats usually do anyway.
That's true. That's
Yeah,
true.
They totally do.
Cats can be demons. But
They're cute demons.
I've never owned a pet crocodile, so
That's very true.
can't-
I have
can't
held a
compare.
crocodile before.
Oh.
I think it was a baby. It was not a full grown. I don't know if it was a crocodile or an alligator, but I held one. It was pretty cool. Can't remember what that was though.
So this is kind of a unique spiral. And we'll see if we can actually start to see some of the spiral structure in this as they continue to play with exposure and attempt to draw features out of this. Yeah, it almost feels like there should be a second one. I think it looks, I'd say a lion's eye. That's what it's reminding me of now, which is a
Lions
cat.
are my
so
favorite. Yep.
just large cat,
Big kitties.
maybe mountain lion.
I like it. Yeah, you can see a little bit
Yeah,
of
you
the
can see-
structure coming through.
Can we
now.
zoom in on it just a little bit more?
There we go. That's super cool.
Yeah, I feel like I can see some of the spirals. They almost look like they're branching out counterclockwise from the really bright center.
Nice.
Yeah, so this spiral galaxy is cool because it has this bright center, some spiral structure around it, and then it has these massive spiral arms that go around the outside of it. But those are much fainter than the core and will be harder to actually get actually see through one of the exposures that we're going to get tonight.
Nice.
Cool object. Let's check it off.
Yeah, that's a good one.
M94.
Yep,
M94.
94.
Counting.
Here. It doesn't even say cat's eye on here. Just says spiral galaxy.
Right.
All right.
Next
So-
up on our list.
Ooh, one of my favorites. We've got M63. This one is also known as the Sunflower Galaxy. Yeah, this one's definitely my favorite because it definitely looks like
So maybe
what it's
this,
named after.
okay, we have a question about, I assume it's about the cat's eye. And it's saying how old is this or maybe this is an old galaxy. Yeah, that would make sense based off of, you know, the diverse spiral structure it has. I'm thinking that the inner spirals might have been formed from the original galaxy, and some of the outer spirals might have come from, you know, satellite galaxies getting ripped apart and forming these spiral arms. I can't say that with 100% certainty, but if I had to make an educated guess, that's where it would go.
Checks out. All right. So now we got pulled up M63,
Oh,
also known as the Sunflower Galaxy. So it's called that because it's got a very bright yellowish center, central disk, and short spiral arm segments that are kind of dotted with starburst regions. So regions of a bunch of stars all together, and then a bunch of dust lanes as well. Ooh, we got another
and
one.
there's an awesome spiral off to the left too.
Nice. Making an appearance. Looking pretty cool.
Oh, this is also in the hunting dogs.
Yep, Canis Venatici again. So quite a few objects for tiny constellation. Still get some cool stuff going on.
Yeah.
So the Sunflower Galaxy is a prototype for a type of galaxy known as flocculent spirals, which is an interesting term I recently learned. So it appears to have a lot of arms because they appear kind of patchy and discontinuous. So that's what's known as a flocculent spiral. It's pretty neat. Kind of see the patchiness in there with the dust lanes. Couple arms in there as well.
Yeah, I always find it interesting that based off the angle that you're observing the galaxy determines what features you can see. So since this is at a slight angle, we can see that super prominent dust lane as it passes in front of the center core of the galaxy. Versus if it were more face on, we wouldn't be able to see that as clearly, and we get a lot more of the spiral features. So there's advantages based off of, different advantages based off of the angle at which you're looking at the galaxy.
Nice.
All right, let's check it out.
M63. 63.
All right. So now what we're going to do is we're going to have to wait a couple minutes before we can move to the next object. So we're actually going to talk about something else. We're going to talk about space and movies. So we're actually going to pull up a PowerPoint for this. So if we can go ahead and switch screens. Give us one moment.
Nice.
Okay.
Is it working?
Yeah, we're waiting for them to.
Screen. There we go.
All right, success,
Cool.
I think. Let me check.
I think we got it.
All right,
Nice. Well, cut off, but that's okay.
thank you for being patient. So yeah, we want to talk a little bit about, the realism of physics and how it's portrayed in a couple of different movies. Arguably one of the most famous space movies, being Interstellar. We actually watched it the other day to study up on it.
Refresh.
Yeah.
It's been a while since I sat down and really focused on it. So it's one of those kind of movies. You miss
Yeah.
one line and you're lost for the
Yeah.
whole movie.
And this movie does a very good job of portraying accurate physics most of the time. The end scene, I don't want to spoil it, but it's been out for a while, so I'm going to spoil it. At the end,
Yeah.
Matthew McConaughey goes into the black hole, and that becomes very weird and abstract.
Love.
But in some of the previous scenes, there's some really good descriptions and reenactments of how physics would work in these scenarios. So the first planet they land on is this huge water-like planet, and it's very close to the supermassive black hole that I believe is called Gargantua.
Gargantua,
Gargantua.
I think. Yeah.
It's so close to Gargantua that it's actually inside of this area that's being warped by the massive gravitational fields of this supermassive black hole, or I guess in this case it would just be a massive black hole. And what happens when you approach objects that have a ton of gravity is time can actually change. There's this weird relationship between gravity and time, and the closer you are to objects with larger mass, the slower time will actually pass. So there's this cool thing that I learned during my undergrad, that your feet are actually younger than your head, because your feet are closer to the center of the earth, which means that time passes slightly slower for your feet than it does for your head. Now the time, your feet are only going to be, 10 to the negative 12 seconds younger, but there is still a change there. But anyway, in this movie, these astronauts go and they land on this planet that's in the distorted space-time caused by this black hole. And time actually passes differently there. I believe in the movie they said something along the lines of every hour on this planet is like 7 years in Earth time. And they end up being stuck on the planet for like 3.5, 4 hours.
Longer than they wanted to.
And 30 years passes. And this is accurate. This is what would happen if you had a planet that was orbiting a black hole, and you got a little too, or if you spent a little too much time on it, time would pass slower for you, and all of your loved ones on planet Earth would perish. Yeah, a little dark. Yeah. It's okay.
Even for the guy waiting for them on the spaceship, he waited 23 years when they were only there for what you said, like 3 or 4 hours, which is just mind-boggling to me. Yeah, which is weird.
And then there's one more phenomenon I want to talk about from this movie, and it actually is on this water planet as well. So they land on the planet and they start exploring, and the water is only like 3 to 4 feet deep, and then all of a sudden this massive wave that's like 300, 400 feet high,
very large.
this giant almost tsunami starts approaching them, and eventually slams into their ship, and is why they ended up spending more time than they wanted to on the planet. And this is because of something called tidal forces, something that we experience here on Earth. With the moon traveling around the Earth, it causes the water to kind of follow it around, and thus you get waves and tides formed. Now, since this planet is orbiting something much larger than the moon, being a black hole, yeah, way more massive, the tidal forces are much more intense, meaning that these waves aren't 5 feet high, they're 300-400 feet high, which I thought was pretty cool, and that's something that I didn't catch the first time I watched the movie.
Watching it this last round, we're like, never thought about that. So yeah, pretty cool.
Yeah, and we have a couple other movies that we can talk about in a bit, but let's get back to imaging some objects.
Yeah, we got a really nice one.
Let's see if we can we can make this screen swap a little more smooth this time. All right, so I'm gonna stop sharing.
Yeah, we'll get the Malin cam back up, and
Oh, perfect, so
Nice.
smooth.
we're gonna go to our next object, which is gonna be M51. This is a pretty popular one, one that we often like to show to guests when they visit the Godo. M51 is gonna be the Whirlpool Galaxy, which is a really, really neat one for a lot of reasons too. So we'll get that salute over. One thing I learned about this one, we got a little bit, it's also known as the question mark galaxy, but I don't think that name stuck as well.
Yeah,
as
this one has
Whirlpool.
2 names already, so
Yeah.
maybe we can rename it.
So the Whirlpool Galaxy, we've got it pulled up here. With those flocculent spirals I mentioned earlier, that M63, the Sunflower Galaxy is, this is like the complete opposite of that. This is what we call a grand design spiral galaxy. So called because you can literally see very, very clearly the spiral arms coming off of this galaxy here.
Oh, so
Yeah, this
so
looks
it's
great.
so cool.
This is definitely one of our favorites. This one's about 23 million light years away. And this is the brightest example of an interacting spiral galaxy. This is actually in the constellation Ursa Major. So it's right underneath the handle of the Big Dipper. A way I like to remember it is like the whirlpool would be underneath, and like the dippers, like the spoons that get in the water. Does that make sense? You know?
Yeah.
Yeah. As opposed to like the pinwheel, which people usually get confused. The pinwheel's above the handle of the Big Dipper. I think we got some background noise going on here. All right.
Cool.
There we go. Yeah, so this galaxy, you know, looks pretty different from other ones. So like I said, this is the brightest example of an interacting spiral galaxy. So this galaxy is undergoing what's called intergalactic cannibalism. That is the official term for one galaxy that is basically eating another galaxy, stealing stars from another galaxy. So you can see that the two are connected by an arm of stars. That bigger guy over there is stealing stars from the smaller guy. So when this happens and these two galaxies interact, it actually triggers a bunch of new star formation in the regions where they're connected. And eventually they will merge together. Not like, you know, in a couple days, but far along from now, they will merge together and become a bigger galaxy here.
Yeah.
But super cool that we're able to, you know, catch this happening at the time it is. And also another cool thing is that you can see the arms on towards the bottom are more rounded out, like more circular shape, but towards the top you can see a little kink in that arm up there. And that's because the smaller guy in the top is kind of fighting back. It's gravitationally influencing the arm of the bigger galaxy and causing it to bend just slightly. So
Yeah, something cool about galaxy collisions is you think, you know, these galaxies have billions, some have trillions of stars, that there'd be a lot of stellar collisions, you know, stars hitting each other, but this doesn't really happen a lot in galaxy collisions, and that's because there's so much space between each star. So to give you an example, our sun, the next closest star to our sun is Proxima Centauri. Now, if you imagine our sun,
4 light years away? Yeah.
If you imagine our sun as a basketball here in Flagstaff, which some of you might not know where Flagstaff is, but if you know the United States, it's in northern Arizona. If the sun were a basketball in Arizona, the next star to us, Proxima Centauri, would be a basketball all the way out in Los Angeles, which for us is about a 7-hour drive. Now this is a ton of space between these two basketballs for other basketballs to fly through. So when these galaxies merge, there's so much space between each individual star that stars rarely collide. However, if you look at this image, both of these galaxies that are merging have bright cores. In this area, there are a lot more stars in a small area, so the stellar density is a lot higher, meaning that stars are a lot more likely to collide. And when these two cores meet up, there will probably be some stellar collisions. But
Be cool to see.
outside in the spiral arms, there won't really be a lot of stars hitting each other.
Yeah. So this, you're looking at this object here. I think we had the Andromeda Galaxy earlier. Our coworkers were talking about that. So Andromeda is going to collide with the Milky Way galaxy in about 5 billion years. So when it does, it would, probably kind of look something like this, except the Milky Way would be the small guy and Andromeda would be the larger guy, since Andromeda is about twice the size as the Milky Way. So we will be eaten up in due time.
Yep. In 5 billion years.
We won't be here,
So,
that's fine.
yeah. Night sky would be pretty spectacular.
Oh
too.
yeah.
All right.
Let's check this one off.
Yeah, we spent some time on the whirlpool because it's such a cool
It's so
object.
cool.
Next object we're going to go to is M53. We're actually going to migrate away from galaxies, and we're going to go to globular clusters.
Let's do it.
M51, right?
Yeah, M51. Whirlpool, or the question mark galaxy. In this case, it'd be an upside down question mark. It looks like a 6.
Ooh, it does look like a 6.
Yes.
All right, new name for it.
6 galaxy.
The 6 galaxies. Could be misconstrued
right.
because there's only 2.
Cool. So next object we got here is M53. This is a globular star cluster in the constellation Coma Berenices, which I think is a new one we haven't talked about yet. So Coma Berenices in Latin translates to Bernice's hair. So it's a story with this one. The constellation, it refers to Queen Bernice II of Egypt. And she was, the story goes, she was afraid for her husband, Ptolemy III, when he went off to war. So she vowed that she would cut off her gloriously beautiful long hair if he would return safely. So like she would sacrifice her hair basically for him to return home. So Ptolemy III, he eventually did return home safely, and Bernice, she kept her promise. She cut off her hair, and Zeus, because she kept her promise, he decided to, I guess, reward her by putting her hair up into the sky among the stars, so everyone could see how beautiful it is.
Yeah,
so,
you have constellations of great fighters and giant scorpions, and then you have a constellation of
some hair.
some hair. Yeah, so constellations are pretty abstract.
I bet she had beautiful hair though.
Now for this object, I believe we looked at some globulars earlier with the earlier groups. But essentially what these are they're reasonably large clusters of stars ranging anywhere from 100,000 stars to 1 million stars. These clusters actually orbit around the Milky Way. Milky Way has about 150 of these, and we're looking at one of them now.
Yeah.
These star clusters are normally formed out of older stars. These clusters are thought to have formed around when the Milky Way was formed, and they now orbit around our galaxy, which is pretty cool. A cluster of stars large enough to orbit a galaxy.
And we'll go to our last object before we take a break. That's going to be M3. That's going to be another globular cluster.
M3 is a good glob.
Yeah.
Let's
it
check
is
out
a good one.
53.
Oh, yeah. Check it out.
Oh, it's all the way over there. Can you write my initials? I'm too lazy.
Sure. Do it.
Ooh,
Ooh, Star Traits. Nice. This
Nice.
one's so much bigger than the last one. Yeah, so this is M3, actually in Canis Venatici. So we went back to the previous constellation that we were talking about there. This is one of the brightest and largest globulars in the sky. So this is a pretty cool one.
this one is one that looks spectacular through a telescope, because you can see all of these stars with your naked eye because they're all all bright enough to see,
Yeah.
or see all these stars through a telescope with your naked eye.
Yeah. So this one has around 500,000 stars, which is like crazy to think about just looking at it like that. We're looking at that many, about 180 light years across, and just beautiful, honestly. I love how it like kind of speckles out.
Yeah, I think
all around it.
I was describing globular cluster to a 4-year-old girl once, and she said that it reminded her of a unicorn's sneeze. And the one we were looking at that time was M13, which is right off the snout of Pegasus.
M15.
So M15.
Right.
Oh, M13 is in
M13
Hercules.
is
Yeah,
Hercules,
yeah,
yeah.
you're right. So we were looking at M15, and I thought that was very clever of her. And I do
Love
think that it does, somewhat resemble,
Snot.
yeah, a unicorn sneeze.
I love it.
Yeah, that's great.
Awesome.
Right. And with that, we're going to take a quick break. Gavin and Dylan will come down here and talk to you guys for a little bit, and we're going to go and operate the Malin Cam. So we'll be back in 15 minutes. See you then.
All right. And so, hello, my name's Gavin.
My name's Dylan.
And we will be your next hosts. So I don't know if it cut off there before we actually switched over, but just in case, once again, my name's Gavin.
My name's Dylan.
And awesome. All right, thank you. So now we will be your hosts, and we do have Matt and Angel on the working the camera. So they're going to do a really great job as we show off some more objects on this whole Messier stream. So we might as well go over to the first object, if you guys would please. That would be M64. And so this is also known as the Black Eye Galaxy. It's in Coma Berenices.
Yeah, and this galaxy also has a lot of other cool names. I found the Sleeping Beauty Galaxy, the Evil Eye Galaxy, and of course there's other catalogs like the NGC catalog, but that's not what we're here for.
No.
We're here for the Messier catalog.
But I haven't heard those other names before. That's I like those.
Yeah, it's kind of fun.
Yeah, and so to find this object, it's gonna complete like a right triangle in the constellation. So Coma Berenices is gonna be basically this right L shape. And so if you complete that right triangle and that line between those two other stars, it's gonna be about like a third up in there. And it's relatively close for a galaxy, but still kind of far. There it is. So it's around 17 million light years away from us. I've also seen 24, some conflicting data, but I'm going with 17 million.
Yeah, I also saw 17 million. But let's kind of break it down a little bit. You know, everyone always says, oh, light years, right?
Yeah.
Well, what does that even mean?
I don't know.
So a light year is the distance that light travels in a year, and light is the fastest thing that we know of.
About 300,000 kilometers a second.
Exactly.
Yeah.
And so this is that distance. So think of it as a unit of measurement, kind of like a mile or a kilometer. That's how, you know, astronomers, that's what we use it as. And 1 light year is just under 6 trillion miles.
That's not your average Sunday stroll.
Yeah. So it's just amazing that, you know, that our telescopes here at the Giovale Open Deck can even get these objects because they're so incredibly far away. And the black eye isn't really that far away when we're talking about space, which is pretty amazing.
Yeah. And so this galaxy that we're looking at, it has roughly 100 billion stars within it. So there's quite a few in there. But it's still like, what, around a fourth of the Milky Way?
Yeah.
So it's still actually a relatively small galaxy, even though it looks magnificent. You can see the definition there. So that's where the real black eye part of it comes from, because you can see that almost like an eyelid there.
Yeah.
And then the eye within it. So that dark little area there is actually what's magnificent about it, because the outer region of gas there is actually moving in the opposite direction as the rest of the galaxy.
Yes.
So they're spinning different directions. And they actually think that this happened because like 1 billion years ago, they think it actually collided with another galaxy. And so we're still seeing the remnants in there. And so that's why it's moving the other way.
Wow. Pretty amazing.
It really is.
I guess a lot of amateur astronomers can get this through their telescopes as well. So for those of you amateurs out there, might give this one a shot. See if you can see it. Why not?
All right, but that looks pretty good to me.
It
Should we
does.
sign?
We should sign.
All right. So 64. How do you count? There it is. All right.
Woo-hoo.
Now for you. Here.
Very good.
Yeah. There we go. Still in front. All right. So there's first one down. Plenty of more and fun ones to go. So should we move on to the next one?
Yeah, I would say so.
All right. So if you guys would do us the honor of M98, please. And so this is going to be one of kind of like this little cluster of galaxies. And so M98, M99, and M100 are going to be all like right around each other.
So this galaxy is about 44.4 million light years away.
That's that's a lot more than that previous one.
Yeah, absolutely.
And we'll see here once we get the first images coming in, but it's a lot bigger.
Yeah.
It's significantly more. So the other one, the black eye that we just saw, is going to be in the range of 100 billion. This is going to be around 1 trillion stars within it.
So this one should be comparable to what we should see with the Andromeda. The Andromeda is about 1 trillion stars. It's also the largest galaxy in our local group, Andromeda is.
Yeah.
Which is pretty crazy.
And so that size, but now you're going, what, like 20 times farther away?
Yeah.
It's incredible, but that image looks amazing.
It does. Good job, Matt and Angel.
Yeah,
That was
very,
awesome.
very good job. And so we're going to see like these next couple objects, 98, 99, and 100 are all going to be found actually on the same day. So this same day, it was Charles Messier's Pierre McCain, I can't pronounce names well. But on March 15th, 1781, he went crazy and just discovered a ton of objects.
I know, Gavin, how would you feel discovering some more galaxies? Think we could do that up at the Godo?
At the Godo, I mean, I'd love to dream.
Yeah, me too. All right.
Yeah, because it would be pretty awesome. And so this one that we're seeing here, and we all flew over to 99 afterwards, but 98 we actually believe interacted with 98 and 99 we believe actually interacted with each other, because we think they're only like roughly like 1.3 million light years away from each other.
Wow.
So we actually think that like they came in close contact.
Wow.
Yeah, and so that looks just amazing. And so you can see that bright center there, and so that's going to be the core of the galaxy itself. And so that's where there'll be a supermassive black hole in the case of this, and then also the highest density of stars, which is giving off that bright light.
Which is pretty crazy. And also a little fun fact is this galaxy has an estimated of 76 billion times the mass of our sun.
Ooh,
So
that's
just-
a couple.
Yeah, just a few, billion,
Yeah,
whatever.
that's not intimidating at all.
No, absolutely not.
All right, well, since it's right next door, should we move over to M99?
Yeah,
It's kind of its next door neighbor. And so again, this was found at the same time, same day actually, and that is only believed to be about like a little over 100 billion. I have 150 billion stars is the number that I have.
150 billion. That's pretty small.
It is. Is that the
Small in space.
exactly right? Like, yeah, small is a relative term. Everything is going to be
Yeah,
relative.
especially in space.
Yeah. But what's interesting about this one, M99, is that, so it was discovered by Charles Messier's colleague, but the spiral shape of it wasn't actually discovered until like almost like 100 years later, like 80 years. Yeah, so it was discovered in 1781, but the spiral was actually in 1846. So it took a very long time to actually understand like the shape of it. And so there we go, we can see it now. It's a really interesting spiral shape. And so, especially if we think that it interacted with M98, it makes sense of why it's kind of this irregular arms there, because it got thrown a little bit.
Yeah, you can see like gravity kind of pulling on those arms a little bit.
Yeah.
And it's kind of interesting to see that.
And so in order to actually see that spiral shape, because again, originally we couldn't see that, it was actually William Parsons who discovered it, and he used a 72-inch reflector.
Wow.
Yeah, which this was 1846. That was the largest telescope in the world at the time, 72 inches. And can you guess where it was located?
No idea where.
It was Birr Castle in Ireland.
Ireland.
Yeah, so in Ireland was actually where they discovered the shape of the spiral. Yeah.
Pretty awesome.
And so we can see here that there's a bright star. I believe it's going to be one of the bright stars near it is PTF 10FQS. It's a really obscure name, but it's interesting because it's a really bright star that is brighter than a nova, but less bright than a supernova. And so we actually don't even know why it's what it is, what it's categorized as.
Wow. And something interesting, just to show how bright this object is that right around the star here, you can see kind of this little faint little halo almost. That's actually an artifact of the telescope itself. So that star right there is actually so bright that it's kind of reflecting it back to the camera, which is pretty amazing.
All right. But if we, do you have anything else for this one?
I don't think so.
All right. As we sign, should we get M100 up?
Yeah, absolutely.
All right. So if you guys could get M100, after you, my sir. So M98 and 99. Right here. Nice.
That's with my left hand.
Impressive,
Signing
actually.
autographs, yeah.
Signing autographs often?
Every day, don't you know?
I'm gonna have to get yours after this.
All right, sounds good.
All right, so now we're moving on to Messier 100. And so this is gonna be, again, near the other two objects, but it's gonna be relatively large, 400 billion stars within it.
So yeah, this is about the same size as our own galaxy, the Milky Way. But what I have is it's 55 million light years away.
Ooh,
so we're
getting far.
Yeah, we're getting close to like the dinosaur ages. We're, you know, not quite that far back, but we're getting close to it.
When that light actually left this object.
Yeah, absolutely. I believe this has about 107,000 light years across. So,
oh wow,
it's pretty amazing stuff.
Yeah, it's a very large object. And so this object is also considered a starburst galaxy. And so it's actually the two armbands that are right around the center area of the galaxy is actually where most of the star forming is happening. It's right in that intense part close in there. And they actually think that like the last 500 million years is when like a lot of this formation has been happening in little bursts. Yeah.
We can see some of those like little background galaxies too, just around there.
Oh,
which is
yeah.
pretty awesome. Great job.
Yeah,
with
all those faint guys.
with Matt and Angel being able to pick those up.
Yeah, incredible, incredible.
I wonder if back then when they actually discovered this object, because they are pretty bright little points of light. I wonder if they even noticed those, if they thought they were just kind of another little, stars. But you can almost definitely tell that they should be galaxies or something like that because they're kind of a little fuzzy-ish.
Yeah, and that is looking
That's an awesome
amazing.
picture,
That
yeah.
is incredible.
Wow.
And to think that this is from our section that we've been talking about, this is the farthest object that we've seen, 55 million light years away from us.
Yeah.
And it looks that incredible. It's amazing. And because it's so active, especially with all the star forming, there's been 7 supernova recorded since 1901. Yeah, and the last one was actually 2 years ago, 2020, was the last supernova that we actually saw happen in this galaxy.
Yeah, it's only a couple of years ago, which is pretty amazing. We can see a lot of that like really bright kind of star formation happening around those edges there, which is beautiful.
Yeah, absolutely stunning. All right, seems good to me.
Yep. M100.
M100.
Woohoo.
And after you.
Thank you.
All right. Do you think we're good to move on?
I would say so.
All right. So our next object that we'll head over to, if you guys would help us do the honors, would be M85. And so again, we're staying in Coma Berenice's. All of these objects have been. And this is going to be a lenticular galaxy. So it's actually showing characteristics of both a spiral and an elliptical.
Yep.
And so this one, a little bit farther, little bit farther than the last guy.
Only by a little bit, 5 million light years.
Yeah, just a little bit, but
No big deal.
So now we're going to be moving on to 60 million light years away. It's hard to even comprehend a distance like that.
Absolutely. Well, this is when that big asteroid was coming for Earth.
Oh.
So this is when we're seeing the light. So kind of fun thing that we always talk about too is, so telescopes are number one, light buckets, because they basically just collect light. Number two, they're time machines. So the light that we're looking right now and projecting onto you beautiful people is 60 million years old.
It's
kind of gives me
incredible.
goosebumps just thinking about that.
Yeah.
It's crazy.
And so you can see that bright core there. And so because it is going to also show characteristics of an elliptical, it's going to be very dense core, but then really kind of loose, fuzzy outer area of it.
A lot of people call these like football galaxies because they kind of look like a football or a rugby, depending on where you're
I
from.
could see that. Yeah, I could really see that. And so this one they actually think merged with another galaxy like 4 to 7 billion years ago. And so we are seeing the results of that. So kind of a good example of what us and Andromeda will do in a few billion years from now.
Yeah. This guy is estimated to be about 125,000 light years across.
Ooh.
So that's about the same size as the Milky Way we think is in diameter. So pretty cool stuff.
Yeah, and so most of the stars in this galaxy are going to be generally pretty old, but the center is going to be a lot younger actually because of a few late star formation bursts that happened. Like we think the stars are in the center like under 3 billion years old.
Oh, wow.
So like not super young, not
So younger than our sun.
It is.
Wow.
Yeah. Which is weird to think about that we're seeing it then. All right, and then we can also see that little satellite galaxy off to the side there. And so that's what that shape is as well. And you can even sort of see little faint dots as well. That might, hard to tell, but. All right, and so we are taking these photos at the Giovale Open Deck Observatory with the Malin cam attached to a 14-inch astrograph.
Yep, and it's plane wave, so shout out to plane wave.
And so the telescope that we're using is going to be relatively comparable to the one that actually discovered Pluto, but just 90 years later.
Yeah,
it's
exactly.
like the great grandchild of that telescope that we also have up here, just around the corner, actually from where this telescope is.
Yeah, it's like 50 yards or less behind the Giovale Open Deck Observatory. And that's kind of the beauty about Lowell is that we have, these beautiful old instruments like the Clark and like the Pluto telescope, and and they're pieces of history and they still work and everything. That's just amazing. Then we have state-of-the-art telescopes 50 yards away in our brand new facility. So it's really amazing, that just to see the contrast of what technology has done. And of course, putting your eye to a telescope is second to none. I mean, these pictures are great, but putting your eye to a telescope is just amazing.
Yeah. And yeah, especially going off of that like time difference too, is that like in order to actually discover Pluto like they did, like Phytamba did and stuff, you would have to actually do these long exposures, like hours long. Absolutely. And using just these plates of glass with like negative film on it. Versus now we have these little tiny boxed cameras that are the one that we're using right now going to be similar to what, your DSLR camera?
Yeah, and that's what's great is it's basically a DSLR camera that is fitted for astronomy, which is basically only a few filters removed.
Yeah, and so you'll hear the term dedicated astrophotography camera, and so you get the fancy CCD charge coupled devices that are absolutely incredible, but this is kind of that like nice in between, where it's not your like bird watching camera, but it is but it still works off the same principle.
Yeah, absolutely.
With that CMOS type sensor.
Yeah.
And so we also should mark down this guy. This was M85. Here. And then for you.
You're so pretty.
All right, and so we can move on to another object in a couple minutes, but we talk about these Messier objects. We should who is this Charles Messier guy, right?
Yeah.
And so Charles Messier was a French astronomer who was obsessed with comets. That was his desire. When he was just a young child, he witnessed a very intense astronomical event where this comet came over his town, and it had 6 tails on it.
Oh yeah, the 6-tailed comet, yeah.
Yeah, and so it was absolutely incredible, and so he fell in love with it, and especially comets is what he wanted to study. And so this list that we have is about the opposite of what you would think it is. It is actually objects that he didn't want. And so when he was searching for comets, the very first object that he found was the Crab Nebula. And when he first saw this object, he was like, oh, this isn't like a star in the sky, but it's not a comet. And so he wrote it down, and he started this list. He was like, okay, as I'm searching, I'm going to list these, quote, objects to avoid, is actually the list that he started.
Oh, wow.
And so then it became the Messier objects, because he just started charting down all these objects that weren't comets. He was basically telling people avoid these areas.
And how funny is it now in today's astronomy world, we kind of use the Messier objects as like almost the very first things you learn. You learn how to find the moon, you learn how to find the planets, and then you head on to the Messier objects because they're bright. A lot of times they're easy to find, they're well documented, you know. How funny is it that he was saying avoid these areas, and now here we are having an entire stream dedicated to this.
Exactly.
Which is kind of funny.
I absolutely love it. And because, he wanted to study comets. He was, again, so into comets that King Louis XV actually nicknamed him the Comet Ferret.
The Comet Ferret.
Comet Ferret.
That is a terrible nickname.
It is, but honestly, wouldn't you just accept any nickname from a king, right? Like,
I mean, I guess you probably did not have much of a choice, probably.
Probably not.
You probably don't want to make mad the king.
No, but Comet Ferret is very interesting, actually. And originally, the list that Messier actually made was only 103 objects. But now we have 110, because later researchers and people actually went back and studied his notes and realized that he actually found more objects than he credited himself with, that he thought he found. He actually found more objects.
Wow.
And so they went back, revised it, and now we have the 110.
That's pretty awesome.
Yeah.
I think I also read somewhere where he was also, besides the 6-tailed comet, where it's like he saw an annular eclipse, solar eclipse.
I've never seen one of those.
And basically what that is, it's an eclipse of the sun, but it's not a total eclipse, whereas the moon is a little bit smaller than the disk of the sun, so you can still see a little bit of the sun around it. I believe that's an annular eclipse.
Still probably not fun to stare directly at.
Yeah. Do not look at the sun at all. It's not a good idea.
I was tempted at first, but now I won't.
There's only one place where you can come up to the Giovale Open Deck and look through our solar telescope.
Yeah.
It will not hurt your eyes, but you can really get some awesome views of the sun.
Yeah.
That's the only time.
Yeah, I've never seen any type of solar eclipse.
I was here for the one that kind of like skimmed through the Great American Eclipse. And here in Flagstaff, and it was kind of, so we used like welding masks to look at it, which is, yeah.
Nice.
But it's what it was.
All right. I feel like it's probably time for an incredible object.
Yes.
So if you would be so kind to move us over to Messier 101. And so this actually does have a nickname. The last couple didn't have nicknames, but this one does.
Yep.
Do you have multiple names or just the one?
I just have the one. I think it's the same one you're thinking of.
I think it is too.
Probably, let's say 1, 2, 3, right?
Pinwheel.
Yes.
Okay.
We messed it up. That's okay.
Oh, well. But yeah, so the Pinwheel Galaxy.
Yeah.
And which is interesting because there's others that are classified as pinwheel, but this is the pinwheel.
Yeah, like another one that is considered the pinwheel is M33, which is the Triangulum Galaxy.
Yeah.
And plus, why would you shortchange such a cool name like the Triangulum Galaxy?
Exactly, right?
Than the pinwheel, but
But this is the pinwheel, the pinwheel, and it's in Ursa Major.
Yes.
And so this one moving a little bit closer. Oh, look, it's already looking
Beautiful,
magnificent.
yeah.
It's like first image, and it's amazing. This is 21 million light years away. So a lot closer than the previous 60 million.
Yeah. It's insane. And what I really love about this object is you can see like these big, beautiful, spiral arms coming off, and the one kind of way out on the side, you can see like this huge kind of long arching on the top there.
Oh yeah.
And that's just amazing.
Yeah, and so this is a top-down view.
Yeah.
Which in space we don't get to pick and choose our perspective. It's we just get whatever we're dealt. And so being able to see a top-down view of a magnificent galaxy like this is just jaw-dropping.
Yeah. And this one's, nice and face on, so we can see those beautiful, beautiful, beautiful arms.
Mm-hmm. Oh yeah.
And also what I love about these galaxies and about what our telescopes can pick up is these like little kind of blue, faint little, I call them almost like sprinkles throughout the arms, which is amazing, which I believe is newly forming stars.
Yes.
And that's just beautiful.
Yeah, because also if you start messing into way fancy technology like Hubble capabilities,
Right.
you can actually see that there's still tons of red hydrogen gas, which is why we see all these blue new stars, is because there's just so much. Oh yeah, there you can see it coming in really nicely there. You can actually start to see some of that gas in there as well.
Yeah.
Oh, that's just magnificent. And so twice the diameter of the Milky Way is what we estimate this guy at.
Holy cow.
Yeah, so huge. And we consider it a galaxy, but when it was first discovered, did you know that they didn't think it was a galaxy? They actually thought it was a nebula.
Oh yeah. Most of these old classifications, they called them nebulas, because they didn't know that these kind of fuzzies that they were seeing in the sky, they didn't have a beautiful instrument that we have here. And they kind of just looked like little fuzzies in the sky. So, or little clouds, and that's why they called them nebulas. If I agree.
Yep. This one, Charles Messier's right-hand man, once again, he actually described it as nebula without star. So it's a shame that this galaxy that we now know has over 1 trillion stars,
right.
He considered it as gas with no stars.
Yeah, how funny.
Yeah, our technology just keeps moving forward, and it's amazing. Like that's just a magnificent image.
Absolutely.
And so.
Oh, it's autograph time.
Yes, after you.
After me, okay.
I see you 101. Right at the bottom there.
All right, let's see.
Awesome. All right. And so if we're in the 100s, we might as well just go up one more in the Messier catalog, Messier 102.
Might as well.
And so still, but actually not close, close, but not close, It's in a neighboring constellation. And so it's in Draco.
Draco.
Versus the last one was in Ursa Major.
Draco the Dragon.
Ooh.
So here up at Lowell, we like to give constellation talks and tours where we point with our laser pointers up in the sky. And one of my favorite constellations is for sure Draco the Dragon. It's a very large constellation. It kind of wraps around. It looks just like a dragon when you can point it out, which is pretty cool. It's one of my favorites, of course.
I can tell, yeah. And so this next galaxy that we're going to be getting here in a second is into that lenticular style. So that kind of hybrid between spiral and elliptical. It has a nickname.
It does, yes.
It does. And what is that nickname?
I believe it's the Spindle Galaxy.
It is. That's what I have. Do you have any more nicknames?
No more other nicknames.
Okay, yeah, me neither. I just want to make sure.
Yeah.
No. So yes, the Spindle Galaxy, which only 100 billion stars is the estimate that I have.
Another kind of mini one.
So yeah, you can see the shape there. We're kind of on a little slanted angle there, but a little more edge on than other ones. And so you'll never guess when this one was also discovered.
I would say around the same time.
Yeah, like March 1781-ish time. Because again, it was Pierre McCain, just so many. All but the first object that we've talked about so far, the two of us.
Right.
All in March of 1781.
Like we should call this the Pierre. That's considered the Messier.
This little section really should, yeah.
He's going crazy with.
But he was a colleague. He was right-hand man with Charles Messier, so they were working together. And actually, this one they did actually kind of work together when they discovered this. So Messier added it at the same time, roughly. And this one, Messier 101 Messier 102, they actually believed was an error and a duplicate of Messier 101.
Oh, wow.
Yeah. And an interesting thing about this galaxy, it is a little bit harder to see. It is 44 million light years, roughly.
Yeah, 44.
Yeah, and so a lot farther than the previous one. But you can see that there's kind of this outer halo around it. So there's that bright, tight center, but then there's that halo kind of all the way around it. And there's numerous globular star clusters within this kind of outer halo of it. And these globs, they actually think like million stars within them. So huge globular star clusters. Wow. And globular meaning that all of them are gravitationally bound to each other. And so just all stuck together.
Yeah, we saw some globulars earlier. They kind of look like like black construction paper. If you had like a handful of salt and just kind of like dropped it on the paper, it's kind of what they look like.
Yeah.
Just kind of fun.
And so you can also kind of see in that halo, you see those little kind of faint dots that are all around it. And so there's tons of galaxies in the background behind this object that you can actually see through that halo there. They just kind of appear as little faint dots right now. But for some reason, just all collected behind it there. Yeah, it's just tons, they think that it could be millions or billions of light years away from this object, but just all behind this halo.
Right, absolutely. It's also kind of amazing that we can even pick up their faint light, and we can still see that.
Yeah.
Wow. And
so I know that we are going to be talking about some galaxies in Virgo. We'll talk about some later, but also right after us, our other pair, Matt and Angel, they're going to be seen and talk about a lot of Virgo objects. And so I was wondering, I hear this term a lot, Virgo supercluster.
Yes.
So what exactly is that? Before we do that, should we at least mark off this guy?
Oh, yes.
And then you can tell me about that.
Yes.
All right. Yes. Have you?
102, right?
Yep. Right next door there. The backward signature has been getting very good.
It's getting
It's
slightly better
it's
and better.
progressing.
Not much though. Not much.
But as long as it's moving forward, that's all that matters.
Right.
Okay, I'm interested. I want to know Virgo supercluster. What is it? I need to be able to tell my friends.
Okay, so let's go ahead and start with our solar system, right? So
Okay.
the sun is just one of 400 billion stars in our own galaxy, right?
That's a lot.
So that's like our own little miniature little neighborhood, our own little star system, right? Well, let's expand that a little bit. Let's go all the way out and let's go to our local area where we are in our own galaxy. Well, that's the Orion Spur.
Okay.
And that is only a small fragment that is kind of broken off of a larger arm, because the Milky Way is a spiral galaxy. And that bigger arm, I believe, is the Sagittarius arm. And we're just a little kind of shoot off of that.
And if I'm correct, we're kind of near the edge of it too, right?
Yeah, we're kind of on the outskirts. We're not really towards the center. We're not really towards like the very, very outskirts, but we're kind of like, we're the suburbs of the galaxy.
Okay.
kind of.
Okay. So there is a bit of a commute to get into downtown.
Yes.
Okay.
Yeah, downtown is still very, very, very far away. So our galaxy is huge. It's 120,000 or so light years across. So if we had a way that we could actually kind of zoom out and look at it, we'd be just this little spur.
Okay. I'm imagining this. I'm moving outwards.
And then if you go out even further, like somehow we could zoom back out, we would see a couple other galaxies, and that would be our local cluster, or our local group, I should say. And that pretty much is, starting with largest to smallest, is the Andromeda with 1 trillion stars. Us, the Milky Way, the second largest at 400 billion stars. And then the third largest, which is of course the Triangulum Galaxy at 40 billion stars. But that's just our little kind of local group here. Now, if you kind of back out even further than that, then we're talking about another huge clusters of galaxies. We're talking at least 100 galaxy groups that are clustered together within themselves. So
okay, I'm staying with you. My head's going a bit, but I'm staying with you.
So we're in like the Virgo supercluster. So that's kind of how we see a lot of this stuff. They're like all kind of like starts to cluster together, like almost like little knots, because our universe, as we can observe it, is almost like kind of like spider webs crisscrossing.
Okay.
And we're just like a little knot that's on a little knot that has like a little vein and a little knot and a little knot. And the Virgo supercluster is just our largest, smallest version of that knot, if that makes sense.
Okay.
And yeah.
So that's what the supercluster is.
Yeah, and to kind of put it into perspective, the diameter is about 110 million light years across.
Ooh.
So
a little large.
Yeah, absolutely. It's huge.
Wow, that's okay. But at least now I know. So
Yep.
I don't know if I could recite it as beautifully as you did,
Oh.
but I could at least get the general idea of what this supercluster is.
Absolutely. And a little side note too is we believe the Virgo supercluster is actually just a little tiny little, like I said, a knot or a lobe off of an even larger one. And I don't want to say the name because I'll probably butcher it, but I think it's like Lanakia, I think.
Okay.
So I'm so sorry if I mispronounced that.
I was trying to see if I could find the pronunciation of it.
But yeah.
Okay, I like it. And so I know what this supercluster is. I know some of these Messier objects. If I completely had no background in this, how could I get into this? What if I wanted to take photos? How would I get into this astrophotography world? Because I hear it, it's a little intimidating, but I'm interested and I want to get into it. So like, is it hard to get into it?
You know, it's really not. All you really need is a you know, even in some cases, your normal cell phone can do so much stuff. Especially with these newer phones, they have like longer exposure stuff. You could start doing stuff with a pair of binoculars and an iPhone or an Android phone or whatever.
Wow. Okay.
And if you have just even a normal DSLR camera, like a Canon or an Nikon that most anybody has, and a little bit of a tripod, you can start taking pictures of the night sky. Whether if that's star trails, like the stars going around Polaris and having these beautiful star trails, or, you know, taking pictures of the moon. In some cases, people with these crazy zoom lenses, they can almost get Jupiter and Saturn, you know.
Just with a camera.
Just with a normal everyday camera.
Wow.
And it takes, you could YouTube something for 5 minutes and figure out how to use one of those cameras. and you'd be golden to at least give it a start.
Wow. And so what if I wanted to take it to like a step after that? What would I be looking at doing? So I have just like a DSLR and a normal lens per se for it. But say I want to dive in, put my toes in the water a little bit more.
Then what I would do personally is I would get something that's called a star tracker.
Okay.
So it's basically a tripod that moves with the same motion that the sky moves, basically.
I guess the Earth rotates, doesn't it?
It does rotate. It rotates rather fast.
It does. And so like, I think I heard after every just like 10 seconds, then it starts streaking a little bit, right?
Oh yeah, absolutely, yeah. So the problem with just having a tripod that's stationary is that, like Gavin said, you'll have star trails or these streaks because obviously, you know, the Earth is rotating. So to compensate for that, you use a star tracker, and that'll kind of help that a little bit. It's like a little mini German equatorial mount. And that's just basically a fancy word for a tripod that tracks the sky.
And so just with that, what could I do? Does that mean like I could?
You could do like the Andromeda Galaxy with something like that with a good.
Okay. So I can do
lens.
longer exposures then.
Absolutely, yeah.
Okay.
You can get into, you know, 30-second exposures if you're set up right. And that seems insane. A lot of folks, they ask me when, you know, we take pictures of the Godo or my own personal astrophotography photos, they're like, so what's your exposure time? I'm like, oh, about 8 or 10 minutes. And they look at me like I'm crazy. And I'm like, well, it's because we have this equipment that tracks the stars for us. So we don't have to worry about that. But,
yeah, very, very, very true. Okay, so you'd start off, you can just do it with like a cell phone camera. Actually, I think I have an iPhone that has that capability now. I can do 10-second exposure. So start with there. So anybody with a modern flagship phone or modern phone can, chances are, do it. Yeah. And then moving on from there, you would DSLR camera, just DSLR and camera lens.
DSLR with just like run-of-the-mill camera lens.
Okay, and then if you want to dabble in it a little bit more, then you'd go for the tracking mount.
The star
tracker. And then after that, then start getting fancier with like maybe get like a telescope lens or.
Yeah. So if you're really interested in stuff like that, then the next step would be to get a telescope. But you would need to start to really learn how to use these instruments. So, you know, picking up a book that show like a planisphere is a great thing. It shows you where the stars are and how they move and what they do, what they act like, and you know, you start learning these constellations. And I know for a lot of us, we use the constellations to kind of hop back and forth to help us actually gauge where a lot of these deeper objects are that you can't see with your own eyes. So you really need to learn the sky before I'd say you jump into a telescope. And you could learn the sky with a pair of binoculars and your camera. So
cool.
Yeah.
All right. And so I think we are about to transition over into a break for a little bit. We will be jumping back on the telescopes, and then the previous hosts, Matt and Angel, they will be coming back and talking about some new objects soon.
Absolutely. And Matt and Angel, thank you for being our awesome telescope operators tonight.
Absolutely awesome.
Great images. Thank you.
All right. And so we'll be back soon after a little break.
Yep.
All right, we are back again. So
It's a little late. We might be a little loopy, but that's okay. We're officially halfway done with Messier Marathon.
oh yeah,
Yeah.
we've reached into the next day.
Yeah, it is now
the 12th of
past
March.
midnight here. So
That's
yeah.
my bedtime. But we're here. Let's do it. Okay. So our next object is going to be M84. We're going to move over to Virgo, which is super fun. I haven't seen Virgo in a while.
Yeah, most of the next objects that we're going to look at are going to be in Virgo. As Dylan and Gavin just talked about, there's a large cluster of galaxies located in the direction of Virgo called the Virgo supercluster, and we're going to look at a lot of those galaxies.
Let's do it. So M84 is going to be an elliptical / lenticular galaxy. Lenticular literally means shaped like a lentil, which I thought was very funny. Once I read that, I like lentils. They're pretty good. Good source of protein. They're also thought of as armless spiral galaxies. And you can see why, because don't really see many arms in this little glob right here. We can get a little zoom on there. See very, very bright center, obviously more elliptical shape. Can't really see any arm definition going on there. So this one in particular is about 60 million light years away from Earth and about 110 light years across. Oh, a little brighter there. Nice.
To get more resolution out of it.
A little lentil. Shining lentil in the sky.
Wait, so what should this one be named? Because we have a couple.
Yeah, we got a couple lentils. We got a couple lenticular galaxies, so we can't name them all the lentil galaxies. So I don't know. I would say like the protein galaxy.
The fiber galaxy.
Or like the bean galaxy. Is a lentil a bean?
The red lentil. All right,
yeah,
I like
yeah.
it.
That's a
The
good
red lentil. We can give them maybe different colors.
Yeah. Yeah, they do come in different colors. There's red, there's black, there's green, all sorts. Nice. Yep, so this one is also part of the Markarian chain there, that stretch of galaxies that looks like a line seen from our perspective here on Earth. Ooh, looks like
And we're actually seeing more of the Markarian chain to the left, and near the bottom there's
nice.
another galaxy down there.
Little guy.
Now there's this interesting phenomenon happening in all of the Virgo galaxies called ram pressure stripping. Essentially what's happening is this giant cluster of galaxies is traveling through a gas cloud. And as these galaxies travel through these more diffuse gas clouds, the gas clouds are actually pulling some of the gas and dust out of the galaxies. So when we look at these galaxies, say in the spectra of X-ray, if we look at them in X-ray light, we'll see these galaxies, and then we'll see these trails of dust that's left behind the galaxy. And this is because this gas and dust is being ripped out of these galaxies. And this leads to a lot of interesting results and things that happen with these galaxies. And we'll get more into that as we continue throughout these galaxies in Virgo.
Nice. Yeah, that's neat. You can see they look like twins there.
Yeah.
It's almost like a face. You can see the two eyes up here, the nose in the middle, and then the little mouth at the That's what I see.
Abstract art.
That's what it looks like.
Here at midnight at Lowell Observatory.
Love it.
Yeah.
Awesome.
All right. M84, the red lentil.
The red lentil.
Next up is M86.
Nice.
Oh, so Marcus getting a little sad.
Take it. All right. So M86 up next is going to be another lenticular galaxy in Virgo. And it'll probably look pretty similar to the last one, but let's take a look at M86 here. Uh-huh.
So it was the one on the left side.
Yep.
Yeah, so we actually already kind of looked at this with
Yep.
with the last image, with M84 being on the right here, and M86 now taking up the center. And we can see this, yeah, I mispronounced it too, Markarian's chain, continue down to the bottom left. So it's just, yeah, this giant string of galaxies that travels through Virgo, and all these galaxies part of the Virgo supercluster. Yeah.
Red lentil number 2, if you will.
Oh, very red.
Very red.
I think someone outside might have shined a red light into the telescope. And that's what we're seeing.
You can see another thing up the top as well.
Yeah, another spiral up there.
Nice. So.
Oh, something that's interesting about these globular clusters, these lenticular galaxies we're talking about, is they all have a lot of globular clusters. So the Milky Way galaxy has about 150 of these globular clusters. We've imaged a few already tonight. These objects have, and this one in particular has 3,800 globular clusters. So you have this main core of this galaxy, and then you have a bunch of these really massive star clusters orbiting around it.
The bees around a hive.
I'm not sure if that's something we're going to be able to see, because they are going to be much fainter than the center of this galaxy. But
nice. Yeah. You also have written, this object has the highest blue shift of all the Messier objects.
Yeah.
Traveling towards us at 244 kilometers per second. You have. It's pretty neat.
Yeah. Yeah. So they probably talked about blue shift and red shift when talking about Andromeda, but essentially what that means is light can change color depending on if an object is traveling towards us or away from us. If an object is traveling away from us, it will be slightly redder. If it's traveling towards us, it will be slightly bluer. In the case of this galaxy, it was bluer, meaning that this galaxy is traveling towards us. And as you said, of the Messier objects, it's traveling towards us the fastest. It's traveling towards us at 244 kilometers a second, which is pretty fast. However, this galaxy is so far away that it would still take 65 billion years to reach us.
Oh yeah, that is, I cannot count zeros. Okay. Yeah, that's a long time.
Yeah.
That's a very long time. Traveling at the speed of light just goes to show how big the universe is. Pretty neat.
All right. So yeah, these two elliptical lenticulars that we just showed are two of the brightest galaxies in this Markarian's chain. But we'll continue down the chain and maybe start looking at some fainter objects. So next up is M87.
Ooh, it's a good one.
And we are going to mark this one off.
Oh yeah.
M86.
Filling up fast.
Oh, someone put all three initials on there. It's John Compton. It's feeling special.
I have 4 initials. Should I put all 4 of mine? Couldn't even see the other.
Wait, we didn't get a name for this one.
I said lentil number 2.
Red lentil 2.
Right? Did we already do? How many did we do?
Or we could do right eye and left eye of the smiley face.
That's true. Okay. This is M87 that we have here. This one's another galaxy here, and this one is named Virgo A, aka the Smoking Gun, and this is in the core of the Virgo cluster, about 53.5 million light years away from Earth, and about 120,000 light years across. So this is one of the largest, most luminous galaxies in the local universe. Estimated mass about 2.7 trillion solar masses. Absolute magnitude of -22, which is basically the lower the number of absolute magnitude, the brighter it's going to be. So -22 is pretty darn bright, which is super cool. About 1 trillion stars in this galaxy here. So one of the brightest. You can tell it is very bright. Again, looks circular lenticular, if you will. So pretty similar to the other, but this galaxy in particular is really cool. Tell me.
So this galaxy has AGN, known as active galactic nuclei, essentially meaning that there's a black hole in the center that is currently consuming things and emitting light. Now this galaxy gets its name, the Smoking Gun Galaxy, because there's a giant trail of plasma and stellar material that jets out of this galaxy about 4,900 light years out of the galaxy. Now it's not something that we're necessarily going to be able to see because this jet of plasma is going to be a lot fainter than the actual core of the center of this elliptical. But yeah, that's how it gets its name, because it essentially has this giant line of smoke traveling out of it. Now, these AGN, active galactic nuclei, aren't uncommon in the center of most galaxies. As we mentioned earlier, there's supermassive black holes, and oftentimes they're hungry and eating stars and giving off lots of energy and emission.
Yeah, so this galaxy in particular is special because this galaxy's black hole at the center is actually the first black hole to ever be imaged back in, well, it's 2019, a couple years ago. So, I mean, super cool. We haven't been able to image a black hole until then, and we were able to do it with the one in this galaxy here. It's one of the most massive black holes that we know about, and we were able to take a picture. So we should probably...
Yeah, so we actually have a slide that goes a little bit more into this. So if those operating the Mount Kim can go ahead and stop sharing so we can share our image. See if we can... Oh, all right, so we're gonna quickly click through a couple, hold on. We're gonna quickly click through a couple of these slides, if it will allow me. Okay, other movies that we can talk about if we get there. Cool, and then let's see how this is displaying. On, oh.
It's good, we're good.
Okay, so with the detection of a black hole. So these black holes, supermassive black holes, are in the center of galaxies, which means if you want to see them, you have to look through a lot of material to actually get to them. Now, this can be hard to do in wavelengths such as visible light, as we're seeing right now, you know, X-ray, almost the entire electromagnetic spectrum. You wouldn't be able to see this black hole. However, there is a part of the spectrum that you can use to potentially, you know, pierce through all of the light coming from galaxies and look towards the center, and that is radio waves. This black hole was imaged using a radio telescope and detected using radio waves.
But not just one.
Yeah, it wasn't just one radio telescope. If you look at the image at the top, these are the locations of all the radio telescopes that were used together to image this black hole. And what's cool about radio telescopes is if we're talking about normal telescopes, the aperture or the amount of light that you can collect is determined by how wide your telescope is. With radio telescopes, if you have a telescope, say, here in the US, and you have a telescope out in Europe or Africa, and you take an image with the radio telescope from both of these locations, you essentially have a radio telescope that is the size of the distance between your two radio telescopes. So if we look at this graph at the top, or this image of the globe, you can see that these radio telescopes are spread out from, you know, the US to Europe, down to Antarctica, out to Hawaii, and South America. And by spreading out the radio telescopes that we're using like this, we're able to create a radio telescope that's essentially the size of half an Earth. And with telescopes, the larger telescope you have, the better resolution you can get from an image.
Yeah, so I think the furthest sites they had apart were actually the South Pole and Spain, and that, you know, created a aperture big enough, basically like almost the diameter of Earth, so that they could image this black hole. By the way, this telescope is called the Event Horizon Telescope as well.
And it's a very apt name because when we're looking at this image of the black hole on the bottom, we're actually not able to see the black hole because black holes don't give off any light. Rather, what we're seeing is the shadow of the black hole. So as I mentioned earlier, this black hole is currently consuming stars. And as stars get really close to the black hole, the gravity of the black hole actually starts to rip the stars apart and forms this thing called the event horizon around the black hole, which in this case is this really bright disk around it. And this bright disk of star guts flying around the black hole is what allows us to see the shadow of a black hole in the center. And this is the image that we got.
Yeah.
Now, one really cool person that was involved in this is to the right. Her name is Katie Bowman, and she developed most of the code to actually synchronize all of these telescopes from around the world to create one composite image of a black hole. It's pretty neat.
I love her expression here.
Yes.
Like,
that's her finding out that her code worked
yeah.
and seeing
seeing
an
the
image of the black
image
hole
for the first time.
Yeah.
Yeah, there's a super cool documentary that kind of talks about the whole process of imaging the M87 black hole. It's called Black Holes, The Edge of All We Know. It came out in 2021, so it's pretty recent. Stephen Hawking's also in it, which is really cool. It's like kind of split between him and his team studying what is the information paradox, and then the event horizon team, telescope team kind of processing and coming up with the first ever image. So if you haven't seen it, I recommend it. It's really neat. There's a lot of cool information. But
yeah, so M87 might just seem like a standard elliptical galaxy, but it's got a lot going on. And is how we got the first picture of something that doesn't emit light. Picture of a black hole.
So cool.
Pretty neat.
I remember when this came out, I just like freaked out.
Mhm.
Never really thought I'd see something like this. But yeah, the Event Horizon Telescope, they're going to add more sites in the future. They're actually currently working on imaging the black hole at the center of our galaxy, which is Sagittarius A star, which will probably be a lot more difficult given there's a lot of stars in the way within that are a lot closer to us. So but that'd be pretty cool to see our own black hole.
Yeah.
Neat.
All right.
Oh,
Time to
let's
get it.
mark it up.
Oh yeah. And then we'll get back to viewing. The next object we're going to look at is M89. Yeah,
Virgo A.
All right.
Yeah, this one's so good.
And I'm going to go ahead and allow them to start sharing their screen.
Great. I love that. Talk about black holes all day.
All right, there we go.
Cool. So we got M89 next. Gonna be another elliptical in Virgo. Nice to start seeing Virgo coming up again. Got Spica in there. Spica's a super cool star. It's a binary.
We're going to M89.
Yeah. Yeah, so Spica in Virgo is a binary star system. And the stars in the binary are so close to each other that the gravitational force in between them is so strong that they're actually more elliptical shaped stars rather than, the ordinary spherical. And they're moving around each other so fast that they orbit every 4 days, which is like what? How does it do that? But that's something super cool about Spica. I'm just happy to see it up in the sky again.
Yeah.
Spica.
All right, it looks like they might be having some software difficulties with the telescope. So something that we can do is we can go back to that movie list and talk about another movie while they get things sorted out. So if they could stop sharing their screen so that we could go ahead and share ours. Maybe.
Gavin Dillon. Hello.
Telescopes and computers get cold when they're outside.
Oh yeah.
So
do people.
Yeah.
They might just be a little chilly.
Okay.
Cool.
Up and running.
Oh, okay, we should be good then.
All right. M89.
M89.
Maybe.
They're thinking about it.
Yeah.
I can tell they want to.
Yeah. Telescopes, I guess, get sleepy too, like us.
Mm-hmm. Imagine we go
Was that
outside
the
and
halfway
sleep.
point on M55? Wait. M87 is halfway. All right, we've officially completed 55 Messier objects.
Yay!
We are halfway done with the object list.
Nice. Cool. We got the halfway point. It's pretty neat.
Mm-hmm.
And a good object to do it on too. That 87 there. All right. Still probably having a little technical difficulties out there. I see the mouse moving.
Yeah.
Doing a little chat communication with our telescope operators. Oh, YouTube.
YouTube is frozen. Can they still hear our voices? Yeah, we're still live.
Mm-hmm.
It just looks like the Malin cam is frozen to us.
Mm.
Telescope is working. Can we unshare and reshare?
There we go. All right, so
They might.
Oh, okay, they're going to try to unshare and reshare. See if that brings it back up. Telescopes like to take their time sometimes. It's been running for a long time. We're asking a lot of it, I think, you know?
All right.
We have an image.
That looks like an elliptical galaxy.
It sure does.
And it's a different elliptical than what we were looking at earlier. So I'm going to
Yeah.
assume that that is M89.
All right. We did it, guys.
So we got there.
Nice.
Just took a little patience.
Excuse me.
So with a lot of these ellipticals, they're these essentially giant spheres, but they're kind of stretched out, almost like a football. And this is because these galaxies are rotating, and when you have spheres that rotate, they tend to squish down. In the case of this elliptical, it actually looks spherical to us. It looks like it's almost a perfect sphere. And this could be for a number of reasons. One, it might just not be rotating that quickly, which means that there's not this angular momentum that's flattening it out. It could also be because we're looking at it at its axis of rotation. So to us, it would be rotating almost like a clock with the axis pointing towards us. So it looks spherical to us, and the direction that it's squished in, we can't actually see because it's not facing us. Oh.
All right, we're getting things sorted out here. I think we were. See what the moon.
Okay, so it sounds like the computer that was running the telescope decided that it wanted a quick nap. So what we're going to do is we're going to go back to that PowerPoint earlier and talk a little bit about some movies.
Yeah. I like movies.
All right, so let's go back. I recall this took a second to load, so let's wait a second for PowerPoint to decide that it wants to acknowledge. There we go. All right, so we started with Interstellar. We talked about that. in our first hour. The next space movie that I want to talk about is a very famous series, Star Wars. Surely everyone has heard about it. I want to talk about this movie in particular, the Last Jedi,
It's
which
gonna be all yours. I have not seen either of these.
well, they're the same movie.
Oh.
Yeah, just different trailers.
I see.
But if Interstellar was good at following physics, Star Wars is not as good at following physics.
Naughty.
So in space, there is no air. It is considered a vacuum. And there are some consequences of space being a vacuum. And one of those is that you cannot hear in space. If you were to go into space without a helmet, you were just hanging out in space. If you were to say scream because you're terrified about being in space,
as you would be,
you wouldn't hear anything because there's nothing for the sound to travel through. So when we're here on Earth and we're talking like I'm talking to you now, right now, my vocal cords are producing sound waves, which are compressing the air, and that air compression is hitting the microphone, and that's how you're hearing me. In space, there's no air, so there's nothing for my voice to travel through, thus there's no sound. And Star Wars breaks this rule pretty egregiously. Every time there's a space battle, they're shooting lasers at each other, and as angels recreating.
I know that part.
Effortlessly and accurately, you can always hear these laser sounds. And in an actual space-like environment, you would hear nothing. Also in Star Wars, spaceships get hit by one of these lasers. They'll often explode in a fiery explosion. This would also not happen. Fire needs oxygen to breathe. There's no oxygen in space. Thus, the fire would have no air to breathe and would die instantly.
I never thought of that.
Exist. Yeah. Now, the reason I chose this movie in particular, because there's a scene with Princess Leia. This movie came out a while ago, so I hope I'm not spoiling anything. If you haven't, if you haven't seen it, I mean, close your ears for the next 30 seconds. But there's a scene at the end of the movie where Leia's in the bridge of a starfighter or a star cruiser, and the bridge gets the windows in the bridge get shot out, and Leia flies into space. Now, a human in space is not a good thing for the human. A lot of bad things would happen. So when you're here on Earth, there's a lot of pressure pushing in on you. There's about 15 pounds pushing in on every square inch of your body. If you were to go to space, there's no air, there's no atmosphere, so there's no atmospheric pressure, which means this force that's normally squeezing you with 15 pounds per square inch is gone, which means your body now expands outwards without anything holding it in, which would be really bad for things that are squishy like eyeballs and lungs and things like that. I'm not going to get in too much detail. Another thing that can happen is due to this lack of pressure, your blood can actually start to boil, which is also not good for the human. And then space is obviously very cold. There's no atmosphere to hold heat in, so you would freeze pretty quickly as well. And then there's no oxygen or anything, no air for you to breathe, so that would be a problem as well. So anyway, Leia is in the bridge. The window gets shot out, and she flies into space. Now, if this movie were accurate, she would have died pretty quickly in a matter of seconds. However, what happens is she kind of floats through space, and the first thing that you notice as she's flying through space is she starts to have ice form on her face, indicating that the biggest fear of being in space, or the biggest problem of being in space, would be her freezing, which would probably kill you, the last of the things that I've mentioned. How I like to think about it is that Leia, since she's force sensitive, was using the force to pressurize her body so that that her blood didn't boil and things like that, and then she used the force to pull herself back in.
Quick thinker.
Yeah. So sorry to kind of go on a gory discussion with this, but it is past midnight, so
We've reached that point.
we've
now.
reached that point.
Yeah.
All right, cool. We're gonna check and see if
Yeah.
the computer outside is up and running. If it's not, we'll come back to the movies. All right, and it looks like we're up and sharing again, so you guys are good to start sharing. Let me grab some water. I put where? Where did I put my water?
We did
It's right here.
M89, correct? We already did that one.
Yes, we did M80. No.
Yes.
Yes, we did M89.
Yeah, we already talked about that. So then M88 is going to be our next object. Did we check off M89?
I don't think so.
No, we did not. All right, check it out. M88, the one right before then. Oh, it's a spiral galaxy this time, so no more lentils.
Yeah,
For now?
so spoiler, we're gonna be in Virgo for the next
The rest of our objects.
yeah, the next 10 to 20 objects are going to be in this Virgo supercluster.
Ooh, look at that.
Ooh.
M88.
All right, so we've escaped from the ellipticals. We're now getting back into spirals. Ellipticals are cool, but I'd argue that spirals are
Just a
much
little-
more pretty to
A
look
little
at.
more to look at, yeah. A little more detail. So this one's pretty nice. Oh, I actually really like that one. It's like what are the circular saws called? You know,
A hacksaw?
like a buzz saw?
Buzzsaw, hacksaw? I didn't.
Tables? I don't know.
I didn't.
That's what it looks like to me. So
I'm
this
not
is
a carpenter. I don't know.
Oh, there we go.
Oh,
Really nice.
wow, this one almost looks more like the sunflower.
Yeah, it kind of does.
Okay, does this one have a name? I don't think it has a name.
It doesn't. That's why I'm just
Right.
gonna call it the buzz saw galaxy.
The buzzsaw.
I think that's, I'm not a carpenter either, but yeah, so this one also located in Virgo as well, about 47 million light years away, 105,000 light years across. Getting some good dust detail in there. You can see that one really pronounced arm in there with a couple more. There's one at the top as well.
Oh,
That looks nice.
yeah, a really cool thing about this galaxy. So you remember how I was talking about RAM pressure stripping earlier, how all of these galaxies have been stripped of a lot of their gas and dust. So when we look at this object, we look at the center is extremely bright, very bright core. But once we start to look at the spiral rings on the outside of it, there's not really a lot of light coming from there. And that's because there's not a lot of new stars being formed. Because of this gas stripping, there's not enough gas really in this galaxy to have these dust spiral arms start to collapse down and form new stars because it's lost quite a bit of its dust and gas. So that's one of the consequences of this galaxy flying through a giant galaxy-sized cloud. Is it has lost a lot of its star-making material.
Yeah, this one's pretty neat.
Hurricane? Maybe we should call it a hurricane.
Hurricane galaxy.
All right, we'll go with the hurricane galaxy. I dig it.
Nice.
Yeah, that's a
You
super.
don't like buzzsaw?
I do like buzzsaw.
I do like hurricane better. I'll give you that.
The hurrisaw. The buzz cane.
The buzz cane.
The buzz cane.
Hurrisaw. Nice.
Yeah,
All right.
that is super pretty. All right, let's sign off on it.
M88.
Oh, look at us. 4 in a row.
Nice.
Look at us. Who would have thought? Like I said, it's late. We're tired.
M90 is up next. Come on down. We got M90. This is going to be another spiral galaxy in Virgo. So get that pulled up. Ooh. That one's definitely a little fainter so far.
Ooh, nice wipe down. All right.
Nice.
Nice.
So this is...
Oh, that. Wait, did they take the last one on a 10-second exposure? That must have been very bright.
Oh, I don't know. That was not. paying attention. Anyway, this one's 58.7 million light years away. We're getting out there. That's very
Yeah,
far.
distances in astronomy, they are really, our brains can't comprehend it because everything's just so far away.
I would say that's one of the most
Okay.
common questions I get asked here at the observatory. How far is this object? So just want to let you guys know, in case you're curious. Ooh,
Ooh.
nice.
Okay, the last one was a 30-second exposure as
Oh,
well.
okay. You can
Ooh.
see some nice
Another cool spiral that's on its side.
spiralism.
Spirality.
Spirality.
Ooh, and this isn't in Virgo.
It's not?
No,
Where is it at?
it's in Coma Berenices.
I think you're reading
Ber
the wrong one. We're on M90.
Oh, well, the last one was in Coma Berenices. My apologies.
Oh, yeah. So, yeah, this one's still in Virgo. This galaxy is traveling super quickly through the Virgo cluster, about 1,500 kilometers per second, which is actually fast enough for it to escape. So it's trying to make a break for it, actually. Should be kind of interesting. I'm sure its partner galaxies would be sad to see it go. Oh, we got some fancy technology going on here.
Yeah, this galaxy is also traveling towards us, not as quickly as it's traveling through space, but it's kind of heading towards us, traveling at 383 kilometers per second. Based off of its velocity towards us and its distance from us, it will reach us in 46 billion years.
That's a long time.
Yeah, so once again, that's out of our comprehension.
Can't comprehend. I think I'll be like 50 by then.
That's how it works.
Yeah.
This one is pretty similar to the last. In terms of its star formation, there's stars being formed in the center. That's why the center of this galaxy is bright. And then on the outside of the galaxy, it's lost a lot of its star forming material. And that has led to the outer dust bands being significantly darker.
That's a nice picture.
That's an excellent picture.
Nice job, boys. Awesome. Should we move on to the next one? Let's check the sky off. M90. Oh, we got a bingo here. We got a bingo. Nice. All right, so M91 is going to be the next galaxy. Kind of going right in order a little bit. And this is going to be another spiral galaxy, and you guessed it, Virgo. So here we go. Getting on the screen here. Let them get a little bit longer in exposure. Let them play with the colors, and we'll start to see those features pop. This one's a little further away at 63 million light years.
Oh, this one is the faintest of all Messier objects.
And the most difficult to observe.
So if we can get anything from this, even if it's a faint smudge, I will call that successful.
Pressure's on, Gavin. Let's go.
However, yeah, Gavin and Dylan are experts. So if anyone can get any feature out of this, it will be them. But with these images, we're taking exposures over 30 seconds, so we have to wait. Oh,
wow,
that looks pretty good. And that is like textbook barred spiral galaxy.
Oh yeah, that's like a. It looks like those like S's you used to draw in like elementary school.
In like fifth grade.
Yeah, that's what it reminds me of. So we should call it whatever those.
Let's see if there's any suggestions. As for what this should be named.
I don't think those S's had a name, but they were.
Is it the S that you would draw 3 lines and then 3 lines and connect all of them?
Yeah, do we have a pen? I'll show you. I'll use this.
We're doing some Lowell art. But yeah, this
oh, I did it wrong.
Is an excellent barred spiral. You have the bright core in the center. You have this. Oh, I don't know I'm doing that. You have this bar like structure coming off, and then off of the end of the bar, you have these spiral arms.
Yeah, that's a good one.
Yeah, if there was a textbook version of a barred spiral, it would be this. It's great. This one looks like Vader's TIE Fighter. Oh, I see it. Darth Vader's TIE Fighter. It's in Star Wars too.
Yeah.
Okay.
I know who Darth Vader
Yeah.
is.
So, but you haven't watched Star Wars, so yeah, his TIE Fighter has a circle in the center and then it's curved on the edge. I really like that. We'll go with that suggestion.
Here's my beautiful S that I drew. For everyone to see.
Yeah.
I know you know what it is. That's where I got all my art skills from.
Yeah, so that actually came out a lot better than I was expecting.
Yeah, for the faintest Messier object.
Well done,
Props
Gavin
to
and
Gavin and
Dylan.
Dylan. Snaps. Nice. Oh, this one is also oh, okay, we'll talk about it in the next one. So the next one is going to be M58. So that's going to be another spiral. So let's check off M91. Oh, we got a stupid bingo here.
Ooh.
Let's switch it up. I'm gonna put my
Oh, all right.
Okay, so M58 is going to be another barred spiral galaxy in Virgo, similar distance from the last one, M91. Oh, this one looks like it's going to be cool too.
Yeah.
So
I see
M91
what they're doing.
and M58 are classified as anemic galaxies, meaning that they're spiral galaxies with very little gas and a low rate of star formation compared to similar galaxies. And again, this is due to that ram pressure stripping that we were talking about earlier as it moves through the Virgo cluster. So that was a new term I learned, anemic galaxy, kind of interesting.
Galaxies, yeah.
Yeah. This one looks fainter than the last. Super interesting.
They're taking a 30
Oh, I see.
Yeah, so they're taking
I
10
see they did it.
seconds, centering it, and then taking a longer exposure.
That's what I like to see. All right. Nice. Looks like we got a big bright star off to the right there too.
Yep, and as Angel said, and as we've seen in a couple of these spirals, very bright center core that has star forming regions, and then these dust lanes around the center of the galaxy just aren't forming stars. Just because of this giant gas cloud in Virgo.
Ooh. And that's interesting. I can see like a tiny little dot in there.
Yeah,
I wonder if that's anything significant.
Yeah. So that could be a star forming region that just has enough dust.
You know, this is, I had written down one of the rare galaxies to have what's called an ultra compact nuclear ring, UCNR for short, which consists of multiple starburst regions that's found within a very small ring around the galaxy's nucleus. So maybe that might be what we're seeing.
Yeah.
That'd be interesting if so.
If there were star forming in this galaxy, we would see a lot of those bluish dots that we're seeing just above the core of this galaxy.
Yeah, this is a cool one. Cool. All right.
Oh, we have to name this one too.
Oh yeah.
Any name suggestions?
Oh, we didn't.
This one looks like a cheese Danish. Ooh, kind of like that.
Cheese Danish, they're pretty good. Not too bad.
All right, so we've had Star Wars references, and now it's getting to that point where we're gonna have our midnight snack of a cheese Danish.
We don't have cheese Danishes here.
Or
though,
1 a.m. snack of cheese Danish.
We'll have to have Cheetos instead. I think.
Yeah.
Close enough, right?
Mm-hmm.
Awesome. All right, so that about wraps up our time here. So thank you guys for listening, tuning in. We're going to hand it back over to Gavin and Dylan. We're going to take a little break first. So take it away. See you guys.
Yeah.
Hello, we're back.
Hello again.
It's Gavin.
And Dylan, your two
And-
favorite educators.
Yeah, exactly. And more Messier objects. And so I've heard that we have just hit 60 objects now,
Woohoo!
which is a lot. That's over halfway. So we're getting there. It's I want to say the final stretch, but I guess it's just over half. But
Yeah.
I guess still final.
It's our final stretch.
Yeah, it's not the
So-
start.
Yeah.
So
True.
yeah. And so might as well start it off. We're gonna hang out in Virgo for a little bit. And so the first object is M59.
M59. Yes, sir.
Is that a favorite or just
No.
like the sound of it?
I just like the sound of it.
Okay. I can't blame you for that. It
Yeah.
does sound nice.
So this guy here is about 50 million light years away.
Ooh.
This is an elliptical galaxy, so a football galaxy,
Okay.
as we were saying earlier.
So we know what to expect.
Yes.
Okay.
And while the telescope does its thing and Angel do their thing, we'll wait for that.
Yeah. And so estimated at around a couple 100 billion stars within it. So more than a couple, but not too many. Not too many. A nice considerable amount.
Absolutely.
And we've been talking about a lot of objects that have been discovered by Pierre McCain, and this one is not. We finally have a new person in the mix here. Before Charles Messier added it, and it was 1779, so a couple years earlier than the previous objects. And it was Johann Gottfried Kohler. I think that's how you say it.
Cooler, yeah.
And ironically, was trying to study a comet when he found this.
What's up with these guys in comets?
Exactly. It always comes back to the comets. It was actually Comet Bode that he was observing, and then he noticed it and noted it down. He also ended up seeing the next object that we're going to see as well, M60, because it was in the same section of the sky. And Charles Messier, guess what? 4 days later, was trying to study the comet, found this object. So right around the time, Messier also saw M60 as well, but also actually found M58. So he actually found one more. It was actually the last object that Angel and Matt saw.
Nice. And then real quick, you can actually kind of see almost some like background galaxies here in the upper left-hand corner. There's one there, and then like a fainter one off to the left, right about there.
Yep.
And it's just amazing, you know, stuff we can see.
Yeah. And speaking of, we've actually found globular star clusters in this one, and a considerable amount, a very considerable amount, 2,200 globular clusters roughly. And to put that into perspective, that's around 100 or around 10 times more than the Milky Way.
Wow.
So a lot.
That's crazy.
Yeah. And another thing that I like about this object as well, that's kind of different than other ones. The inner 200 or so light years from the core actually rotates in the opposite direction as the rest of the galaxy.
Wow, just like the one from earlier.
Yeah, but the thing that makes this one different, it's the smallest region in a galaxy that's known to do this.
Wow.
Yeah. All right, and that's looking very nice, especially with the other galaxies that you can see in there too.
Galaxies,
Yeah,
absolutely.
you can never go wrong looking in Virgo. There's always so much to see.
Absolutely.
All right, shall we move on to the next door neighbor?
I believe so, yeah.
All right, so M60 is going to be our next guy up to bat.
I believe this is another elliptical style galaxy, so another football guy.
All right.
For our football fans out there. Woohoo.
I guess for me, I'd like to think of it as like a sideways hockey puck.
Yeah, there you go. Yeah.
Yeah, just to try to relate it back a little bit there.
Sideways hockey puck. I like that.
Yeah, kind of like on its edge.
Yeah.
Yeah. Almost like kind of like actually sombrero, the later object that we'll see too, is kind of a little bit like that as well.
Yeah, definitely for sure. So this guy is 57 million light years away. And as Gavin said, it's still in the constellation of Virgo.
And there we go. Okay, so there's a bunch of galaxies there in general. There is a ton. And so I'm trying to find what the secondary galaxy is there. So the brightest circle there, that is going to be Messier 60. But like right behind it there is another galaxy. And so I'm trying to get that name right now.
It even looks like a little spiral galaxy, kind of.
It is. Okay, so it's the spiral galaxy NGC 4647. So it's 2/3 the size of M60. So M60 is bigger than it by far. But yeah, it has a little companion. He's not lonely, which is nice.
Absolutely, yeah.
Especially space is kind of spacious. And so having a little and there's my bad joke of the night. I'm not promising there's not going to be more. It's just that is the one. But yeah.
So that was very punny, wasn't it?
Yeah, you can tell that it's getting late in the morning, the day, in the night.
Actually,
what would you
morning.
consider? Yeah, what would you consider like 1:15? Would you still say it's late at night?
No, it's the morning. Technically, it's the AM. AM.
Okay.
Right? I don't know. In the chat, what do you think?
Yeah.
1 a.m. night or morning?
This is the big question.
Yeah. That's the biggest question we're gonna ask tonight. Just kidding.
And so the galaxy that we're looking at there, or the main one, M60, around 400 billion stars within it. So roughly around the amount within the Milky Way itself.
You know, it's always kind of fun to see all of the different shapes, sizes, and kind of the way that, you know, these galaxies are in our universe. And that's pretty awesome.
Yeah, there's 3 different styles within the viewfind right there.
Yeah.
It's the big elliptical that's more face on that we're seeing, which is why it looks so much wider there. Then you have the spiral behind it that's also face on. And then off to the side there, you have a little more edge on of a galaxy down there.
Absolutely. So we got a question. What causes some galaxies to move faster than others?
Take it away. Not to set you up there, but
I actually don't know.
Me
Do you
neither,
know?
actually. I
have no idea.
It's
That's a
also
good
hard because
question.
like I'm learning this stuff right now in school, so it's still getting there, but I'm not sure because the universe is expanding, and so how that plays a role into why different objects are moving at different speeds exactly.
Yeah.
I
don't know. That's okay not to know. It's always a learning thing.
It is.
Yeah.
And that's asking questions is the way to do it. So
That's how we all learn, you know.
So
great question.
I will try to
We don't know.
and so I'm going to ask the question and try to find it as well. But yeah, so it is also kind of our perspective as well, because like if I'm standing next to you and you're moving at a speed, it looks slower than like somebody else in a different spot, or vice versa, or faster. And so a bit of that too. Dark energy, yeah, that's getting into a lot of questions.
Yeah.
Okay, while we try to see if we can find answers for that, should we move on to The next guy.
Yes.
Oh, we haven't been signing it.
Oh yeah, we've
Okay.
been slacking on
We have. Okay.
signage duties.
59 and 60 are the ones we've done. We might as well start getting M49 while we do this.
59, 60. That's S, not C. There's a Dylan C, but I'm Dylan S. So
Close
that's,
enough.
Yeah.
Oh, that's okay. Okay. I'll
Shake
take.
and
I'll
bake
take.
that
Yeah.
Got to shake and bake that pen, my friend. This is another elliptical galaxy, M49.
It is.
We're the elliptical lovers over here.
We really are. We just have all the ellipticals. Elliptical, isn't that a type of workout machine as well?
It is, yeah, it's like the jog in place thing. It's kind of like, I would rather just run on a treadmill. Well, I don't do much running, but you know, yeah, sure.
And so another reason why some galaxies farther away could also be moving is because there's more space between us and them. And if all space is expanding at the same rate, then just having more of it would make it move faster. So, okay. I feel like that's a good, we've gone a good base for that question.
Yes.
All right. And so 49. Hello. Nice to see him. Okay. So what do we have on 49?
So I have here that it's a giant elliptical galaxy that's 56 million light years away. And kind of funny, what we've kind of noticed is, well, what I've noticed is that a lot of the Messier objects here are around 50 million light years or less, which is kind of interesting.
It is, yeah. And so we've talked about the discovery a bit, especially with our objects, and a lot of them done by Charles Messier's colleague there, and also a couple other professionals in the field. This object, M49, Charles Messier himself discovered it, wow. Which is nice because he did actually discover these objects, not like for the first time. There are other ones that he also discovered himself. And so 1771 is when he discovered this. So like 10 years before a lot of the other galaxies that we were seeing before and talking about. And this was actually the first object discovered in the Virgo cluster of galaxies.
Oh, wow.
So yeah, it's a little bit notable in that sense.
Something else that to mention is that the nucleus of this galaxy is actually emitting X-rays, which is suggesting kind of that there is a presence of a supermassive black hole, which is pretty awesome. That's emitting a lot of energy out of that kind of corridor.
Yeah. And okay, so I mentioned that it was the first object discovered in Virgo cluster of galaxies, right?
Yep.
Also, first elliptical galaxy that was detected outside of the Milky Way's local group. So just like there's so much about this, and also we talked about like previous object 2200 globular star clusters we found in it, which is 10 times the amount known in the Milky Way. This guy around 6,000. So just blowing the number out of the water of star clusters within it.
It's pretty amazing.
It really is.
So also another fun thing about this guy, I guess there has only been one supernova event ever recorded since we've actively been looking, and that was supernova 1969. Q, that was discovered in 1969. How? That's another fun thing.
Yeah.
Astronomers are really bad at naming things.
They either go like super blunt with it, like, hey, this thing looks like a glob, so we're gonna call it a glob.
Yeah.
Or it's just so out of left field. Like the wild duck cluster is
there's no duck.
There's no duck.
No duck.
But
in a wild duck cluster.
Maybe I just don't know what a duck is. If that's what, did ducks look differently back then?
No.
Okay.
Maybe, I don't know. I mean, chickens look different now than they did back then.
Maybe ducks look. More similar? No, there's no way. There's no way.
Slap happy. This is what you get. Slap happy educators talking about ducks and chickens.
And a good point that was made is that, yeah, just birds aren't real. But no, please
They're also
stop.
dinosaurs too. Think about that.
Yeah, they are more closely related to dinosaurs, aren't they?
Yep.
That's.
Have you seen an emu? Emu looks like a dinosaur.
It does. It really does.
Oh man.
All right, so now for the dinosaur part of the live stream.
Right. Back to your paleontologist.
All right. And so now that we have M49, we should probably also make sure we're signing.
Gosh, we're so slackers.
Yeah. Okay, so we can start getting M61 yes, please, while we do this. So 49 is somewhere here.
That's almost as bad as mine, dude.
That one gets a smiley face just because I feel bad about that signature.
That's right. Mine looks like it's different every time. Yeah, good enough.
I like it.
Right. Cool.
It's the effort that's
We'll give it a little shake and bake with our little pin so it stays alive.
Yeah. I don't want it to end up like the previous guy. All right, and so we are moving on. Messier 61. And so we did have a lot of fun with ellipticals. Not gonna lie, we had a good little run there. Still stand within Virgo now. Spiral.
They're my favorite.
Yes, I will agree with that. They're just
so much more
how could you
to look at.
How could you not love it? Especially because you got to think that like the Milky Way we believe should be a spiral, so you got to have a little bit of favoritism towards it as well. And that is looking really nice. There's also all the satellite galaxies around it. Ooh. Okay, and so you'll notice there that at the top of it especially, and on the left side, a lot of blue. And so that's going to be a lot of the like new bright blue hot stars that are forming within these clusters. It is a starburst galaxy, and so that means it has a lot of these forming.
Yep, and it's also a barred spiral galaxy too. So there's a little bit of that kind of like big bar section right in the middle, and these big, large swooping arms coming out like that, which is always fantastic to see. Because how can you not like those big spiral arms, right? Especially when you have the elliptical galaxies, which look like footballs and kind of boring. But spirals is where it's at.
You and your footballs.
Hey, now. I used to play back in the day.
That's fair. And so into the discovery a little bit, because that's always yes, thank you for petting the galaxy. And so into the discovery, always fun. This one is a little bit of a fun thing as well. So it's considered discovered in 1779 by Italian astronomer Barnaba Oriani. There's no way I pronounced that right. But Charles Messier noticed it on the same night as him. Like, what are the odds that they both noticed it? But Messier mistook it as a comet. He was the comet on the brain. And so he saw this and said, yep, that's just a passing comet, and mistooken it.
Didn't you say the king's was the comet ferret? Was
the comet ferret.
Maybe this guy had a brain of a ferret because no, I'm just kidding. He was a very smart guy.
Yes.
Oh, this one is 52 million light years away. I don't know if we mentioned that or not, but so again, it's in that same kind of range, pretty much. And
for this guy, 8 supernovae have been discovered in 61. And that's starting in the 1960s and all the way up to 2020. Again, just a couple years ago. Or actually, sorry, 1926 was the first one. My mistake. But yeah, so about over 100 years, we found 8 supernovae in this, which makes sense. Again, it's really common in these like rapid firing of just star forming galaxies.
Absolutely. Let's talk about the supernova just really quick. So
yes, we've been using that word a lot.
Yeah, supernova is a giant explosion of a star, a very large star. When it dies, basically the core collapses, or the whole star collapses in on itself, and then it kind of rebounds in this giant explosion. But these explosions are so incredibly bright that they can shine just as bright as their host galaxies for, an X amount of time. And to me, that just is amazing. You have one single object that will shine as bright as the galaxy for a little while. And that's just immense amount of power and energy, which is amazing that these things even exist, It's just crazy.
Yep. Okay. And so it is a very exciting time for me personally.
It is.
I'm so excited. It is time to move to Messier 104. So if we can please get that one coming up, and then we might as well sign for 61.
61. Here you go, sir. I'll let you do the honors.
Thank you. I also noticed that M61, it kind of looks like it's almost jagged shaped. It's not like, it doesn't look completely smooth. It's like jagged.
Yeah.
Which is fun. All right. And so we are going into a very awesome galaxy. I don't know. I feel like wait for the reveal in order to see what people want to call it, if they know what it's called.
Yeah, that'd be good. That'd be a good thing for the chat. See if those star lovers out there know which galaxy this is. And we're almost there. And wow, that is a fantastic photo just right out the gate.
Yeah, just like I'm starting with that guy. It's just awesome. And so also one thing I want to just also verbally say, because it is in the chat as well, M104, first galaxy that Vestos Lifer observed to be redshifted.
Really?
It was, yeah.
Actually,
so that was
that one. So that's a good one.
Yeah. Speed of 700 miles per second away from us. So just really awesome, but it looks amazing. I would love to know what people think. Okay, so we have a giant galaxy, ravioli.
A ravioli.
Ravioli.
Yes.
That's pretty awesome.
So the Big Bang did not create this galaxy. It was Chef Boyardee.
Amazing. Okay, and so we've been teasing it, but the actual name, the Sombrero Galaxy.
Sombrero, yes.
And so yes, someone did actually say that. So Sombrero Galaxy, edge-on galaxy, absolutely incredible. We have that nice dark dust layer around the outside that's given that nice definition within it. It's just amazing. Like, how can you not love this object?
Yeah, this guy is 31 million light years away.
That's a couple.
Just a little while. Its diameter is approximately 49,000 light years across. So it's actually quite a smaller type of galaxy. It's 3/10 the size of our Milky Way. So just to kind of put that in perspective, and our Milky Way is 120,000 light years across. So pretty crazy.
And so this one discovered 1781 by Pierre McCain. But Charles Messier, what's interesting, this is one of the objects that was added later in the list. Wow. And so the original Messier object catalog was only 103 objects. It's now 110 because of things like this, where Charles Messier had a note that talked about this object and a couple other ones, actually 5 other ones. But he never published them in his official catalog. And so it wasn't until later on in the 1900s that people actually started to look through this and added it to his official list, because he did make note of it.
Wow. It's pretty crazy. Now we can easily see the large central bulge there in the center. And then of course, like Gavin pointed out, that beautiful dark dust lane out on the side here.
Yep.
And it's kind of fun. Like a lot of galaxies, you think, and it's really kind of thin if you really look at it, at least from the perspective now, if we saw this thing probably, face on, it would probably it wouldn't look that kind of thin, but it's kind of interesting.
Yeah, it's weird. Again, the different perspectives, that the weird phenomenon that you can get.
Yeah.
Someone also said Saturnus galaxy. I like that because of that dark ring around it. I actually really like that.
Absolutely.
And so this is just okay. And so this is just beyond the capability of your eye being able to see it, but it's only a magnitude 8, which our eyes can see to around magnitude 6. This is in the positive scale. 6.6 is kind of roughly where our eyes can see, depending on every person is different. And so the more positive that an object gets, the harder it is to see. The more negative an object gets, easier it is to see. Negative is actually bright objects. And so it's 8, which means that even just like small little telescopes, like it really wouldn't take much to see this guy, at least to see the core there, that bright spot.
Yeah. All right. You think our small little telescopes can see it, like our own personal stuff?
I think they could.
Yeah.
Yeah.
Yeah. Of course, the Godo ones can. Obviously, we're looking at it with one of the Godo telescope.
Okay, and so this object is one of the most massive objects in the Virgo galaxy cluster. Estimated the mass of this, 800 billion suns.
Holy
So, yeah, not just talking about like kilograms or pounds or something like that, like hundreds of billions of suns.
Suns, yes.
So, yeah, there's a lot in there. All right, and so move on.
Yep.
All right, we will sign the board, and
the
as
board.
we can get M68, please. Right in the corner there. Very nice. All right.
Perfect.
And so the Sombrero Galaxy, we'll see the Lax Galaxy in our section. We'll have to say bye to it.
Tears.
I know, very much
Lax
so.
Galaxy.
Oh, yeah, we see the
Waving
wave hand.
Yeah, waving goodbye.
Yeah, it's sad. But we're going to move on to a different type of object now. I think we've only talked about galaxies, actually.
Yeah. Yeah. I don't think we've had any other kind of object.
No, but not only a different object, but also completely different constellation. Hydra is where we're moving now. And so you can see there, not a galaxy, not a nebula. It's a star cluster, and specifically a globular star cluster.
So another thing we want to know from the chat, how would you describe this thing? Because we here at the observatory, we have a whole list of what people think these objects look like. So it'd be really interesting to see what you guys think this object looks like. So I'd love to hear your input on that.
Yeah, we'll be checking that out because I'm very interested. And so now we're moving on to a globular star cluster. And so this is going to be made up of hundreds of thousands of stars that are all stuck together there. And so like we've compared to other galaxies, there's only roughly like in the 1 to 200 range of how many of these are in the Milky Way.
Yeah. Wow.
And so see Dippin' Dots, that's a new one that I haven't heard. Ghost Cluster, I like that. Spilt glitter on the floor and it took forever to clean up. That feels so oddly specific, but I love it.
Yes.
Glitter bombs. Okay,
Glitter
so
bombs,
a lot to do with glitter, which I can understand because especially with these older objects, they do seem a bit more glittery because they have that nice golden color to them. They're usually more yellow and red, and that's representing that the heat is a lot cooler than blue stars, but also that usually correlates to the age of them as well.
Dippin' Dots, that's another one that someone said. Dandelion flower and 1 million ants.
1 million ants is
1 million ants.
interesting. That's a specific number. I'd love to know
Very specific.
how to calculate 1 million ants, if like the difference between that. This seems like a science experiment that would not be approved.
Probably not.
And so a fun one that I once got was Microsoft old intro. I feel like that might have been before my time to understand that, but apparently Microsoft old intro is something that relates to it.
Yeah. I don't see that.
Yeah. And so this cluster is going to be inside the Milky Way itself. It's actually only about 33,000 light years away from Earth. So it is still like relatively far for within the Milky Way.
Yeah.
But for the objects we were talking about up to 60 million light years away, and we're at 33,000. So much, much closer. And that's why the object looks really big, but like this is only 100 light years, maybe give or take, in diameter. So it's a lot smaller of an object, but it's just so much closer to us that it looks like it's just as big as a galaxy.
Yeah. So another fun thing, looking at globular star clusters here at the Open Deck is probably one of my favorite things to look at, especially through our 32-inch star structure telescope.
Yeah,
oh,
I've come to appreciate them.
It's beautiful. It almost brings like a tear to your eye. I know I'm sounding dramatic, but it's really that beautiful.
We could always use a bit of dramaticness. Come on.
Theatrics.
That's great. Exactly. All right. I feel like that's good for M68.
I think so, yeah. M68.
All right.
We can knock that one off the message board.
And so then that brings us down to the single digits of Messier object, Messier 5.
Messier number 5.
Yes. And so I guess we should sign this and then we can
Sign
talk about the
board,
object. Yeah. So after you.
All right, Kevin.
Thank you, sir. I can't even.
That's a me signature.
That one turned a little McDonald's on us.
Have it your way.
What?
No, that's not it, huh? I'm loving it.
I'm loving it.
That's
yeah,
right.
there you go.
Right. Well, I'm loving this chat here.
Yeah, what I'm loving it joke can we make about Messier objects? I'm really trying to figure it out.
I don't know.
I'll think on that.
Ooh, I like this one. This one is much more big and bright. I love it.
It is. It's in your face, and I love that.
Yeah, absolutely.
And so now we are on. It's from McDonald's, of course. And so Messier 5, a globular star cluster, and a new constellation we haven't talked about yet, Serpens.
Serpens, yes.
And so, what can you tell me about Messier 5?
It was discovered by Godfrey Kirch in 1702. So
okay.
This area was just like a hotbed of discovering these fainter deep space objects.
Yeah.
Again, we should just go back in time and like know all these things, and just then we would have our names. It would be the GD Gavin Dylan list. That'd be fun. Yeah.
I like that. Yeah. And so over 100,000 stars within this. And after this, I feel like after this object would be a good time that we talk about globular clusters. So we can explain that a little more in a couple minutes. But for this object itself, it is actually within the view range of our eyes.
Really? Wow.
Yes, assuming you're in a completely dark sky area with no weather restrictions, it is at a magnitude of 5.95. So technically within that threshold, but just barely. And so that would be one to test out using your peripheral vision and whatnot to try to see objects in the sky. But Messier 5, also over 100 stars within it are variable stars. Yeah, so variable stars, and actually 97 of them are this whole other classification, usually referred to as cluster variables, are variable stars are going to be stars that we know change their luminosity, and we know the relationship between the time and how bright they typically just fluctuate in their brightness. And so objects like Messier 5, having tons of them, have really helped us to understand how to judge distance in space and how to calculate that, and how to really it's helped with a lot of calculations, actually.
Absolutely. So you mentioned a little bit earlier about having perfectly dark skies. I think this would be kind of a good point to kind of talk a little bit about like the dark skies, right? Well, Flagstaff, for those who don't know, was one of the very first dark sky cities. I believe we were the first international dark sky city is our claim to fame. So
yep, 2001, I believe.
And of course, Lowell Observatory and the surrounding observatories have had a huge impact on that as well. But and I'm so glad that the city of Flagstaff, you know, our friends and family, people down there, you know, do this, because we wouldn't be able to have this beautiful chat.
Yeah, and it did actually start kind of with the observatory as well. Back in the 50s, around that time, the observatory was really trying to like convince the city that they need to start regulating the sky, because 50s, around that time, like light pollution is really becoming a thing now.
Oh yeah.
And so Flagstaff was also the first place to actually put in light ordinances.
Yep, in
1958. Okay, yeah. So 1958 is when the first one. Yes, thank you, Kevin. Yeah, so not only first light ordinance, but then first international dark sky place.
Absolutely.
So really kind of in the forefront of that side of the industry of trying to protect the night skies, which is an important thing for me too, because yeah, like you were saying, when we're just up here at the observatory, like you don't need a telescope and you can just see the Andromeda Galaxy in the sky.
Absolutely.
Which you cannot see in Phoenix.
No.
Or not even close. And it's just absolutely magnificent. Okay, so the light ordinances, that first one in 1958, thank you, Kevin Schindler, was when Lowell was trying to bring the Perkins telescope from Ohio here to Flagstaff. And so when that was happening, wanted the conditions to be good.
Yeah, absolutely. Yeah. One of my favorite things, being an educator, and a lot of times showing people for the very first time their very first view of a dark sky. And sometimes I see just folks just kind of like looking up into the sky, and I'm just kind of like, you okay? You know, because it kind of looks like they're sad or kind of lost, but they're like, no, I'm just enjoying the sky. I've never seen the stars so awesome before.
And that's like me too. I still catch myself doing that, and I've been here long enough, but like, yeah, I'd never seen skies like this before coming to school at NAU and then working here.
Yeah.
Flagstaff is just unmatched skies.
Yeah. Another little fun fact from Kevin Schindler. His favorite fact, or one of the favorite facts, is when Percival Lowell arrived in Flagstaff, the community's nickname was Starlight City because of how brilliant the stars looked in the sky.
I think that's accurate representation.
Yeah, I think that still should be our nickname for the sky.
It really
for the city. I mean,
it really should. Yeah. Like cities have slogans, so that should like really just be on there. That should be Flagstaff's.
Yeah, absolutely.
And so it did mention that we would come back to globular clusters, though.
Oh yes,
and different star clusters.
Tangent. Sorry, let's come back.
Absolutely, it doesn't matter. And so, do you think good time to talk about that?
Sure. Yeah.
All right. And so we've talked about globular clusters, and then we've talked about open clusters. And so, what is the difference?
So the main difference visually is globular clusters. Well, they look like big globs of stars.
Yeah.
And then open star clusters, well, they look like these same kind of structures, but a little bit more open. They're not as like more, whereas globular star clusters have hundreds of thousands of stars. These other star clusters, the open star clusters, have maybe a few hundred to a few thousand stars. And how they form is incredibly different too. You want to elaborate on that?
So open star clusters we still see those being formed today. A good example is the Orion Nebula. We see the Orion Nebula, all the gas, but then if you really get into the heart of it, there is the trapezium, which is an open star cluster that's forming in the center of the nebula. And so these stellar nurseries, as we call it, where we see these stars being formed, once all that gas is used up, there'll be hundreds to thousands of stars sitting there, and that will be the open cluster. And then they're gradually drifting away from each other. Like an example is the Pleiades or Seven Sisters or Subaru.
Yep.
That object, after a couple rotations around the Milky Way, completely gone. All the stars have drifted away from each other. Versus globular star clusters, there's not a for sure answer. I know two different ways that we think that those form. And so I would love to know how do you think globular clusters form?
So I believe one of the theories is that these were actually kind of like the core stars of really ancient galaxies. And as the Milky Way and these other galaxies kind of collided with galactic cannibalism.
Yeah, the best term ever.
Best term ever. So these are kind of like the granddaddy stars that are kind of on the smaller-ish side, and they kind of live for a long time. So these are the stars that kind of lasted the test of time after the Milky Way kind of like stripped or kind of converged with the other ones. Is that similar to what you've heard?
Yeah, so that's one that I heard. Yeah. Another one is that they're actually from the Big Bang. Like not directly, a little bit after, obviously you need time for everything to happen, but kind of similar style of the open star clusters, how they end up forming in these gas regions. Right after the Big Bang, there's tons of matter everywhere. Right. And so think of that being so much larger and so much more gas and matter that it just creates more stars that are closer together and end up forming these globs. Because the oldest glob that I've seen estimated is 13.2 billion years old, which is the universe is at roughly 13.8 is the current age of it. So line up to like when galaxies were young.
Yeah.
And so I guess there is a question here as well. Are the Seven Sisters part of a larger star cluster?
I think they're their own cluster.
They are, yeah. So the Seven Sisters or the Pleiades are their own open star cluster. The brightest stars are, if you're trying to talk about just the bright stars, yes, they're within the star cluster, right. But another nickname for the Pleiades is the Seven Sisters. And so that is its own star cluster. And actually there's like over 1,000 stars now estimated within that cluster.
Wow.
Yeah, even though there's just those bright ones.
Very cool.
Yeah. And so, yeah, there's different types of star clusters. And so you can see the visually as well, because especially with how old globular clusters are, that's why, as you see on the screen, they appear that yellowy color, because usually they're stars that live so much longer versus other ones that are so blue because they're really fresh stars. And so that's why they're still that blue, really hot color. Okay, and so
fun fact.
Yeah, and so another fun fact, in 2020, a team including Lowell's Kyler
Ewan?
I can't pronounce names.
I'm so sorry for butchering your name.
Just Keen.
Keen, thank you.
Thank you, Kyler Keen. And discovered a shredded globular cluster torn apart by our own Milky Way galaxy. Wow. Actually, I think I remember seeing a graph of that like we see this kind of like trail of like what's left of it kind of around us.
Yeah, that makes sense.
Which, yeah, because the Milky Way comparatively is going to be huge. And so I think it is kind of the end, unfortunately, for our time.
It is the end.
And so we're going to be going on to another break, and then you guys will be joined by another set of educators that will be walking us through the last of the Messier objects, because we're at 67, I believe now. Yeah, 67. And so, yeah, thank you guys, and we'll take a little break now.
Thanks for sticking out, guys.
Thank you, guys.
See you in a little while.
Welcome.
Hello.
Hello. We are in the final stretch of the Messier Marathon.
2 a.m. Woo!
Woo! Woo! All right. So I'm sure a lot of you regulars know me. I'm Haley Osborne, one of the educators here at Lowell, and I'm joined by two of my awesome coworkers. Woo! Do you guys
Hello.
want to introduce yourselves?
Yes. I'm Nina.
I'm Peter.
Cool.
Yep.
All right. Well, before we get to talking about what's on the screen here, Peter, I think you had an answer to someone's question.
Yeah. So we had a question of kind of what you need to study or to get into astronomy, or what kind of field you need to go to. And honestly, like I feel like what's great about astronomy is there are so many paths to get into the field. I know that a lot of people, there's the classic kind of, studying, majoring in astronomy, and then pursuing it that way and then going to grad school. But there's a lot of ways to contribute to the field. A lot of people, come in from other STEM fields, like maybe, more physics or chem or bio, or anything really. Or some people, I think, can even come from totally different fields in the social sciences and everything. Astronomy is a really, is you can get into astronomy kind of, I think, from any of those fields. And then, you don't have to just like follow that path of, undergrad to grad school. You can become a science communicator. You can assist in researcher. There are a lot of different ways to contribute to the field that aren't just, the classic path of undergrad to grad school. So I think to answer that question, I think you can kind of tackle astronomy from a number of different angles, and still contribute to the field and have a really fun and fulfilling career.
Well spoken.
Thank you.
Thank you, Peter.
All right. So let's go ahead and talk about the object that is currently on the screen. This object, we're going to be seeing a lot of these types of objects. This one is M13, also known as the Hercules cluster, and it is a globular star cluster. So globular star clusters, they're very, very old stars. In fact, they're much older than our galaxy is. I almost said our universe. That is not true. They're older than our galaxy. Now this one specifically, I really love M13 because it was actually discovered by Edmund Halley, who is my namesake. So yes, I'm named after Halley's Comet. Technically it's Halley's Comet, but whatever, we'll ignore that. Yeah. Logistics. Who cares? So this was discovered in 1714. It was cataloged by Messier in 1764. So what is that, 50 years later it was cataloged. So yeah. Now this one, it's actually kind of closer than a lot of globular star clusters. It's about 22,200 light years away, which obviously sounds like a really, really far distance, but it is still within our Milky Way galaxy. Now, the really cool thing about this globular star cluster and a couple others, actually, I think most others, is the stars inside are so close that sometimes they'll actually collide and make new stars. And those new stars, they're called wandering blue stars or wandering stragglers. No, just stragglers, sorry. They're called stragglers. So yeah, these stars, they're about 12 to 13 billion years old. So they're pretty old out there. And there's approximately 300,000 of them. So yeah, now the Hercules cluster is of course in the constellation of Hercules. And the story of Hercules is definitely not anything like the Disney version of Hercules, right? Hercules, he was put through these like crazy intense trials. But yeah, it looks like, so on the back end, we've got Claire and Jacob right now, and they'll be joining you guys hosting in a little bit. But it looks like they are trying to communicate something. So
like they're showing.
I think they're showing us. They're showing us
okay.
The constellation. Yeah.
Okay, gotcha. This is always super fun trying to communicate with people on the back end.
Thanks,
But,
Claire and Jacob.
Thanks, guys. Sometimes I like to refer to the Hercules cluster as a pain in Hercules' side because it's in the side of him on the constellation. But yeah, so right now we know about 150 globular star clusters. We're going to cover quite a few of them tonight.
This is the night of the globs.
The night of the
This is
globs.
the evening of the globs. There's a lot of globs.
I love it. All right, so we are going to sign the thing.
We did it.
All right.
Awesome.
Where is it? There.
M13.
Oh, hello.
And we could probably jump then to M92.
No.
M92 is the next globular cluster we're going to be covering.
Whatever. Here, sign it. I'll put mine on there later.
You want to do later?
Yeah,
Okay.
I'll just do it later for that
Awesome.
one because it's a little tricky.
The ones that we talk about or the ones that we take pictures of?
I think it's the ones we talk about.
We'll figure
All
it
right.
out. So yeah. So now we're gonna go to M92. This was labeled as the less cool glob in Hercules, and I resent that title greatly because I think it's way cooler than M13. I don't know why everyone's harping on I don't know why everyone's harping on M92. Even in the articles I was reading on it, it was said it's often overlooked for M13 by astrophotographers. So that's too bad. But anyways, yeah. So this object is about 26,700 light years away, and it has approximately 330,000 stars. So again, one of these globular clusters are packed full of stars. It was originally discovered by Johann Elert Bode in 1777 and published in the Berliner, I'm going to butcher this name, Berliner Astronomisches Jahrbuch, which is the Berliner Yearbook, which was a celestial navigation almanac published then in 1779. Then it was kind of rediscovered independently by Messier in 1781. As in fact, one of the galaxy's oldest clusters, kind of within the standard deviation of how we can age these objects. It's around 14 billion years old. So this is a very, very old cluster.
Yeah, so both of these are located in the constellation of Hercules. So we would like to tell you the story of Hercules. And like I said earlier, it's not the Disney version. This is the constellation story version. So if we just want to kind of like riff off of each other with this constellation story. But yeah, so Hercules, he was a demigod, a son of Zeus. And it's really funny because his Greek name, the Greek pronunciation is actually Heracles, which translates roughly to the glory of Hera. And Hera did not like Hercules, like at all. No. So I think that was a pretty funny choice on their part. But Hercules, or Heracles, he ended up having to go through these various trials. Do you guys know about any of the trials? Anything that you would particularly like to talk about?
Well, I know that one of the trials was the Nemean lion, who's actually often depicted as Leo, another constellation. I know that after Hercules slayed this lion, I'm now forgetting how he slayed it, but essentially the lion he strangled it.
Yeah, he strangled it.
Okay. Yeah. Because this lion had like impenetrable skin, and so then after he slayed it, he actually wore the skin with around himself, and often in kind of art he's depicted as wearing this lion skin. It was kind of his iconic garb.
Yeah, it's like it is impenetrable armor, so that's pretty nice.
Yeah.
So we're getting a lot of sass from the back end right now, talking about things that they want us to talk about. So one of the main things that people think of when they think of the trials of Hercules is Hydra. So Hydra is, in fact, not what Steve Rogers is fighting against all of the MCU. Not this Hydra anyway, especially because the symbol for Hydra in the movies has a bunch of tentacles.
It's like a kraken.
It's a kraken.
Yeah.
Like Hydra is known for having tons of heads.
Yeah.
And like in the fight against Hydra, Hercules, he would cut off a head and 3 more would grow back in its place. And that happened quite a few times. It took him a hot minute to realize that maybe he shouldn't be cutting off the heads. Maybe he should be going for, I don't know, the body or something. And so I forget how many heads it ended up with, but it was like an insane amount of heads. And so finally he ended up slaying Hydra. But yeah, Nina, do you have any trials you would like to add to one of the ones that the people are sassily talking about in the chat?
Well, you already covered Hydra, and I'm not sure what the Draco the Dragon one is. So if one of you two know the dragon one.
Yeah.
I think he killed a dragon once. I think that I don't know the story.
Yeah, I don't know the story for the dragon.
It was, I believe it was his final trial. Basically, he had to steal these golden apples from Hera's garden. Yeah, and the garden, it was guarded by Draco the Dragon, which they're pointing at there on the screen. It was also guarded by a couple of Atlas's daughters. And Hercules, he ended up tricking Atlas's daughter. So Atlas, he's the Titan who is always depicted as carrying the world on his shoulders. That was like his eternal punishment from Zeus for fighting against the Olympians in this like huge battle that they had. But Draco the Dragon, he was guarding this apple tree. And so once Atlas's daughters were tricked into leaving, Hercules had to fight Draco the Dragon, and he ended up winning, and he took one of these golden apples and he proved himself worthy of being a hero. And so in doing this, he got immortality and was placed among the stars.
Yay!
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 Good job, Hercules.
Go Hercules!
Awesome. I think we've got.
There's another trial. So the other trial is I forget how to pronounce it. Stymphalian birds. How do you pronounce that word?
I don't know.
They're these. They're these man-eating birds.
Oh my God, really?
Yeah. Yeah, it was one of his trials, and they're often depicted as Aquila the Eagle, which is a summer constellation that we'll actually be looking at later tonight, and Cygnus the Swan, which we also will be looking at later tonight. Stymphalian.
Yeah.
It looks like Stymphalian birds is the wording for it. But yeah, he had to fight these birds as well. There were an insane amount of trials for Hercules.
Yeah.
That was one of them. The Nemean lion, Hydra, Draco the Dragon. There was all kinds of different things that he had to do. But yeah, eventually he proved himself worthy of immortality.
Yeah, so there were 12 labors of Hercules total that he needed to complete to prove his immortality. So just in order, the first was the Nemean lion, which we talked about. The second was the Lernaean hydra, and then the Cernaean hind. These Greek words. Erymanthian boar, Eugaean stables, the Stymphalian birds, the Cretan bull, the mares of Diomedes, the belt of Hippolyta, the cattle of Geryon, the golden apples of the Hesperides, and then the 12th was defeating Cerberus.
So I forgot about that one.
Yeah.
So Draco was the second to last.
Yeah. Yeah, so he had to capture Cerberus, which is the 3-headed dog that also had a dragon tail. So
really?
Yeah, that's what it says. And it guarded the underworld. It says, yeah, 3-headed dragon-tailed dog. So
interesting.
Yep. They really get creative with their creatures in Greek mythology and the things that people have to do to prove themselves. Yeah. So
all right. So I think we're ready to hit our next object, yeah?
Yeah,
think
so.
Let's do it.
So next we are going to be headed to M12, which is a globular cluster in the constellation of Ophiuchus.
We're also being told on the back end that it is also guarded. It is also, I think that's supposed to say guarding the underground area in Harry Potter. So I think they're talking about Fluffy.
Yep.
It's Fluffy.
Yeah, Fluffy.
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 Welcome to the 2 a.m. slot, guys.
Yep.
All right. Okay. So it looks like we have M12 up. This one is also known as the Gumbel Globular Star Cluster, and I think that that is just, oh, there we go.
Wow.
Yeah, that's really pretty, actually. Yay, I like this one. I think the Gumball Cluster is just a excellent name for a globular star cluster because it kind of does look like gumballs rattling around in one of those containers where you put a quarter in. Yeah, so this one is approximately 15,700 light years away and contains 200,000 stars, so quite a few stars. It has a diameter of 75 light years, so it is very large across. Yep. And this one is approximately 12.67 billion years old. It contains 13 variable stars, and a variable star is a star whose brightness fluctuates either regularly or irregularly from our perspective on Earth. And it contains fewer low mass stars than they were expecting it to. So low mass stars are stars that are less than half of the mass of our sun. They are some of the smallest, coolest, and dimmest main sequence stars. And so there was just less than astronomers were expecting. So as a result, astronomers believe that these stars were stripped by the gravitational pull of the Milky Way galaxy. And they actually think that roughly 1 million stars in this cluster were lost this way. So there previously was significantly more, but now we have about 200,000 stars.
Right.
Yeah. And now if we want, we can talk about the constellation of Ophiuchus, because our next object will also be within that constellation. Yeah, so they're pointing it out to us on the Malin cam. Thank you, guys. So the constellation story of Ophiuchus is associated with Asclepius, who was the son of Apollo and the god of healing and medicine. And so the story goes that one time Asclepius was hanging out and the son of Minos, who was the king of Crete, fell into a giant jar of honey and drowned. I would personally love to find a jar of honey that is large enough to drown in. So if anybody knows where I can find one, just let me know. That's how I want to go out. But anyways, so he drowns in this jar of honey, and Asclepius is like, wow, that's not good. And then a snake starts slithering its way over to his body, and Asclepius doesn't like this, so he ends up killing the snake with his staff. And then we have 7 Messier objects down. Woohoo!
70.
70.
Definitely not 7.
We've only done 7.
Only 7.
Anyways, I don't think we signed off on the last one. So.
Oh, right.
Okay.
Wait, which one was it?
It was M92.
M92. I'll sign it and then you guys can follow.
Sounds good.
Okay, so I'll keep talking while we're signing. So anyways, so a snake slithers on over, Asclepius kills it, and then another snake comes and places an herb on the dead snake's head, and the snake comes back to life. And Asclepius is like, wow, that's cool. So he finds the same herb and he puts it on the son of Minos' head, and he comes back to life. And he's like, wow, that's really cool. So Asclepius becomes really, really, really good at medicine, and he becomes so good at medicine, and with this magical herb that the snake showed him, he is able to resurrect people and bring them back from the dead. And so he's doing this pretty regularly, and Hades, the god of the underworld, eventually gets upset that he is bringing people back from the dead. And so he complains to Zeus, and he's like, Zeus, he's taken my business. That's unnatural. I don't like it. Do something. And Zeus is like, you know what? Yeah, this guy is kind of blurring the line between human and God. So Zeus does what Zeus does, and he strikes Asclepius down with a lightning bolt. Yeah, and Apollo, who is Asclepius's father, is upset that this happened, so he's complaining to Zeus, and Zeus decides to put Asclepius in the sky as the constellation Ophiuchus. And if we can go back to the constellation, I can show you guys. It's usually depicted as a man in the middle of a serpent, kind of dividing the serpent in two. And this is the constellation of Serpens. And there is Serpens Capta, which is the head of the serpent, and Serpens Cauda, which is the tail of the serpent. So yeah, that's the story of Asclepius and Ophiuchus.
Yeah.
Yeah.
Awesome.
Cool. So I think we can sign off on M12. M12. Let's do it.
Here, next one is M10. Another glob in Ophiuchus.
Yeah, we're really getting those globs tonight. So many globs.
Ophiuchus globs. There's like a bunch of Ophiuchus.
There. Yeah. Cool. So heading over to the next glob in Ophiuchus. Also, fun fact, the reason we gave Nina M12 the gumball globular is because Nina is a dental hygienist. And we were like, gum, Nina. Yes, I am a dental hygienist student. Do you want to sign for M92?
Sure.
Cool. So while they're signing that behind me, let's go ahead and talk about M10. Another glob in Ophiuchus. This one's got a little less stars than the ones we've been looking at. It's got about 100,000 stars, which is still quite a bit, right? Quite a bit of stars. And it's about 14,300 light years away. So it is fairly close, considering most globular star clusters are like 20,000 light years away, something along those lines. But yeah, so the really cool thing about M10 is it's actually one of the younger globs that's known. It's only about 11.39 billion years old, which
Super
is
young.
still
Just a baby.
Yeah, it's just like just was born, you know? No. But it is much younger than most of the globs. But it is known for its high density of blue stragglers, which we talked a little bit about at the beginning of our segment. Yeah, so fun fact, if this were brighter, it would actually appear about 2/3 the size of the moon in the night sky. Yeah, so if you have like owl eyes, right, where you can see like every star in the sky, you wouldn't be able to see this because you'd be able to see every star. But if you were able to single out things, you'd be able to see this pretty easily.
I want to get those. I want to get some owl eyes, I think.
Right?
I think I could pull it off.
I think that'd be pretty cool. Just
Yeah,
like
I think it'd look good.
looking around, like being an owl would be so wild. Every time I learn something new about them, it's always insane. Like their legs.
Too
Look,
high up.
if you guys haven't seen owl legs before, please Google it because it's like it's wild. In the back end, people are saying owl legs are horrifying, and they are.
They're too long.
They're genuinely terrible. They're so long for how small owls are. I hate it.
Hoot, hoot.
People are saying hoot hoot.
Hoot hoot. That'll be our catchphrase.
Hoot hoot.
So every time that we find a new object, we'll say hoot hoot.
Yes, I think that's a great idea. Cancel owl legs. All right. Well,
We're
fine.
gonna move on.
All right. So I'm gonna sign off on M10 and
All
let's
right.
go over to M107. Oh, I don't have a Sharpie.
All right. Yeah, so I can talk about M107. This is another glob in Ophiuchus because we have a lot of those. So this glob is about 20,900 light years away, and it contains about 100,000 stars. And again, this is a really old globular cluster, about 13.9 billion years old. First discovered by Pierre Méchain in 1782, and then rediscovered again independently in 1793 by William Herschel, who was the also English astronomer who also discovered Uranus accidentally. He was also a composer. I did not know this.
He was a composer?
He was a composer. He was a very talented man. He did a lot of things. He was a composer. I've never heard any of his music, but I found that out recently. I did not know that.
It'd be interesting.
We gotta look it up.
He was kind of a Renaissance man. Yeah, so this is another Ophiuchus one, and there are a lot of stories surrounded around Ophiuchus, and we'll talk about probably a couple more tonight. But they all kind of carry that snake theme. That's kind of the common thread among all of them. So it's believed that a lot of these Greek stories were derived from older Babylonian stories in Mesopotamian mythology. So it's believed that Ophiuchus may have been derived from the Babylonian goddess Nera, who was a snake goddess, depicted with the upper half of a human, and then not like a snake lower half, but like literal like normal legs, but they were snakes.
Like,
So wait, okay. So like it was like snake skin, or like a whole
no,
bunch of snakes made up the legs.
no.
It was
So,
two
like
snakes.
two snakes made her legs,
Oh.
and like it was snakes with like their heads down, like their heads were the feet.
Okay, you've seen Star versus the Forces of Evil? There's a character who has snakes for arms.
Oh, I do remember that.
And
yeah.
that's what this is making me think
Yeah.
of. So
Snake legs,
classic snake legs.
Classic snake legs.
Yes, Heather. Classic snake legs. Wow. Love it. Love it. Love to see it. Oh, wow.
Awesome.
All right. Moving on from that. Well, if we want to keep talking about snakes. So, fun fact, going back to the Greek mythology concerning Ophiuchus. So many people think that the medical symbol, which is called the caduceus, is a reference to Ophiuchus, and it should be, but things got pretty weird and complicated. So the actual caduceus is the symbol of Hermes. And Hermes really doesn't have anything to do with medicine. It's just kind of been like a misunderstanding that this was used.
It's weird, yeah.
Yeah, and so
super weird.
yeah, so the actual symbol should be what's called the rod of Asclepius, which is just like a staff with one snake wrapped around it, whereas the caduceus has two snakes wrapped around it.
Huh.
Yeah, and so it all started out with like the U.S. Army Medical Corps in 1902 started using the caduceus, and now it's kind of divided between which one is used between different like medical organizations. And the caduceus is used more often, which I think is really interesting because in terms of mythology, it doesn't actually have a tie to anything medically related. And that it should probably be the rod of Asclepius, but now we associate the symbol with medicine.
Interesting.
Yeah.
Also, I'm being told that the person telling us to cancel owl legs and classic snake legs is actually Cody Half Moon, not Heather. Heather has stepped out and Cody is posing as Heather. So
Cody, would you feel more comfortable if owls had snake legs?
Oh no.
Would that be better? Would that be better or worse?
Oh no.
we just got dots, yeah.
She said she's closing. She's just leaving. So
Live stream's actually gonna end here, folks.
Yeah, thanks for coming.
Sorry,
See ya.
All right. Okay, well, let's step away from snakes and move on to our next object, unrelated to snakes. So we are gonna head on over to M83. And this one is also known as the Southern Pinwheel Galaxy. So they are trying to get it up for us, which we appreciate. In the meantime, we'll tell you that this galaxy is approximately 15.21 million light years away. So, you know, it's super close. Like, you know, we could go there tomorrow, totally fine. It's pretty far. It's one of the closest and brightest barred spiral galaxies with an apparent magnitude of about 7.5. And it is twice as small as the Milky Way galaxy, approximately, containing about 40 billion stars. Nice.
Yeah, so it's got a lot. So we're waiting for that one to come up. Oh, there we go.
Oh, so pretty.
Ooh.
That looks awesome.
That looks cool.
Yeah, that
Nice.
looks
Good job.
really, really beautiful. Thank you so much.
Props.
Yeah, so there are lots of galaxies known as the Pinwheel Galaxy. This one's the Southern Pinwheel Galaxy, and it's got those really pretty spiral arms. And within the spiral arms, there's rapid stellar formation happening, with the majority of new stars forming in clusters on the edges of the dust lanes. And so this one's a barred spiral galaxy, and Haley is now going to talk to us about what galaxies are and different types of galaxies and all that fun stuff.
Yeah. So there are a couple of different types of galaxies. They typically, when you think of a galaxy, you think, you know, things like this with like the spiral arms, but not all galaxies look like this, you know? So there are some which are called irregular dwarf galaxies, and they only have like a couple hundred stars.
And I think those are really awesome because actually one of our astronomers, Dr. Deidre Hunter, she studies these little tiny little dwarf galaxies, and she studies stellar forming dust regions inside of these galaxies, just like should not exist there. And there's a bunch of these dust regions here in our Milky Way. We're actually going to do some imaging of them a little bit later in our segment. But yeah, so those are like the smaller end. And then we've got things like spiral galaxies. So things like the Pinwheel Galaxies or the Milky Way Galaxy, they're characterized by these nice spiral structures around them. Barred spirals just means that there's what looks kind of like a bar in the middle of them. Claire or Jacob, whoever's operating, would you just kind of point out that bar going through the middle of this galaxy here? Yeah, exactly. Yeah, so then we also have elliptical galaxies. Elliptical galaxies are typically, they're kind of like older galaxies, I guess is how I would describe them. There's a lot less stellar formation happening inside of those galaxies. Typically, they are the end result of a galactic merger. So two galaxies combining into one. This like whole chaos ensues over millions, billions of years. And then eventually, once it kind of settles down, it appears as something like the Andromeda Galaxy. So yeah, so it's a couple of different types of galaxies. Cool.
Yeah. Awesome.
All right. I think we can cross off M83, the Southern Pinwheel Galaxy, if we would like. Yeah. Okay. I already did. Oh. Well, Haley's I'm on top of it. So we're moving on to M14. Guess what? It's another globular star cluster. Woo!
You thought we were done, but we're just getting started.
We're definitely not done. All right, so we're getting a question. Do the galaxies have to get a liquor license before they're allowed to have a bar in them? Actually, no, they're living illegally, but we're not going to tell if you guys don't tell, you know? Just kidding. We absolutely would report if somebody was doing something illegal, even if it was a galaxy, you know, like galaxies aren't above the law. I don't know where we're going with this.
Like
Let's just move on.
It's like 21 billion years old, right? Is that how old they have to be?
Oh yeah, 21 billion years old.
18 billion in the European universe, but that's just, you know.
Lowell does not condone unlicensed galaxies, is what we are receiving. So, all right. You heard it here. Okay. All right. So, our official PR response is Lowell does not condone unlicensed galaxies. Maddie, can you put that in the chat on the YouTube, the live chat, please? Okay, so M14 is the globular star cluster that's up right now. It's another one that's in Ophiuchus. And this one's about 13 billion years old. So that's kind of like mid-range for what we've been talking about so far. And this one has about 150,000 stars. Sorry, I can speak words, which is kind of on the lower end of what we've been talking about as well. But it is really, really far away. It's about 30,300 light years away. So that is quite far. But this globular star cluster is super, super interesting because in the summer of 1938, M14 actually played host to a nova. So a nova is like this insane stellar eruption, extremely bright. In a few days, the star will actually grow like 10,000 times brighter than normal. And so the most widely accepted theory today is that all novae are actually two stars locked in a close orbit by their mutual gravitational attraction. So these two stars are getting really close and they're kind of pulling at each other. And so it creates this giant burst of energy. And one member of the pair is typically a normal star, fairly similar to our own sun. And the companion is a white dwarf star. And we'll talk a little bit more about white dwarf stars later, because we are going to image some objects that have white dwarf stars inside of them. But it's basically a dense star at the end of its life, which has collapsed down to about the size of the Earth. And for comparison, the sun can currently hold like 1 million Earths inside of it. So this is like an insanely big star and a pretty small star. Well, not insanely big compared to like a lot of stars out there, but whatever. Now, such a compact star like that has a really intense gravitational pull. So that's what's causing this issue. And so this hydrogen gas, it's actually stripped off of the outer layers of the normal companion star, and it falls onto the surface of the white dwarf. And basically it gradually accumulates and it's squeezed even deeper into a denser shell on the white dwarf's surface. And eventually that temperature, because of that density of the hydrogen in the shell, it reaches the point where the gas spontaneously ignites. And it's a giant thermonuclear explosion. And so this is like literally like the definition of an immense hydrogen bomb. So this globular star cluster in the summer of 1938 blew off a hydrogen bomb, basically. Yeah. And the explosive energy that is released explains both the sudden brightening and the rapidly ejected shell of that white dwarf, which reaches speeds as high as like thousands of kilometers per second. So we're talking like intense explosion. So this is one of the cooler globs that we're going to talk about tonight. I know, right? That's a pretty cool glob right there.
I have a question. So kind of like, you know, how if you see a supernova in another galaxy, it can outshine the combined light of the entire galaxy. Would the same thing happen here? Like with this kind of type 1 nova where like, would it have outshined all the light of the cluster?
I mean, like, it grew 10,000 times brighter. Like, I'm gonna assume yes, it definitely outshined this object. And Cody's saying it's not like other globs. So, good to know. But yeah, so this is the coolest thing. Was that nova visible to the naked eye back then? I don't think it was. I'm pretty sure it was not, because this is still really far away, so I don't think it was visible. But through like a telescope, yeah, totally visible. So yeah.
I saw it with my naked eye.
You saw it back in 1938.
Yeah,
Peter is actually a time traveler.
Yeah, Peter's actually just like 2,000 years old.
I'm an ancient god.
Yeah, we're getting all of these constellation stories from him directly there.
I threw half of these creatures into the sky to turn them into constellations.
He's actually just Zeus. All right, so I'm gonna sign off on M14.
Amazing.
Let's move on to the next.
We can go to M9. This is, guess what? Another glob in Ophiuchus.
The snake legs are coming back.
Snake legs come back. And in fact, we have another snake story, because as I said earlier, there are a lot of stories around Ophiuchus that are centered that have the snake as a common theme. Now, in this story, the snake kind of plays it's more to move the plot along. It's not really a central character. But so we're going to look at another glob in Ophiuchus, M9. This another old glob, about 12 billion years old. It has over 250,000 stars, so a lot of stars, this globular cluster. And at 25,800 light years away, it's actually one of the nearest globular clusters to our galactic core. So this was actually discovered by Charles Messier in 1764. And the story that I want to tell you guys is actually one you might have heard of if you've read the Iliad. So this is a story of Laocoon, and there's a really famous Hellenistic sculpture. It's a Roman copy of a Hellenistic sculpture in the Vatican right now, and it's this called Laocoon and his sons, and it depicts Laocoon and his two sons wrestling with this huge serpent. So Laocoon was a Trojan priest, a priest of Poseidon, and towards the end of the Trojan War, when the Greeks put up, the Trojan horse, the Greeks, pretended to leave, and they built the Trojan horse, and it was supposed to be a gift to the Trojans. But in secret, of course, the Greeks were hiding in the horse. Now, the Trojans were delighted to see the Greeks had left. There, it had been a 10-year war, and they were happy to accept this gift. But Laocoon was the only person to suspect that the Trojan horse actually might be a trap. And so to kind of prove his theory, he actually threw a spear at the horse. Now, Athena, Athena was on the Greeks' side, and the gods kind of took different sides in the war. Athena was on the Greek side, and Athena was the patron of Odysseus. And Odysseus was the one who kind of, with Athena's inspiration, came up with the plan of the Trojan horse. And so she sent 2 serpents to go kill Laocoon and his Shamala. I was staring at that for like a minute, and I was trying to like, wait, what? I get it now. Oh no.
Wait, how do you pronounce that? Dulcimerus. Dulcimerus. Okay, so you're fantastic.
That's great. That's great.
Especially because it has to do with the Trojan.
It has to do with the Trojan.
It's a twist.
It's a twist. What a twist.
Wow.
So anyways, yeah, so Athena sent the serpents to kill Laocoon and his 2 sons. And so the Trojans interpreted this as he was being punished for striking the horse. This horse was supposed to be a gift, a tribute to the gods from the Greeks for the Trojans. And Laocoon had just struck with the spear. The Trojan was like, oh no, this is definitely this is a gift for the gods. Let's bring it into the city. So they wheeled in the city, and of course, what happened next was that night the Greeks came out of the horse and they razed Troy to the ground. So Laocoon was right, but he got eaten by a snake for being right.
So many snakes.
So many snakes, but yeah. So again, Ophiuchus often it has all these kind of snake themes to it. Snake themes.
So he mentioned that this is one of the nearest globs to our galactic core, and you guys are new here.
Oh.
So I'm going to make Cody want to quit. So Cody knows that one of my favorite things to say on air is the galactic core can also be known as the galactic bulge of the galaxy. Oh yeah. She said, "Don't say bulge." She knew what I was gonna say. So yeah, that would be another word for the galactic core is the galactic bulge. I'm sorry, Maddie. I won't make Cody quit. So, all right. So let's head over to Alberio. This will be our last object before we take a break and switch hosts, so that you don't have to sit here and hear me say galactic bulge again.
Yeah, please stop.
I'm not actually new here. I meant new.
I am new here.
I meant new to the stream.
I'm new to both.
I meant new to streaming with Cody. Nina is not new at Lowell Observatory, no. Alrighty, folks. So now, while we wait for the Earth to turn, we will be looking at Alberio, which is probably my favorite binary star system. So we will wait for that to pop up here.
Oh, whoa.
Ooh.
Ooh.
All right. Yeah, let's see if we can resolve that. There we go. We're starting to get some resolution. All right. So Alberio, it's about 430 light years away. It is a binary star system. Now this one, it might be a physical binary or it could be an optical binary. There's a little bit of debate. We're not 100% sure. And so physical binaries occur when two stars orbit around a shared center of mass, and optical binaries occur when there are two stars that appear close to each other as viewed from Earth through a telescope. So there's a little bit of debate about which one it is. If they are a physical binary, their orbital period is about 100,000 years. So a very, 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 very long orbital period between these two. Some astronomers believe that they are optical binaries because of differences in the star's proper motion have been detected, which suggests that they may be unrelated.
And so proper motion refers to the angular velocity across the sky exhibited by an object. So if they don't have, the same, it could be an indication that they're actually unrelated and not part of the same system. Regardless of whether Albireo is a physical or an optical binary, it is one of the best binaries to observe this really nice color contrast that we have. So you can see that there's kind of a reddish star and a bluish star. So for stars, the color most oftentimes denotes temperature. And so like fire, the blue star is going to be hotter and the red star is going to be cooler. So yeah, do you guys have anything to say about Albireo? Albireo translates to beak because it's the beak of Cygnus the swan. Which Cygnus we will talk about when we are back, but it looks like they are kicking us off for the next hour. So we are going to go and switch out with the poor educators who are out in the cold. We're going to go in the cold and we're going to take some really cool pictures for you guys.
Yes, we are.
So
yeah, that's the plan.
Thank you so very much for hanging out with us.
Thanks, guys.
And we will return.
to Lowell Observatory. It is currently 3:10 a.m. in the morning, and my name is Claire. I'm an educator here at Lowell Observatory, and this is...
My name is Jacob. Same thing.
Nice. And so just a little bit of an astronomical update. The moon has set, so we're in for some pretty nice, dark, early morning skies, which should be a treat for some of the next objects that we're going to look at. We're going to start off with M80, which is what we have here on the screen. This is a globular cluster in Scorpius. So a trend you might have seen earlier in the program around 2 a.m. is that we're in a lot of globular clusters. We're going to be looking at a lot of globular clusters too, but that's okay. They're pretty cool. So M80 is one of the densest globular clusters in our galaxy, and it's about 28,000 light years away. And this one's pretty cool because it is notable for being the site of a nova in 1860, which Haley mentioned earlier. This is when a close companion star transfers hydrogen to a white dwarf, and that star reignites, which is pretty exciting to astronomers. So that happened in 1860 for whoever was around looking at that, I suppose.
Peter.
Yeah, I suppose Peter was. But M80 is pretty good. Do you want to say anything?
It's a lot of stars.
Yeah.
It's just a lot of stars, and these globular star clusters are going to be clusters of a lot of stars, as the name.
Clusters of very old stars, so a little bit of a globular cluster 101, I suppose, just like brief astronomy flashback, is globular clusters generally have really old stars. They are loosely gravitationally bound, which is pretty interesting. They usually have about 100,000 or so stars in them, sometimes more, maybe a little bit less, but that's a lot of stars in one small area of space. So they look really cool, kind of like frozen fireworks, or like unicorn snot, as some people have described it as, which is very creative of them, I think.
Very specific too.
Very
Like, how do you
specific,
see
yes,
that?
yes. We have a question. Is M4 near this? I believe so, because
Yeah.
we're going to go to M4 next, which we might as well go to now because we're in the same constellation, which will be Scorpius. And we were having a conversation earlier while we were doing the telescope viewing, and usually when Scorpius is up in the night sky for us, it's summer, so it's pretty warm. Right now it is like 20 degrees outside in Flagstaff, which is pretty cold, so it's a little bit weird to see Scorpius in the night sky and be bundled up in 3 layers of jackets and 3 layers of pants and like 5 pairs of socks. It's kind of weird.
5 pairs of socks?
Maybe.
Okay.
So this is M4. This one's neat because it is close to the star Antares, which is one of the brightest stars in the night sky. It is a red giant star, and Antares has a funny little name because it is called not Mars. That's because it is a very red star. And then this one is about 5,500 light years away. So it's a lot closer than M80, which is what we just looked at. This one is a little more diffuse, I would say. It's not as densely packed in the center. So we can see more individual stars towards the core, which gives us some nice detail, but it still probably has around 100,000 stars or so in this globular cluster, which is pretty cool. Also, some of these stars are 13 billion years old, which is almost as old as the whole universe, at least as we know it now. And so sometimes globular clusters in astronomy and cosmology are used to estimate how old the universe is. So that's a great question. How old is the universe? How do we even know that? What evidence do we have that indicates this? Basically, astronomers look up in the night sky and find stuff, and they have ways of measuring the ages of stars. And then we can kind of like reverse engineer our way to when we think the universe started at a very specific time, which we think was about 13.8 billion years ago, which is a long time, very long time. But that is M4, the globular cluster. Anything you want to add?
Well, you got those stars. They're very elderly, and so oftentimes they're classified sort of in their own population 2 stars. Currently, something like our sun is much different. It's made of different material and obviously much younger. So it's cool to be able to see these globular star clusters as they are, as they were, since we're looking back into the past here, no matter what. And just really cool relics of the past, sort of just these very ancient bodies, and with almost 150 of them, if not 150 that we know of, at least in our own Milky Way. They're always cool to look at. They're neat to look at, and we're kind of forced to look at them too right now because that's just this part of the night.
Very much so ahead. So one thing that I always like to ask guests about globular clusters, especially when they look through telescopes, or like now, if you're joining the live stream, is what do globular clusters look like to you? Sometimes they have a unique shape to them. Maybe people say it looks like a spider web with raindrops stuck on it, which is kind of cool. So I always want to hear what guests or the viewers think globular clusters look like. Personally, I like the frozen firework description. I think that is easy to picture. I'm pretty sure everyone knows at least what a firework is, or maybe it's like glitter dusted on a black sheet of paper. That is a pretty good description too. So if you have any suggestions of what a globular cluster looks like to you, we'd love to hear it. But let's take a moment to sign off on the objects we've done so far, which is M80 and M4. I'll do M4 and you do M80, I guess.
Sure, I want to have like really obnoxiously large signature, but I'm not going to.
Oops. This pen is dying. There we go.
That's good.
There we go.
I did it.
So we're gonna hit some more globular clusters a little while in the future, but we're gonna go to some other objects first. But before we get into some of the more unique, colorful, interesting objects of the Messier catalog, we're gonna give you a little bit of Lowell lore, which Jacob and I are very excited about.
There's always so much to talk about when it comes to just everything that goes on up here, because it's a neat place, and there's just quite a lot of things that occur throughout just all of time, and we have some nice little rundowns here that we've created, some presentations, if you will.
We do.
And,
so
yeah.
To the people behind the scenes, if we could share our screen, and while we're doing some of that stuff, we're going to talk about some of the supervisors of the public programs. Do you want to do the
Yeah, I got them
stuff?
long arms. So how do I even share? What do I do?
Yeah, go there.
Oh, I love
There we go.
trackpads. There we go.
Perfect.
Share.
So we're going to talk about the supervisors of Lowell Observatory. These people are very unique. These are the people who are in charge of us educators, which you can imagine, it's probably quite a handful night to night. They need a lot of time off, I'm sure, because we are all very rowdy, but we're going to talk about the supervisors and the Lowell lore behind them. And we're kind of focusing in on the blessings and curses that each supervisor brings to Lowell. So we're going to start off with a brief introduction of the supervisors we're going to spotlight tonight. So we have first Kevin White. He is in that nice aspen setting with the golden leaves on the ground. Then we have Curtis with his cat on his shoulder. And then we have Kevin Conley pictured with the Clark telescope and a very nice facial expression.
A very interesting one.
Yes.
And a sick mustache.
Yes,
too.
definitely. So we're going to talk about each of these supervisors in turn, and we're even going to have a special guest at the end in just a little bit. But we're going to start with Kevin Conley, aka Banjo Kevin. So Kevin Conley comes with a lot of curses. He is also called Cloudy Night Kevin Conley because usually when he supervises, even though the forecast says it's going to be a nice, perfectly clear sky, some sort of cloud always rolls in at any time of the night and inevitably kind of interrupts the viewing. So we call him Cloudy Night Kevin because generally when he's supervising, there's at least a 95% chance that there's going to be clouds, which is always fun. Also, sudden precipitation events. There can be almost no clouds in the sky, and then suddenly it'll start snowing. Then we have to rush to close the Godo and the Clark telescope when Kevin Conley is here, and he's usually rushing around campus, running up and down Mars Hill, trying to get everything covered, but he's also known for the sudden precipitation events. Another one is that he opens the Clark telescope, which takes a bit of time to open, about 15 minutes, because we think we're going to have a nice break of clear skies with no rain, little to no wind, pretty low humidity. And then the forecast changes suddenly, and then we have to close the Clark telescope 15 minutes later, which is something that has often happened with Kevin Conley.
Then we got the sparkling cider incident, which was really just a beautiful thing altogether. It was like partway through COVID lockdown, I believe. And we were having like a little bit of a staff party online, just in Zoom. We all had like a little thing of sparkling cider that we were all gonna like open in unison. And Kevin Conley's was probably, shaken up a little bit or something, because he was just there on stream as his camera was on, looking at all of us, and he popped open his cider. And it apparently hit the ceiling, the cider itself, and created a gigantic mess that caused him to absolutely frantically shut everything down and just get to cleaning. And he pretty much dropped out of that little bit of a staff party, losing also the drink that he had sort of planned to drink with everyone else. It was definitely a hilarious thing, and one unintentional little curse that did occur.
It was a glorious moment.
It really was great.
It was the highlight of lockdown for Lowell Observatory.
Absolutely.
Truly, we just saw this bubbly explosion from his screen, and there was much laughter after that. So that's the sparkling cider incident from Kevin Conley. So we're gonna move on to Kevin White. Kevin White has a lot of blessings, not a lot of curses. Kevin White is the basically owner and the CEO of the snack drawer here at Lowell Observatory, which is basically just this filing cabinet, one of the drawers in there that we fill with snacks, usually pretty unhealthy snacks, because we're up late at night trying to do stuff for all the amazing guests that come here. So that's the snack drawer. Usually there's ramen noodles in there. There's probably Oreo cookies of some sort. There's tea, trail mix, sometimes like Ritz crackers type stuff. So you get the gist. He's also our resident philosopher, so you can have any type of conversation with Kevin White, and you are in for a treat because he'll usually bring something up about philosophy, ancient philosophy from thousands of years ago, and you'll be into a very deep conversation about that. He also has ginseng tea at all times.
It's the best.
So if you're
That's
feeling a little sore in the throat, he'll always offer you ginseng tea, which is quite nice of him.
I need to go steal one actually after we're done.
Oh
take
yeah,
that
there's
home.
probably some ginseng tea still.
Oh, there is. There always is.
And Kevin White is just great for wholesome conversations. He's so incredibly kind, and you're just in for a lovely time when he's supervising. He's just awesome. And so the snack drawer plus the wholesome conversation makes for a pretty good night with Kevin White. We're going to show you one more before we get to one last supervisor. We have an honorable mention, Rezi, the science demo queen. So if you've come to Lowell Observatory recently, you might have noticed that some of our programming has changed to include more amazing and fire-based science demos. And
Fire's cool.
Yeah, fire's
Nina
pretty
would know.
cool. Nina would know. But Rezi is the one who introduced some of these new demos for us. She's really revamping some of the science demo curriculum that we have here, which is pretty awesome. Rezi is also an amazing artist. She posts some of her artworks in our Discord, and they are just so cool. Very proud of Rezi. She also plans the Halloween party. So whenever Halloween, October time rolls around, we know that Rezi is already in the spooky season mindset, which is always fun to have around. She also has really awesome sunglasses that she wears at the beginning of shifts. Sometimes they're heart-shaped, sometimes they're circular. Overall, really cool, and Rezi's amazing.
I don't think I've actually seen those cool sunglasses,
Really?
to be honest. Yeah,
Oh.
it's kind of like a new thing to me, but now I'm gonna have to like really pay attention
Yeah,
because
yeah.
I want to see some cool sunglasses.
Cool sunglasses
Absolutely.
at the beginning of shift. So that's Rezi. But we have one more supervisor to talk about, and this is Curtis. And so Curtis has curses. He is known for unexplainable phenomena happening during his shift, spooky stuff. And usually you can find him in the office eating canes pretty often. But
Natural habitat, really.
natural habitat. But we have Curtis as a special guest for us tonight.
He's actually sitting over here.
Yeah, we're gonna have him
And now
join
I'm
us.
gonna very awkwardly sit here in the middle as Curtis takes up the other third of this.
So,
Hello, everybody.
So Curtis is known for unexplainable phenomena during shift. Basically, anything that weird happens is usually because Curtis is the supervisor, and Curtis has a story to share with us about what we collectively call the thing that Curtis saw.
Yes. So yeah, always a weird thing, whether it's a weird animal, weird event, something in the sky, something weird always happens when I'm working, it seems. And I don't even remember what part of the sky we were looking at. It's somewhere to the north, I think.
Cepheus.
Was it Cepheus?
Yeah, because I was laying on the
It was
concrete,
Cepheus.
looking at the same spot in the sky. there.
Yes. So we're looking at the constellation of Cepheus, kind of to the north, and we just see this part of the sky that has no stars just get super bright and then just dim back, and we just straight up couldn't explain it. Like, we were looking on all the different apps and star charts trying to figure out what star it could have been. There weren't any stars there. It wasn't a satellite. It didn't move. It was quite bizarre.
Mm-hmm.
We tried to put the telescope on it too, I think M32, and we were just like looking around the general area, like, oh, did we see something new that like,
did we see a supernova? Like,
yeah.
Whoa. Yeah, I still think my favorite weird event though is when I get a radio call a few months ago from one of the other educators and just says, I think there's a bear down in the parking lot. I'm like, oh no, like, I don't even know what I would do at that point. And so I go down there and we finally shine some flashlights. There's like 5 of us that congregate and are shining flashlights, and turns out it was a javelina. It was a wild pig that was, we didn't even know lived this high. They're just here.
They were hanging out, trying to see some stars.
Yeah, and then it like took off towards the Open Deck Observatory up here where we have a bunch of guests. I'm like, man, I don't know what I would do if that attacked someone. I don't know.
Wrestle them.
Maybe.
Wrestle them.
I might have to.
That's
yeah.
the best option.
Yeah.
Don't do that.
Yeah, would not recommend. I remember being there that night and just hearing on the radio, there were some javelinas wandering around on campus, and it was really interesting to hear that. You're like, huh, okay, makes sense though, because Curtis is supervising, so something weird is gonna happen.
Checks out.
Yeah.
And speaking of animals, we got something a little later.
Oh yeah, we do.
When it comes to animals.
Stay tuned because we have a little special presentation about the ghost pets of Lowell Observatory. So we're going to introduce some cute and maybe not so cute animals, depending on your opinion, of Lowell Observatory's past. Yeah, I think they're pretty all cute. So stay tuned for that. But we're going to get back to some of the objects that we're going to look at. So thank you, Curtis,
Thanks
for
for having
joining
me
us.
on.
Curtis,
yeah.
Be banished over that.
Sounds good. I'm gonna go probably sleep.
Nice. That sounds like a good idea. It is 3:26 a.m.
Yeah.
So
All right.
it's pretty good.
Well,
okay.
I'm gonna steal my spot back over here.
So we're going to switch back. We're going to stop sharing our screen so that the operators can go back to showing us some pretty neat objects. But we have a nice and colorful one coming up next, which will be M57, the Ring Nebula. So we'll give a moment for the operators to get that going. So you might have seen this earlier in the stream if you were here, but what you're looking at now is our plane wave interface. So this is where we type in is usually the easiest way to find an object. And so we can also see the constellations and some bright stars in the sky from there. Then we switch over to our camera software and we can get some pretty cool stuff. So this is the Ring Nebula. We're starting to get it in view. Sometimes when we take a photograph, when the telescope moves, the stars look like little comets. So that was what you just saw probably earlier.
They're cool.
They are cool. I think
it looks
really
sick.
cool.
It's,
Yeah.
It's like a cool background or something.
Yes, but here's the Ring Nebula. So very colorful, and it kind of looks like a fuzzy Fruit Loop in the night sky, or sometimes known as the moldy Cheerio. Some people call it that.
I like that one because it's funny.
Moldy Cheerio is more funny, I guess, than a Fruit Loop. But the Ring Nebula is about 2,000 light years away, so it's not all that far. It's a lot closer than the last 2 objects we've looked at. And this is a planetary nebula in the constellation of Lyra. And Lyra is usually a pretty well-known area of the night sky. This is usually, under normal nighttime circumstances, a summer object. And right now it is March, and so it's a little bit weird to be looking at summer objects while it's freezing cold outside and it's spring. But what planetary nebula are, they are dead stars in the night sky. So what you're looking at is a bunch of gas of what used to be a star that has just shed itself outwards, kind of like slowly peeling the layers of an onion out into space over time. And that gas, that bluish orangish gas, will continue to diffuse outwards forever until we can't really see it anymore. So this is the Ring Nebula. So one cool thing is that how M57, the Ring Nebula, is tilted towards us, we can view this planetary nebula face on, which is unique because that allows us to see more details of the actual structure of the planetary nebula and how that gas is being blown outwards into space. Sometimes, just like with galaxies, we can see a planetary nebula edge on, which doesn't allow us all that much detail, but here, face down, we can get some pretty good views of this planetary nebula. So breaking down the colors, the blue gas in the center is going to be more oxygen rich. So the blue kind of greenish is going to be a little bit of oxygen, maybe some carbon. And then the orangey reddish stuff on the outskirts, maybe you can just see it a little bit. That's going to be more of our hydrogen and helium on the outside. Is there anything you want to add?
Well, dead stars, that's pretty much it.
Dead stars are pretty cool.
This would be something more like in the case of something similar to our own sun. Right?
Yes.
There's other stars out there in the sky, and a lot of the ones that we can see with our naked eye, at least, put our sun to shame when it comes to like mass and physical size and all that. And they live different lives, or can live different lives, depending on like how much more massive they really are. And with something like a planetary nebula, these come into existence whenever, you know, a star like our sun just gets kind of too old to hold itself together anymore. It's not really a fantastic event. It's nothing like a supernova, but still super sick to see. And those colors, especially in the Ring Nebula here, are just like fantastic. This one here is specifically like a personal favorite when it comes to planetary nebulae, just because it's like really like grabs your attention right off the bat there with the blue and the red. So it's always a neat object to hit. And Lyra being up already, I guess it's only 3:30 in the morning anyways. It's kind of spooky, kind of weird.
It is spooky, kind of weird. One note though is that we're looking at this with a camera, but if you were to see this object through a telescope, it would look kind of, to me at least, more grayish green, which alludes to the reason why we sometimes call it the moldy Cheerio of the night sky, because it has a bit of a moldy color to it. One thing you might notice too, and the telescope operators can point this out, is that there's a small white star in the center of this nebula, and that is called a white dwarf star. That is the remnant star of the star that once used to be. That's the dead core of the star. White dwarfs are usually pretty dense and very small. They're usually about the size of Earth, and for a star, that's extremely small. Stars are very, very big, and to shrink down to the size of Earth takes a lot of energy to be able to do that. So that white dwarf star is emitting a little bit of energy. It's ionizing or exciting the gas around it so that it glows for us. So that's how we can see the Ring Nebula in the first place, is that gas is being ionized or excited from that energy from the white dwarf star. But as that gas expands outwards, we're not going to be able to see it as well, just because that gas will slowly cool down more and more over time into space and just diffuse into the background, which is pretty cool. One other thing to note about this object is that the blue part that you can see towards the center has more of a football-like shape, which is interesting. So nebulas, specifically planetary nebulas, can take all different shapes or forms, and we're going to see one soon that looks quite different from this. But the football shape means that this nebula is pretty developed. It has a complex shape. Sometimes planetary nebulas can be perfectly spherical. Sometimes they have different lobes of gas, which we'll see soon. So just a note that this does have more of a football-like shape. So it's not just a sphere. It is very much so complex in its shape and color, which is pretty cool. So that is the Ring Nebula. I think we should sign off on this object.
There it is.
There it is.
That is a horrible signature, or initials really. But it's 3:32. I'm not really good at writing or thinking at this moment. But that's fine. Who is?
Who is? So let's take a moment to talk just a little bit more about planetary nebula formation. So Jacob mentioned earlier that this is something that happened from a sun-like star. So in many billions of years in the future, our own sun is going to become an object like this. And there are a couple stages to get to a planetary nebula. So first, your star, or let's say our sun, has to run out of hydrogen. And usually that takes a long time. There's tons and tons and tons of hydrogen in the universe. And so the star, our sun, uses up a lot of that hydrogen before it moves to other elements, burning through other elements. So eventually it runs out of hydrogen, it'll convert to helium, and that'll cause the sun to expand a little bit because it takes more energy to smash helium atoms together than it does for hydrogen. And then eventually the sun will become a red giant star. By that time, Earth will probably be engulfed by that red giant sphere, enveloping out towards us. So it's possible that our sun could engulf Mercury, Venus, maybe even Earth in that expansion, which is kind of interesting to think about. But that won't happen for billions of years. So you can mark it on your calendar if you want, but like honestly,
that's gotta be
whatever.
A big calendar.
Yeah.
That's a huge calendar.
I'm sure smartphones can do it because they go into like infinity, I'm pretty sure.
You have like integer overflow or something.
Yeah,
which
maybe.
is like wild. You brick your phone by just trying to mark the date of the death of the Earth.
Death of the Earth. So the sun will become a red giant star, and then eventually the sun will completely run out of fuel. It's no longer able to burn through elements in its core, no longer able to go through thermonuclear fusion, smashing atoms to create heavier elements. And that's kind of the end of our sun. When that happens, a white dwarf will be formed. the core will compact down into itself into a white dwarf star. And that white dwarf star will stay in the universe for billions to perhaps even trillions of years in the future. We think that white dwarf stars will be some of the last things to exist as the universe continues to expand, continues to get cold. They may be some of the last things to just really exist in the universe. And at the same time, that gas will continue to shed outwards like we can see with this ring nebula. So who knows what our own star will look like when we become a planetary nebula, but I'm sure it'll be interesting and pretty for aliens to look at back on Earth, if they can even see us. But yeah, maybe, I don't know.
Here's to hoping.
Yeah. So we're gonna move on to the next object, which will be M56, which is a...
We're going back.
Yes, we're going from M57 to M56, which is a globular cluster in Lyra. So we're gonna look at another glob. This one's gonna be about 33,000 light years away, so we're moving quite a distance from 2,000 to 33,000 light years. That's a pretty big jump. So we're gonna take a look at this pretty soon. Jacob, do you have a favorite object in the Messier catalog?
In the Messier catalog, 82, easily. 82,
Okay.
straight up.
Nice,
It's a cool galaxy. It's neat.
nice.
Love it.
Have we looked at it already?
Yeah, I mean, who did it though? That's Wesley, I think.
Oh, nice.
It's beautiful.
Cigar
It's
galaxy.
just an awesome galaxy. It looks pretty.
Yeah, that is pretty cool.
Galaxies are usually like just an all-around favorite when it comes to like the Malencam and what it can do. So, like anytime that anyone gets a chance to see one, it's great. It's a good time.
Pretty great. All right, so this is M56, the globular cluster in the constellation of Lyra, which means the harp. It kind of just looks like a squished box in the night sky, to be honest, but hey, it's pretty cool. So this is a light cluster. There's in light, in an astronomical sense, means that there's really not a lot of heavy elements in the stars of this cluster. So it's mostly hydrogen and helium, and that's about it. There's not really any other heavy elements beyond that. And that means that these stars are very old. So newer stars usually have heavier elements just because stars before them have blown up or become planetary nebulas, either one, and that has shed heavier elements out into the universe, which eventually can be recycled into new stars. But these stars are so old that they really didn't have access to those heavier elements, so they are mostly hydrogen and helium. Now, where this globular cluster is located is in the plane of our Milky Way's halo. And so usually globular clusters reside pretty far outside the plane of the galaxy. So if we think of a galaxy as kind of like a plate, it's outside of that thin strip and kind of in this arcing halo over it. And so that's usually where globular clusters are in our galaxy. This one's nice. I mean, it has some pretty bright stars in it, but I mean, it's another globular cluster. We've seen lots of those already. So it's pretty cool. Do you want to talk about maybe how globular clusters can come to our galaxy? There's a couple theories.
Really, like, I guess the best idea is that they sort of just the Milky Way befriends them from either like other passing by galaxies or just from the universe itself, as they are components of, you know, things that are external to our Milky Way, as a lot of these have developed even before our Milky Way came about being as we know it. And with the stars, you know, having just different materials and sort of like different compositions as a whole, even compared to like the older portions of the Milky Way, it's important to note that like all 150 that we know about are sort of these things that had formed externally. Now there are some, you know, younger globular star clusters and always outliers as well, but with some of these that are just, you know, super elderly, you know, upwards the age of 13 billion years, it really does just show us that they were brought in. They're now a part of our system. They exist sort of within our Milky Way sometimes, also sometimes like on the threshold. And as they pass through the Milky Way on occasion, they also have a lot of like their stars stripped from them and sort of like brought into our own galaxy in a more chaotic, you know, sense. It's not really as put together as they are in these groups. It's really cool thing to see. There's, you know, a lot of these cases, a lot of these different like star streams that just sort of do appear out there in the sky. Easier to really see whenever you're like, you know, looking in different wavelengths that our human eyes can't really make out. And, you know, these globular star clusters, they kind of do exist almost as their own like really, really small galaxies. And even these dwarf galaxies that are technically external, they'll sort of have the same thing happen to them as well, which I think is kind of cool, where they'll be brought into our Milky Way since it's just much more massive and then sort of stripped apart. And all these stars will just sort of be all, you know, on their own now. It's just a cool thing. And yeah, globs.
I think befriend is a very nice term.
It's a very
what you're
nice term, yeah,
describing.
because galactic cannibalism doesn't sound really much.
Does not sound very nice.
No, and that's the real term.
Yeah.
Yeah. But
that
I'm
is a
gonna call
real
it
term.
befriending. It's sweet.
That is sweet. And we're gonna see some globs in Sagittarius towards the end of the stream. So some of the last objects that we'll see. But you mentioned earlier about the Sagittarius star.
It's like the Sagittarius star stream, if I remember correctly,
Okay.
which is something that I like heard about a little bit more recently, which was it's sort of like this small little elliptical galaxy, or I guess not really elliptical galaxy, that's being torn apart in a very similar fashion. And it was just a really neat thing to see. And it sort of like arcs across the Milky Way in a way, just since it is being gravitationally ripped apart.
That's pretty cool. I
Sounds pretty
mean,
cool.
I want to see that, but I guess our eyes just aren't that good.
It sounds like
So,
super violent,
yeah.
but I'm sure it's like absolutely stunning to like witness if you could really see it.
Okay, so the next object we're going to go to is M29, and while the telescope operators are getting that ready, we're going to sign off on M56.
Let's do it. That's 55.
Oh, well, I think we do it later anyway.
Maybe. All I know is that it is now approaching
Yes, we do.
4 in the morning over here in Flagstaff.
Okay, so we have an open cluster, which is quite different from a globular cluster. Oh, look at that. Look at those 4 stars. This open cluster is known for kind of just looking like a little box. Some people call this the stubby Little Dipper, which
What?
I don't know what to think about that, but it kind of looks like a Little Dipper with like a tiny little handle coming off. Maybe it looks more like a camping mug to me, maybe. That's a better description.
It just looks like stars.
Yeah, okay, fair enough.
I'll be completely honest with you. You can call that anything in the world, or even outside of the world. Those are just stars to me.
Those stars. This one's about 3,740 light years away. One really interesting thing, I guess, historical aspect, more modern history, I suppose, is that of the Messier catalog, almost all the objects have been visited by the Hubble Space Telescope or seen by the Hubble Space Telescope, except for open clusters. Open clusters were kind of just ignored in that category, which I don't know why. Probably just because they're not very interesting in terms of how old these stars are, perhaps. Open clusters generally have quite young stars compared to globular clusters, but basically the Hubble Space Telescope does not look at open clusters. There's probably some reasons why for that.
I think it'd be technology limits
Okay,
because you know
that's
these
fair.
things can be pretty like angularly large in the
Mhm.
sky, and with the Hubble Space Telescope and like the way that it can really like resolve things, I feel like one of the main reasons it may be ignored, because I'm not even too sure myself, is simply because like you know some instruments can't really detect them as a whole. And
That makes sense.
what's like neat about open clusters is that you know for the most part they seem to like form together from similar materials in a similar space. And you know as cool as it is to like pick them out individually and learn a little bit more, that's you know where I guess like star survey missions really come into play more than something like the Hubble. But there's a lot of intrigue, a lot of interest for you know open clusters out there. But yeah, that's kind of a weird thing to think about. But again, probably a really good reason. That's just like kind of my thoughts and maybe
That's fair.
why.
That's fair. Open clusters in general are pretty good for looking at with binoculars. So if you have a pair of binoculars at home, open clusters are usually pretty good targets, just because generally you can identify them pretty easily and the stars are fairly bright. So if you're looking to get started, maybe in using your own binoculars or maybe even a telescope at home, open clusters are a good accessible way to start that. So just putting that out there. So that was the open cluster in Cygnus. This is in Cygnus.
Yes.
Oh, okay. Yes, Cygnus. And just an announcement, we are at 80 Messier objects out of 110, which is pretty good. So only not that many to go.
We're really getting there. Which is
Yeah.
kinda cool.
Yeah. So the next one we're going to go to is M27, the Dumbbell Nebula. So while we're waiting for that, we can sign off on M29, which is
right here.
Yes.
Oh my god. I kind of like skipped in. Oh, that is a real signature.
Wow.
That is truly.
There we go. Okay.
Masterpiece.
So we're going to look at another planetary nebula, and this one's called the Dumbbell Nebula, sometimes also known as the Apple Core Nebula. This is in the constellation of Lopecula. Is that how you pronounce it?
So.
Okay.
That's right.
Yeah. So we can kind of get it in there. We'll probably get a better image. It looks kind of greenish and purple, which kind of looked cool. Actually really liked that color contrast.
It's always cool to see like
Yeah.
color contrast like that.
But in reality, it is a little bit more blue and red that we can see right here. But this is an example of how a planetary nebula can have a lobed effect. So there's two lobes, one kind of going off to the northwest, one kind of going off to the southeast. So you can see how they're kind of breaking apart a little bit. So that's just depending on how that star dies and how energy from that dead star moves out into space, it can create these different shapes in the planetary nebula, which is pretty cool. Now, M27 is about 1,200 light years away, so it's, I think, the closest object we've looked at so far in our segment, which is pretty cool.
One of the closer ones for
yeah.
sure. And a little note on those distances too is with these objects like the nebulae and star clusters, you know, they're very volumetric things. So their distances are more of like a general average more than just like a definitive, oh, this is 1,200 light years away. And that's always something to think about because these objects can be pretty massive. Like the amount of material that is being spewed out into the surrounding universe, it stretches a far away. And this here is, it's a much more loose planetary nebula compared to a lot of different ones that are in the sky. There are quite a few that are still like really compact together, and they're always like called something like, oh, the ghost of Jupiter or something. And they're really cool to see, and sometimes like taking a quick little picture of them or a little video or something can show a lot more than, you know, what can normally be seen.
And just one quick note about this. This is the first planetary nebula that was discovered, which is kind of cool. So the name planetary nebula has nothing to do with planets. Probably when astronomers in the olden days were looking at these objects with their little handheld telescopes, these looked kind of like fuzzy planets, perhaps, especially the Ring Nebula. I could see how that might be a mistake. We just kept the name, which is kind of confusing sometimes. But
just to bring it all around to, we're going to be going to M71 here.
Yes.
Another globular star cluster, but this one's kind of funky. We'll talk about it a little bit and then get on to a nice little break, do a little switcheroo, and then next segment.
So M71 has an interesting history, and this is in the constellation of Sagitta. So back in the day when this object was first discovered, there was a question of, is this a dense open cluster or a loose globular cluster? That was the big question in science at the time, perhaps, or maybe only for like one or two astronomers who really cared about it. And when we get to that object, you might be able to see why. It doesn't look at like other globular clusters we've looked at. Maybe it looks different than other open clusters. So what do you think? If you put in the chat, do you think this looks more like a globular cluster or a regular open cluster? But anyway, we started studying this more, and in the 1970s, we said definitively that this is a globular cluster because it does have other characteristics that align with how a globular cluster acts. So it is a globular cluster according to the International Astronomical Union, and it is recognized as such as a globular cluster in the Messier catalog, but it does kind of look like a loose globular cluster. However, it's still pretty to look at. I think it's pretty nice. What do you think?
It's cool.
Yeah.
It's cool. I like that it's not like kind of in the norm with other globular clusters.
Yeah.
It's kind of a nice little shakeup of a view.
A shakeup. I like that. However, this is one of the, I guess back in the day when this was still called an open cluster, this is one of the open clusters that the Hubble Space Telescope looked at. But nowadays, it is a globular cluster. So kind of interesting how that flip-flop changed around a little bit. But of course, the Hubble is pretty new technology, so relatively. But we're going to sign off on the last two objects, M27 and M71. Oops.
That's funny.
And we're gonna head off into our next break. So we're gonna switch again. You're gonna see Haley, Peter, and Nina back to talk about some cool space objects. And then we'll be back for the last segment around 5 o'clock. So go get some warm coffee or something.
Whoa!
Wow, how the time flies when you're having fun.
We're back. We're all in frame now.
Yeah, we somehow
I
figured
used to
it
be
out.
over here.
I don't know.
over here.
I don't know what we did because I feel like we're sitting in the same spot.
Absolutely
but I
nothing
guess
changed, and somehow it's working now.
Something has
magic.
changed.
Orion
Maybe they moved
magic.
the laptop back. I don't know.
Anyways, for those of you who are just joining us, I'm Nina.
I'm Haley,
I'm Peter.
and welcome to our segment of Everything is in Ophiuchus again.
Everything.
Everything. So this right here is M19. It is a globular star cluster in Ophiuchus. It is 11.9 billion years old, and it is home to about 300,000 stars, and it is about 28,700 light years away. Now, while we're on Ophiuchus, Nina has a really interesting question to ask everybody. So, Nina, if you would.
So, in regards to the story that Peter was telling the last time that we looked at a globular cluster in Ophiuchus, about the god who had snakes for legs, I'm wondering what you think would be cooler, to have 2 legs and each leg is its own snake, just one snake, or if all of the muscles in your legs, each individual muscle was a different snake. If you had to have snake legs, which would you prefer?
You would feel all the snakes.
Do I still have like skin? So so can any, or do my legs just look like can no one tell because it's like because I still have skin, but all the muscles are snakes?
Claire and or Jacob are saying snake muscles.
Thank you. I agree.
I hate that. I
don't
really
like that.
genuinely hate that idea. Like, why so many snakes, Ophiuchus?
Both say
oh,
that.
both say it.
Thank you. You have
Are those,
fantastic taste.
Are those like their own, like each is a sentient snake, or like?
Yeah. Each is a sentient snake.
So like they're just moving how I want them to out of like courtesy. They don't have to.
Yeah. Is there do you have control
Yeah.
over them at all?
Yes.
Like, or do they all move differently? Like, can you
It's
even
like
walk?
Medusa's hair, but snakes.
Oh no!
Wait,
okay.
I don't think is it like that at all? I
But
feel like
like-
it's terrifying. Wait.
I need to not be a part of this conversation.
I think we should move on to the next globular cluster.
All right.
So we are going to head over to M62.
Should we sign off on?
Oh yeah, we should
yeah.
Old
probably sign off.
M19.
Yeah.
So
We should
yeah,
sign it snake legs.
yeah, totally. We should sign it snake legs. So we are now signing our objects snake legs. So
Snake legs. That's like the worst pirate.
old snake legs.
Old snake legs.
Instead of the peg leg, it's
Yeah.
just snakes.
Awesome.
All right, well, let's move on.
All right, welcome to, here we are at M62, actually, I think this is the last one. This is the last globular cluster in Ophiuchus. So we're going to be
That is good
departing
news.
from Ophiuchus for a while. I'm kind of sad. I really love Ophiuchus.
I'm gonna miss Ophiuchus and good old snake legs.
I signed it snake legs.
You signed?
It says
Good.
snake legs
Okay,
on there
good.
now. Yep. All right.
All right, so this is this globular cluster is 11.78 billion years old, contains about 150,000 stars, and is 22,200 light years away. So pretty characteristic of a lot of the globular clusters we've been seeing tonight. This was discovered by Charles Messier in 1771.
Peter was there actually.
I was there. I was there. I saw it. I remember I saw Charles Messier grow up from a wee lad. This cluster has at least 2 kind of distinct populations of stars, so it likely indicates 2 separate episodes of star formation. It also has about 47 what are called blue stragglers. Now Haley was talking about blue stragglers a bit on the last time we were on, like hours ago. I just want to talk briefly about what exactly blue stragglers are, because I didn't know what they were until we started studying for this Messier Marathon, and they're pretty cool. So they are main sequence stars in clusters they're more luminous and bluer than what would be expected of main sequence stars that in such a cluster. Now, main sequence star just means it's a star that's in the prime of its life. It is going through the process of fusing hydrogen into helium. Our sun is currently a main sequence star. So the standard theories of stellar evolution hold that the position of a star on the Hertzsprung-Russell diagram, so that's we call the HR diagram. I kind of like think of it, it's like the periodic table for astronomers. It's kind of how we like to characterize stars. A star's position on this diagram should be pretty much entirely determined by their initial mass and then their age. So because kind of all the stars in these clusters were probably formed around the same time, all stars should lie on sort of a clearly defined curve set by whatever the age of that cluster is, and their position on that curve should be totally determined by their initial mass. So blue stragglers have a mass around 2 to 3 times greater than the other main sequence stars in the cluster. So they're kind of actually exceptions to this rule. They actually fall off of this curve, hence the name stragglers. They're kind of straggling behind. The curve kind of makes this shape, and they're over here. So they're actually straggling behind the other main sequence stars in the cluster. So we don't know exactly how they form, but the best hypothesis Haley was talking about earlier, we believe that they are stars that were in either binary stars, or they came really close to each other and actually collided. And so they formed objects that had a resulting much higher mass, leading to these blue stragglers. Because if for them to have fallen, if they were just kind of formed normally, then they should fall on this curve. But if they instead were formed from 2 stars colliding, then that would probably explain why they're straggling behind this curve. So yeah, those are blue stragglers. I like that name a lot. I think it's I like astronomy names a lot. I think astronomers name things pretty well.
I feel like it depends on what you're talking about.
Really?
Oh yeah.
What do you think?
Yeah. The Great Red Spot.
I love the
Great Blue Spot.
How
Like,
dare you?
come on.
How dare you? I love those names. They say exactly what they mean.
Exactly. They're not creative, I like the creative names. I don't know.
Like Ophiuchus.
Yeah, like Ophiuchus. Okay. Except I feel like that's an astrology thing. Oh, speaking of Ophiuchus, something we wanted to talk about.
Get all the Ophiuchus out now, because
this is the last one. So here is something that some people are not going to like very much, but we're going to say it anyway. Ophiuchus is a zodiac sign.
Yes.
Yeah. So Ophiuchus is a zodiac sign. Basically, zodiac signs are the constellations that are along what's called the ecliptic. The ecliptic is the flat plane of our solar system. So if you are like sitting on a flat plane and you're looking out, it's going to look kind of like an arc in your night sky. And so that's what the ecliptic is. And there, we believed, were 12 zodiac signs, right? Like Scorpius, Sagittarius, whatever.
And of course, mine like 12 months.
Yeah, 12 months. So it was like,
12 signs
perfect.
for 12 months.
Except it's not perfect because Ophiuchus is in the ecliptic. So technically, Ophiuchus is a zodiac sign.
So what is it? What should it be in? Like what?
I believe it is. What is it? Before Taurus? No. Wait,
I thought it was
Scorpius. Yeah. Before Scorpius? After Scorpius?
Scorpius, yeah.
Scorpius.
Scorpius?
Okay,
Yeah.
I see Scorpius, but
So
is it before or after
Or
Scorpius?
in place of. Oh, it has more. Okay, so between Scorpius and Sagittarius.
Okay.
So it should,
And
it should be
has-
taking up some of Scorpius this time.
Yes.
Yeah.
Because Scorpius only has like 11 days.
Or something like
and then
that.
the rest is Ophiuchus.
Yeah, what the heck,
Yeah.
Scorpius?
Right?
Ophiuchus
Oh my
is
gosh.
the 11th largest constellation, according to the IAU.
Nice. Nice.
Question.
I heard about a 13th zodiac crammed in there. Is this it?
Yes.
Yeah. So to answer your question, Dulcimerist, yes, Ophiuchus would be the 13th zodiac sign that is crammed in there.
Yep. Technically, I feel like Scorpius would be the one crammed in there because it's got the shorter amount of time.
Yeah.
But we're not ready to have that
We're-
conversation. So, all right.
Yeah.
Are we ready to leave Ophiuchus behind? Leave behind our snake
Bye,
legs?
Ophiuchus.
Have we signed this one yet?
We haven't. Shall
All
we?
right,
Not.
so we are, we're gonna head over to M39, and while our lovely operators are doing that, we're gonna sign off.
Man, I'm gonna miss Ophiuchus.
I already missed him.
I already miss him.
I got emotionally attached.
The snake legs, dude. It was the snake
Snake legs.
legs. Okay. Nina? Yes. Oh, thank you. Which one was that?
62.
62. Okay. So we're waiting to see if we can get M39.
Yeah.
Man, I'll forever remember you, snake legs. What if we all got tattoos of snakes on our legs together?
like tattoo our entire legs with like scales and make them look like snakes.
No, tattoo snakes surrounding our legs.
Oh, I like that.
Right?
Yeah, I like that idea.
Let's do it. All right. So we are actually going to go to M23 instead. We're going to try to go back. Yeah, to M39 near the end of the night. It's just not at a good place for right now. So we'll try to get it later and head on to our next object, M23.
Woo! M23, an open star cluster.
Ooh.
So we've pretty much entirely been talking about globular star clusters, the three of us anyway. Open star clusters are quite different. Instead of being like the oldest stars in the galaxy, these are actually fairly young. When I say young, I mean these are still like 220 million years old, but that's different from like 11 billion years old, you know what I mean? So young. And this is actually only 2,150 light years away, approximately. And it's comprised of 176 stars. So you can see much smaller. We've got much closer, much younger. So that's kind of a characteristic of open star clusters. So this one is in Sagittarius, and I believe Peter would like to tell you the story of Sagittarius.
I sure would.
Woo.
So I'm going to tell you firstly who we believe that maybe the constellation came from. Once again, we're going back to the Babylonians. So it's believed that this constellation was originally associated with the Babylonian god Nergal, who is the god of inflicted death. So basically that means like unnatural death. So usually death by war or disease. So there's a specific god in Mesopotamian mythology that dealt with this sort of death and reigned over the Mesopotamian underworld of Kur. And this god is depicted as a centaur-like creature, firing arrows from a bow, but is often depicted having wings and actually having two heads. One was the head of a human, the other was the head of a panther. And actually two tails, a horse tail and a second tail above the horse tail that was actually a scorpion stinger. So this was a much more kind of chimera-like creature in Babylonian mythology. But in Greek mythology, then we kind of get more of the familiar Sagittarius centaur. Actually, there are two centaur the centaurs get a lot of publicity in astronomy. There are also, celestial bodies called centaurs, which are basically mixtures, but they're kind of half comet, half asteroid. But there are also two centaur constellations, Sagittarius and Centaurus. So we're talking about Sagittarius, though. So the Greeks often saw Sagittarius as the centaur Chiron. And Chiron was the wisest of the centaurs, as he was actually raised by the god Apollo. He was the son of the Titan Kronos, and thus he was actually an immortal. And he served famously as the mentor for many Greek heroes, including Perseus, Theseus, Jason, Achilles, Odysseus, Aeneas, and even Hercules by some accounts. He was incredibly noble. He was known for his nobility, and he actually arranged a bargain with Zeus to trade his own immortality for the life of Prometheus. Prometheus was a Titan who had actually brought fire to mankind, and he tricked Zeus and stole the fire from Olympus. And because Prometheus actually created mankind out of clay, and the Olympians were very distrustful of humanity. And didn't want to give them sort of the fire because of all that would entail, sort of allowing humanity to progress as a species. So Prometheus, though, loving his creation, stole fire and brought it to humanity. So he was actually chained to a rock as punishment. So Chiron arranged this deal with Zeus. And so one day Chiron was accidentally pierced with one of Hercules' own arrows, sort of in a skirmish. And this era had been treated with the venomous blood of Hydra, as we were talking earlier, one of the creatures that Hercules killed in his trials. And though Chiron was a master of healing, he willingly gave up his immortality as part of this deal. And to honor this noble act, Zeus placed Chiron among the stars as Sagittarius. And he's aimed at the star Antares, which is the heart of Scorpio, should the Scorpion ever attack the nearby constellation of Hercules. So he's even in the sky, he's still protecting his pupils. So that is the story of Sagittarius.
Is Prometheus the one who was punished by having his eyes pecked out by birds each day? It actually wasn't his eyes, it was his liver. Every single day, Prometheus was chained up in Tartarus to a boulder, and Quill the eagle would come down and eat his liver every single day. So
was it Loki who was punished with his eyes?
Oh yeah, so no, it wasn't. So Loki wasn't punished with his eyes being pecked. He was actually punished by having a snake's venom drip on his eyes.
Okay.
Yeah. Yeah. So it's like two myths mushed into one.
That's a really cool. That's cool that there's that similarity, even with the having a god chained to a rock as punishment.
Yeah, it's pretty crazy.
You gotta really admire like the punishments that they come up with in like Greek mythology.
Oh yeah.
Yeah, they get creative.
Like pushing a boulder up a hill for all of eternity.
Yeah.
Oof.
That's fun.
Shall we sign off?
Yes.
M23.
M23.
Boom. Didn't we say we were going to do that?
Oh yeah.
We haven't done that for
The
anything.
owl. All right, so secondary thought. The tattoos aren't just snakes, they're owls on our thighs with snake legs just like going down our legs.
No.
Oh yes. That's a horrifying image.
That's horrible.
Oh yeah.
Anybody wants to draw us?
Yes.
I need the illustrator. Please do.
We're taking the vow right now. We're going to do it.
Oh gosh. All right.
So we're gonna move one up. We're gonna go to M24 this time.
Ooh. Fancy. What? Let's check her
All right,
out.
so we're gonna go to M24. M24 is a star cloud in Sagittarius. It is also just called the Sagittarius star cloud. So what's interesting about this object is it's actually one of the three, and I was trying to check this, it's one of the three Messier objects that is actually not a deep space object. But I don't know what the other two are, so I'm just trying to check really quickly. But M24 is a star cloud. Star clouds are essentially just large regions of the galaxy containing many stars that appear to be closely packed together, but they don't usually possess any structure, though they do often contain, there we go, M40, that's another one. But these star clouds do often contain star clusters within them. It's about 10,000 light years away. It was cataloged by Charles Messier in 1764. And M24 is a part of the Sagittarius arm of the Milky Way. And it's one of the most dense concentrations of stars visible with just with binoculars. With about you'd have about 1,000 stars in the field of view. It does contain two dark nebulae, Barnard 92 and 93. And dark nebulae are clouds of dense interstellar dust. They're actually obscuring any background emission, so they just appear sort of as these dark clouds. Hence the name dark nebulae. But yeah, that's what I had for.
Cool.
Yeah, it's kind of cool. It's really cool. I think it speaks to sort of what's really cool about the Messier catalog is just how you get such a cool. Just a sample of kind of so many of the things we see in astronomy. Like you just kind of get a little sample of everything. Even something that is kind of just not these sky objects at all. Just a dense area of the galaxy.
Yeah. Yeah, I don't think I've actually ever seen this object. It's really pretty.
Yeah.
It is, yeah. Yeah. All right. Okay, next. Have we signed off on this one? Oh, no. So it is
M24.
M24. Whoop, whoop. So next we're just gonna keep going up in the objects and we are gonna do M25.
Yeah. Oh, hello. Almost just head-butted Nina. We're good.
Okay. Nina doesn't need to be here anymore. No, I'm just kidding. Even though she's gonna talk about the next object.
She's just on the floor talking about the next object.
Okay. Nice. All right, so we're heading over. So this next object, just while we're trying to get the telescope all set up, this is another open star cluster. So like we talked about, a lot of the objects that we were looking at earlier were globular star clusters. And these tend to be very, very, very old objects that are densely packed with hundreds of thousands of stars. And these are all very tightly gravitationally bound to one another. And the globular star clusters, they are different from that. So open star clusters are star clusters that are made up of stars that formed from the same molecular cloud, and they're loosely gravitationally bound to one another. These objects tend to be of particular interest to astronomers studying the properties of stars because the stars are roughly the same age and have similar chemical compositions. So they are pretty valuable for research. But for this particular open star cluster, which we have up now, that's really pretty. This one is 2,000 light years away, so a lot closer than some of the other objects that we have been looking at in our segment. This one is 90 million years old, which is pretty young. Yeah, compared to those globular clusters, which were billions of years old, 90 million years old is like it was born yesterday. It's just a little baby star cluster. Not really, but that's kind of what it feels like. So this one is, it's got 601 stars in it total. So yeah, compared to the hundreds of thousands of stars in the globular clusters, quite a bit smaller. But yeah, it's got a decent amount of stars for an open star cluster, and it's about 19 light years across. So
nice.
Yep, that is M25, also in Sagittarius.
Yeah, and it looks like the reason we were having technical difficulties is, I guess, in our program, M25 does not exist. So they had to look up its ascension and declination and point the telescope to it. So, but it is pretty. It's worth looking at, huh?
Yeah.
All right, so there's a question, what's the dust made out of? Carbon or silica or something else?
Referring to the previous object.
I think it's referring to the dark nebulae.
Yeah.
And I don't actually know. Do you know? It's interesting. Yeah, it's like dense pockets of interstellar dust. But I don't actually know.
Oh gosh,
what
is it?
What it would be.
I don't remember.
I mean, wouldn't just be hydrogen, right? Like that's a.
Yeah, I don't think it's just hydrogen. I think it's probably some form of heavier elements. Yeah, so oxygen, carbon, iron, silicon, and magnesium. So yes, carbon and silica are two of the many things that dark nebulae are comprised of. So yeah. Alrighty, so should we sign off?
Yes, we should.
All right, what is this?
M25.
All right, go for it, Nina.
Yeah, so we're just going in a row for now.
Yeah.
I think this is our last object that's in this nice little pattern that we've got going on.
All right, so next up is the object that I have personally been waiting for. It is finally not a globular star cluster. It's not an open star cluster. It is a nebula.
Well, that's not a cluster at all.
I'm going to sign this real quick and then I'll explain what we're looking at.
I can tell that, everybody at home already misses Ophiuchus and all of the globular star clusters. I do too. It's okay.
Too soon to bring them up.
Too soon. Awesome.
Wow,
Okay.
that is beautiful.
Now we're getting somewhere.
Thank you, Jacob and Claire.
All right, so this right here is the Eagle Nebula. Now, nebulae are like my favorite things to image because, I mean, look at this. Look at how beautiful this is. So nebulae are clouds of gases and dust out in space. And this one in particular is actually a stellar forming region. In fact, that middle part there, that's called the Pillars of Creation. I know, right? So the Pillars of Creation is one of the most famous of the stellar forming regions. We like to call them stellar nurseries because it's where baby stars are born. Now, the Eagle Nebula, it is about 7,000 light years away. It is about 5.5 million years old, so way younger than the rest of the stuff we've been talking about. It's a star-forming mission nebula, so it's this kind of like pinkish color because it is primarily hydrogen gas. Now, the reason it's hydrogen gas is because stars are made of hydrogen primarily. So at the center of every single star, there's like a ton of hydrogen. And as the star continues its life, that hydrogen, it's moving around super duper fast, and eventually it'll actually crash into another hydrogen atom. And when that happens, there's so much energy, so much like speed. I almost said fastness. That's not the way I want to pronounce that. There's so much speed that those hydrogen atoms, they'll hit each other so hard that they'll physically fuse. And in this fusion process, they'll let off a little tiny packet of light called a photon. And that photon will travel throughout the star out onto the surface, and that's what causes the star to shine. And so that process, it's called thermonuclear fusion, which is like a terrible 4-syllable word, but if you break it into pieces, it makes sense, right? Because thermo, we're talking heat, so this is the little photon transfer. Nuclear is like atomic level, right? We're talking hydrogen atoms, right? And then fusion, two things combining into one. So the hydrogen's fusing into a helium, letting off that little packet of light. And so that's how every single star out there functions. 5 syllables. Oh my gosh.
Fusion. Yeah.
5-syllable word, but 4-part word. Thermonuclear fusion. Thermonuclear fusion. That's technically 7 symbols. Whatever. You guys understood what I meant, okay? So
30 syllables.
So many syllables. Anywho, so inside of these stellar nurseries, there's a lot of hydrogen gas and they're forming stars. But the really interesting thing is there's a step in this process from going from a hydrogen cloud to a star that we don't quite understand. And so that is something that the James Webb Space Telescope is going to be working on. So the James Webb Space Telescope, it launched on Christmas, and it is so cool. It reached its destination. It's unfolding. It's going to see all kinds of really awesome stuff. But one of the things I'm most excited for is it's going to look at these stellar nurseries and tell us how exactly these stars form out of this gas. And so the Eagle Nebula here, I can imagine it's probably pretty high up on the list of stellar forming regions, just because, I mean, it's like the most famous of the stellar forming regions. So yeah.
Hubble got those amazing pictures. Imagine the pictures that James Webb got.
Yeah, Hubble got incredible pictures. If you look up Pillars of Creation, I can pretty much guarantee that at least maybe top 5, probably the first image is that Hubble picture of the Pillars of Creation, and it's just absolutely gorgeous. But yeah, so Eagle Nebula, it was discovered in 1745 by the Swiss astronomer Jean-Philippe Loys de Chazeux. I don't know. Chazeux, probably yeah. Chazeux. But yeah, so stellar forming emission nebula, super exciting. I personally don't see an eagle here, but you know, to each his own, I guess.
See it. I can kind of see. It's like it's like an open beak.
Oh.
And that's his head.
So the pillars.
So his wings are there, and that's his head.
So the Pillars of Creation are the open beak, and then the gas around it is the wings. If Claire or Jacob can potentially point that out, I know that's kind of so that's the beak. Yeah, and then he's got his head, his neck.
Yeah, there.
Yeah, neck and then wings.
And the wings I think the wings are kind of like
like further out.
Further, yeah.
Nope, other way.
Yeah, exactly.
Yep, that's exactly how it looks.
The wings are implied.
The wings are
implied. You know, I'd never been able to see the eagle before you pointed that out, Peter. So that just like really cleared it up for me. So thank you.
Because that star kind of makes his eye.
Yeah, that looks like the eye. Yeah, so
Maybe it's because it's 4:30. I mean, it's what I'm seeing.
Yeah,
that's
for
true.
Sure.
We could just be hallucinating at this point, but
we're seeing an eagle and there's actually not one there.
Yeah.
But you know, so much in astronomy, you know, with like these objects and the constellations, you really have to use your imagination. So this is an example of how you can get it.
We're being told that birds aren't real, so of course it's not an eagle.
I've never seen one. So.
Yeah, no, birds are not real.
Never seen
especially eagles. Eagles do not exist.
No.
Anyway,
you know what are real? Snakes.
Snakes
are real.
Yeah.
Snakes are real.
Snake legs are real too.
The snake legs, very real. Birds, very not real.
Oh my goodness.
All right, moving on.
All right, should we sign off on
yes.
M16?
M16.
Yes, we should. M16.
Oh, thank you. M16, where are we?
And so next we're going to be going to M17.
Oh, yay.
Yeah, this is going to be another really cool object.
All right, yes. Ooh, thank you.
Oh,
That was very.
That was very aggressive.
Pretty picture.
I'm going to draw over the pretty picture.
All right, so we're moving to M17.
Woo!
So M17, this is another star-forming emission nebula. Yes. It goes by many names. This is a nebula of very many names. Ooh, there we go.
Wow.
It is called the Omega Nebula, the Swan Nebula, the Horseshoe Nebula. I will personally be calling it by none of those names. I'll be calling it by my preferred name, which is the Lobster Nebula. I think that's just the best one. I think that's the best one of the four, undoubtedly.
Where is the lobster?
Okay, no. Hold on. You'll hold on.
Okay.
Okay.
All right.
So it's called. It has a bunch of like lobes. There's a way you could. There has some lobes that are some lobes that look like claws. Because that's why it's also called Omega or horseshoe, because it has like kind of a horseshoe loop shape.
Okay.
But anyways, shush. So this was also discovered by Philippe Loy de Chazot in 1745. It is about 5,000 to 6,000 light years away, and has about 800 stars contained within this nebula. And is actually one of the youngest star-forming regions that we know of, at about only 1 million years old. And this particular nebula is characterized by a lot of very young, massive blue stars that have shaped the evolution of this nebula a great deal. And it's kind of a good indicator for the ways in which very O-type stars, those very bright blue stars, can influence star-forming regions. There are a number in the Orion Nebula as well that have that effect. This was greatly revealed in 2020 by the SOFIA telescope. SOFIA is it's the strangest looking thing to me. I think it's so cool. It's a big Boeing wide-body aircraft that's been modified. Essentially, there's a much more technical way of explaining this, but essentially they've strapped a big 2.5 meter reflecting telescope into the side. It's a collaboration between the U.S. and Germany, and observation recently of SOFIA. So basically, it just flies up in the sky and is actually imaging these objects while it's in flight, and revealed 9 young protostars, primarily in the southern regions of this nebula. There are 3 main regions kind of characterized. It's a little hard to see in this image particular. But there's a center region, a northern region, and a southern region. And these 9 young protostars, sort of these are stars in their early stages before they've gone to the main sequence phase and started, fusing hydrogen to helium in these southern regions. And they also revealed that these 3 different regions of this nebula have different ages. So the center region is the oldest and most active and most evolved, with over 100 of the youngest massive stars in the galaxy. So again, this is a very active region forming these supermassive young stars. The southern region is actually the youngest, and that's where these 9 protostars were found. And what's interesting is that even though the northern region it's in the middle, it's the kind of the middle region of this. It's old, but it's older than the southern region. It's actually, excuse me, it's a dramatic pause. It is far less evolved than the southern region, actually, due to the radiation from the previous generations of massive stars. So these massive stars release a lot of radiation into oh yeah, former Lowell supervisor is an operator.
Yeah, I was going to mention that one of the former Lowell supervisors was an operator on Sophia.
Good.
Yeah.
That's so cool. Wow. Yeah, Sophia's it's a really cool instrument. It's like super unique. Like I wonder who had the idea for that initially. Like, let's strap it to a plane.
Right?
Yeah.
Like, let's just put a telescope up there.
Let's just put it on. But yeah, so it kind of illustrates how these massive stars from earlier generation star formation have actually, their radiation has disturbed the material that would become the building blocks for these stars, preventing them from collapsing and actually forming new stars. So it's forming new stars. So it illustrates how massive stars can greatly influence the subsequent evolution of these nebulae, where even though the northern region is older than the southern region, it's basically been prevented from, it becomes sterile. It's been prevented from forming any new stars due to the radiation of the older stars. So that's just a cool kind of way that we can use the Lobster Nebula. The Lobster Nebula. Okay, everyone. The Lobster Nebula is a kind of a way to study the effects of stars on their own home nebulae.
I'm gonna make you guys really uncomfortable. You know what Wesley says about this? It looks like a nose.
Where?
A nose? The bridge of the nose and then the nostril. Oh, I see it. Yep.
I don't see it at all.
It's like if the person was.
Oh,
like,
I do see it. Why'd you say that?
Because he told me, and now I need everybody else to know.
No, it's a lobster. It's a lobster.
So I'm still seeing it as a swan, personally. That might just be me.
No one can agree on what it's called. That's why it has like 17 names.
True. This is true. I think all of us are kind of unhappy with the Omega Nebula. Maybe?
Yeah, Omega. I don't see why it's called Omega. Maybe is it shaped like the Greek letter?
Yeah, but hear me out. I'm so sick of Greek letters from all the math classes I've taken.
We've run out of them.
I don't want Omega.
I want us to start bringing.
Oh God.
I want us to start bringing in like letters from other alphabets. Like,
right.
I want Norse runes. I want to solve for like whatever the Bluetooth symbol is. The two. Do you guys know that? The Bluetooth symbol is a Viking rune.
Oh, yeah, I did know that.
Yeah.
I did know that. Yeah.
Venus is up and intimidating.
All right, then.
Don't be intimidated by Venus. What's it going to do?
What does that even mean?
Yeah, I don't know.
That's ominous, Sarah. All right. Venus is apparently intimidating, so we are going to move on to the next object, which is going to be M6. So Venus's heralding apparently means that the dawn is coming.
Oh shit.
So we need to
we'll zoom
through. Okay. Oh, let's sign off on. Okay. Swan, you do that. I'm gonna start talking about M6 because we're zooming now. All right. So we're waiting to get that adjusted up on the camera, but M6 is another open star cluster. This one is in the constellation of Scorpius. It is 1,600 light years away, so pretty close to us, and about 100 million years old. So these are significantly younger stars. Most of the stars within this open star cluster are hot, young blue stars. But the brightest star is going to be an orange giant star, which we can start to see here. We're getting a really nice image of it. So yeah, so you can see those hot young blue stars in comparison to the older, colder orange star that we've got going on there. It's about 12 light years across, and it's made up of at least 120 stars. Now, what I like about this open cluster is that it was named by the American astronomer Robert Burnham, and he described the cluster as, and I quote, "a charming group whose arrangement suggests the outline of a butterfly with open wings." And so,
I see it.
Yeah. So cute. So that is how it got its name. This is personally one of my favorite open clusters. I really love the butterfly shape. And when looking at it through a telescope, I think you can make it out a little bit more than you can make out the shape of some of the other open clusters, such as the next one that we are going to look at. Yeah. So do you want to just head on over to M11? This is the wild duck cluster. And for the longest time, I thought that it was called that because people thought it looked like a duck. But apparently it's because it's vaguely V-shaped. And so that V shape looks like ducks flying in their formation, which makes so much more sense because I was so confused. Once it pops up, you'll understand. I mean, like, look at this. What? Huh? That looks exactly like a wild duck. What are you talking about? I don't even see the V.
Where's the V?
Where's the V? I have no idea.
Is it there?
Oh, you know what? Maybe. This is wild
Yeah,
duck,
we're
right?
on our
Yeah,
own.
we're on wild duck. Weird.
Wow.
Interesting. Don't see who sees the V, but apparently it's there.
You were talking that up a lot.
I know I was. I really was.
Maybe
Now I'm disappointed.
Maybe it's when you're like looking at it through a telescope.
Yeah.
Because
Yeah,
like we can probably
probably.
see more stars with this than if you're like looking at it.
Yeah, maybe through an eyepiece.
Yeah,
for
through
sure.
an eyepiece. Yeah.
Yeah. But this was discovered by the German astronomer Gottfried Kirch in 1681. So this was discovered a really long time ago. Peter was like a baby at that point.
I was a young one.
But yeah, this is one of the richest and most compact open star clusters. So this is an open star cluster, even though it looks like a globular star cluster, which I think is hilarious because Claire and Jacob had a globular star cluster that had characteristics of an open star cluster. And I feel like this is backwards.
Yeah, it's totally
So
backwards.
I don't know. But this is about 6,200 light years away, and it is home to about 2,900 stars, and it's approximately 220 million years old. So not too shabby.
Not too shabby
Not
at
too
all.
shabby. Yeah.
Good on you, Wild Duck Cluster.
Good on ya.
Good on you.
But yeah, so do we want to try to get what was it, M39?
Yeah, let's do it.
Let's try to grab M39, see if it's still in the dome or not.
Yeah, so
Why couldn't we grab it before?
It's behind the dome.
Oh.
Yeah. So
let's check her out.
See if we can get it. If not, we'll have to just wait for a little bit later in the night/morning, I guess, because it is now 4:42 in the morning.
It is almost 5 a.m.
Woohoo!
Maybe fainter.
Maybe fainter.
That's
Okay.
fine.
That's okay.
As long as we can get it, we're happy.
Okay, maybe not.
Well.
So yeah, we may have to wait a little bit longer for this one, just to really let it get out from behind the dome so that we can image it.
Let's go ahead and sign off on
6 and 11.
the stuff we have seen. Yeah, 6 and 11.
Let's do it.
Go for it. Cool beans.
Yeah. And then we will be signing off.
Yeah, thank you guys.
Yeah. This is the last you'll hear from us tonight. So thanks for hanging out, listening to us.
Yeah.
Thank you for humoring all our jokes and shenanigans.
And never forget owls with snake legs.
Never forget owls
Never
with snake
forget.
legs.
I think you should forget that because nobody wants to remember it. Anyways, have a great rest of your night, and we will finish with Jacob and Claire.
Good to see you guys.
All right, welcome back everyone to the second annual Lowell Observatory Messier Marathon. We are in the very last home stretch, so this is the last you'll see of this live stream because we're going to hit the last of our objects through this segment. So we have quite a lot to go through. Towards the end, we are going to move quite quickly just because the sun will start to rise.
Well, we're speed running.
Yeah,
It's going to be great.
It's going to be awesome. We're going to see so many objects in such a short amount of time that it's going to be amazing. So to start us off, we have the open cluster M26, which is in the constellation of Scutum. This one's about 5,000 light years away, so not too far, not too close. One thing that it spans about 22 light years across, which is pretty interesting. But honestly, it's another open cluster in the night sky. Kind of looks like another box to me, like some of the other ones we've looked at. So we're going to go ahead and move to M7, which is a little more interesting. And this is an open cluster in the constellation of Scorpius, and it's also known as Ptolemy's cluster. And Ptolemy is a very interesting person of the ancient Greek origin. So we're going to look at this object next. But yeah, we're excited to bring out the home stretch. I'm so happy that all of you have joined us so far. Excited to see what we're going to see. So this is M7. It is an open cluster. We have some pretty bright stars towards the top of that image. This is technically a naked eye object. This is an area which is kind of seen as the stinger of Scorpius, the scorpion in the night sky. So you can kind of see it with your own naked eyes, or at least with a pretty easy pair of binoculars. One other thing is that this is the southernmost Messier object. So this is as far south as we're going to look tonight, which is pretty cool. So that's pretty cool. I don't know. So this is one of the objects that have been known since antiquity. So the reason why it's called Ptolemy's clusters, because Charles Messier was definitely not the first person to look at this. It was first cataloged by a Greek-Roman astronomer and philosopher named Ptolemy around the 2nd century. And he described it as a nebula, which is kind of interesting because nebula in Greek means cloud. So maybe to his eyes, it looked a little more like a cloudiness in the night sky. To us, it looks like these nice, bright, defined blue stars. But Ptolemy, you may have heard that name before. He is famous for writing one of the first astronomical models and creating one of those called the Almagest. So maybe you've heard of that before. That comes from Ptolemy. And this is one of the objects that he cataloged back in the second century. So pretty interesting. But this one also looks like a box to me. What do you think?
That's not really a box. I mean, kind of looks like nothing. More stars. Never mind. Yeah, I don't know where I was going with that. It's approaching 5 in the morning, so
Yes, it
my
is.
brain function is slowly flatlining. Besides that, though, it is a pretty cluster,
It
and
is.
those bright blue stars just really stand out in the foreground there. It's kind of
Mhm.
cool.
It is. It's nice. And there's so many stars like in that area. So if you kind of look beyond those bright blue stars, you just like see so many. And then there's kind of like dark cloudy bits weaved in between. This is just a really beautiful picture to look at.
Baby Hercules. That's cool. I see
okay.
it.
Okay.
I see it. You got like the arms and stuff.
So we're having a discussion that this looks like a baby Hercules cluster, or sorry, baby Hercules constellation, maybe. You can see it.
That sounds like a Haley thing.
Yeah.
That must have been a Haley thing.
Probably. So we can sign off on M26 and M7.
26 and M7.
And we're gonna try to go back to M39, that one that was kind of stuck behind the building. We'll definitely be able to get it. We just need to give it a little bit more time. So we're gonna sign off on those.
There we go. That does not look like an eye.
Ooh.
That's okay.
And M7. Oops. There we go.
Fancy.
Nice. Okay, so we're moving the telescope to M39, which is another open cluster.
Given that
So
the
we'll see.
shot, hopefully it's not building.
Yes.
A bright orange
It
building.
might look a little bit faint, might look a little bit,
Oh, that's building.
still building.
That
Okay,
is-
we'll
that
have
is
to
definitely building.
we'll have to go back to that one in a little while. So we'll keep you updated on that. For now, let's go to M18. I'm keeping track of the objects here because we have quite a lot to go through. So the M18 is an open cluster in Sagittarius. So we're still pretty low in the sky right now. So this is in between a couple of the objects that we hit in the last segment. It's in between the Swan Nebula, or as we discussed, the Lobster Nebula.
Or the Omega Nebula.
Yes, or the Omega Nebula, and the small Sagittarius star cloud. And this is actually quite close. This is about 4.23 light years away. So I think this is the closest object that we've looked at so far tonight. Yeah, that's pretty cool. Yeah. So it's it looks like a curvy triangle to me, that cluster right in the center. My imagination is not very great right now.
Yeah, no, that there is just stars again.
It looks like a Dorito chip, maybe.
Dorito chip.
Yeah.
Yeah, really weird Dorito chip.
I mean, it's cool to look at. So this is a very sparse cluster. As you can tell, there's not too many stars in here. And this is one of the few remaining Messier objects to not be photographed by the Hubble telescope. We touched on this a little bit earlier, just how open clusters may not be able to fit within the field of view of the Hubble Space Telescope or something like that. But this is one that our camera can get quite nicely. So we have a nice treat with M18, which is pretty cool. So just checking on the clock here. So we have a little bit of time to kill. So we're going to talk about some cool pets of Lowell Observatory's past. So we're actually going to need to share our screen. And while we're waiting for that, we can sign off on M18.
You get that. And you can even sign for me because I'm not fancy by any means.
Okay.
So we'll get this all loaded here. Exit out of our last cool presentation. And then go into here. Go there.
So we're going to share our screen.
Beep, boop. Bop.
And we're going to talk about ghost
Bam.
pets of Lowell Observatory. So we're going to hit up some pretty interesting pets or animals that were living at Lowell Observatory back in the olden day. So let's get started.
Let's get that first one there.
So probably the most famous.
Venus the cow.
Venus the cow.
Venus the cow.
With her calf named Satellite.
It's a really funny name, to be honest with you.
Very cute.
Adorable name for some reason.
Yeah.
Doesn't seem like it would be, just
Yeah.
Satellite. But it works.
Well, Venus doesn't have any moons, so I guess they were out of a loss to what to call the calf, because there's no moon of Venus. But we send spacecraft there, so. But not when they, not in satellites time. That's very true. One cool thing is that you may have heard the name Vesto Slipher before. He's a very important astronomer of Lowell Observatory's past, and part of his job while he was here was to take care of Venus and Satellite, which is kind of cool. There used to be a barn here at Lowell Observatory that was constructed. It has since been torn down, so it no longer exists as a barn. There's not really one where it used to be, but hey, we had some cows at Lowell Observatory back in the day, which is pretty cool. So we're gonna go to the next one.
Moo.
We're gonna go to my favorite, which is
cool.
Skippy. Skippy the dog.
Look how happy he is.
He's so happy.
Just a handsome little lad.
Handsome little lad. So this is Skippy the dog. He was at the observatory from 1952 to 1962, which is a pretty active time in astronomy. That was kind of like,
There's a lot going down.
yeah, there was lots of looking at the moon and stuff like that. Space race-esque type of time period. But how some astronomers described Skippy back in the day is an astute heckler of skunks, which is just so cute and adorable.
It was a fun little thing to run across there. I didn't even notice it until we got the picture. We were like, oh, he's an astute heckler of skunks. It's quite the title, actually.
Yes, I just love this picture so much. He just looks so incredibly happy. Just a little happy observatory dog. So that is Skippy, the cutest.
Such an adorable little doggy. We've also got the cats too.
Yes.
There's cats everywhere. There's still cats up there.
There's still cats up here.
Run around.
Our director, Jeff Hall, has cats. These are the cats of the 24-inch Clark Telescope custodian, Harry Hussey. So,
the one just sitting on the desk there is all in loaf mode.
Loaf mode cat right here, and then there's one sitting in the lap.
Oh, I didn't even notice that.
Yeah, so here are the two cats. Unfortunately, we don't have names for these cats. We don't have them in our archive. So maybe you guys who are watching right now at 4:59 a.m., almost 5 o'clock, can get some names up for these cats for modern day.
Or nicknames, rather.
Nicknames. They probably had names. So maybe some nicknames for remembrance for these two cats. What comes to mind for you?
Craig. And Jimbo.
Oh, okay.
Those are
Which one would be Craig and Jimbo?
Don't know.
Okay.
Those
Fair
are
enough.
the first two names that popped into
Fair
my
enough.
brain at 5 in the morning now.
Okay,
5 o'clock.
nice.
Woo.
I like that. Yeah, I don't have any names.
You don't have any names?
No.
No, really? Not even first two?
Let's say, oh gosh. One would be called Perseus. The other one would be called Collimator.
What?
I have no
Alright.
idea. I'm looking behind me. There's like a wall of tools, and I'm just looking at the names from that because I literally cannot think of
The
anything.
wall of tools.
Yes.
You're not thinking about Skywatcher AZ-EQ5 parts.
That would be
That's
a
cool
great name for a cat.
But in
Lunt
that case-
Solar. So those were some of the pets of Lowell Observatory's past. Although we have pets of Lowell Observatory present, we have lots of dogs here, most notably Lucky the dog.
Lucky the dog.
Lucky
He's
the
a cute
dog
little
is
dog.
very
Skips around all day.
Yes, very friendly. He comes up to you. There's also the cats of Jeff Hull, like Mars and the other ones. I don't remember. But anyway, Lowell Observatory is full of pets, and it still is. Was back then. We don't have a cow right now, but that's probably for the best. They're kind of hard to take care of. It's pretty cold up here too, so I can imagine why we wouldn't want to do that at the moment. But we're gonna switch back to our view of the night sky. Oh, we got we got some names coming in. We got
Jeff's cat.
Pluto is one of Jeff's cat. Okay, so that makes sense
Yeah.
because Pluto is discovered here. That makes sense. We have a comment about the name Perseus, which that's what I gave. Perseus.
But did you have that like intentional sort of?
I did not.
weird
I
pun?
was not that
Exactly.
pun intended at the moment. So hey, yeah, well, that's okay.
We have a cool object.
We do. We're going to go to M21, which is an open cluster in Sagittarius. So we're kind of going to stick around the Sagittarius area for a little while because it's what's coming up right now. This is Sagittarius is not going to be where our last object is, but it is going to be some of the last objects that we're going to hit. Forewarning, we're going to look at a lot of globular clusters, but that's okay. We're going to move pretty fast at that time, so we won't dwell too much on each object. We're just going to try to get through them so that we can get all the objects seen before sunrise. So this is M21. This one's about 3,930 light years away. This is a young but densely packed open cluster.
Look at those blue giants.
Yes.
Those are cool.
Those are pretty cool. Those are really pretty. Those are some pretty stars. Although from my Google search earlier, these are mostly small dim stars in this cluster. So maybe those blue giants are, oh yeah, a few blue giants are kind of the outliers. So most of the stars we probably can't see very well with our point of view currently. But hey, M21 open cluster, we can sign off on this one. And we're gonna let's try to go back to M39. Let's see if that's high enough out of the building. So let's get to M21.
You can sign for me too, because you kind of handed me a highlighter here, and
Oh,
I don't know if that would show up.
Probably not. So we're gonna try for that M39 that has been lurking behind the Godot roof for the past couple of minutes.
The elusive M39.
I mean, probably. I don't know what it looks like.
An open star cluster, that's my guess.
Oh, it's pretty dark. Let's see. Do we think we can get it? I'm gonna wait for the, oh, I don't see anything.
There's no way.
We might have to come back again, but that's okay because we'll definitely get it. We're gonna
They're
try.
giving it a shot.
We're gonna try a couple more seconds.
I believe.
Yes.
I'm
Determination
I'm a
here.
true believer.
Yeah. We're gonna get it though.
Even if I see dots, I think that is.
If we see a star, that's good enough to me. Almost there. Oh, not quite. We're so close, I think. So close.
I don't see anything here, at least.
I don't see anything either.
Dang it.
So we'll come back in just a moment. Let's go to M20. We'll spend a little bit of time on this one. So M20 is called the Trifid Nebula.
And it's cool. It's a really neat nebula.
Yes.
It's just, yeah.
So we're gonna go there. Trifid Nebula is a star-forming nebula in our galaxy. And when you see it in just a couple of moments, it'll look pretty mind-blowing in my mind.
Part emission, part reflection.
part dark nebula.
Part dark as well.
Yeah.
Oh no,
Ooh, look
cool.
at that.
That's cool.
That looks awesome.
It's pretty close to the horizon. You can tell because the telescope is like putting it in a really weird spot, but it's cool. Got some nice contrasts in the colors. Just yeah, beautiful object.
So we're doing something called jogging the telescope, which is moving it just a little bit at a time so we can try to center up this object, which it's fun to see how we move telescopes in small ways. So you can see how it'll move on the image. So we're moving it down just a little bit. We're going to do it again. Pressing some buttons here. It's always fun to see this on the other end of the telescope. Let's see. We're gonna try to behave. Yeah, we're looking at some pretty cool patterns of stars. It looks like a basket to me, like basket weave. Yeah, that looks so cool. It's like artwork. Yeah, that looks good.
We're getting there.
Yeah.
Just another awkward 10 seconds.
No worries. So we can start to see it in the middle there. So by the next exposure, we should have a beautiful image of the Trifid Nebula. There we go.
That's pretty.
That's beautiful. Good. That is just so good.
For what time it is currently, that is fantastic.
That is fantastic.
That's a weird thing to see in March.
Yes, it is. It really is. So this object, again, is in Sagittarius, and it's about 9,000 light years away. And it is a star-forming nebula, which means that stars are being born in this nebula in some way, shape, or form over the course of probably millions of years. So really long time spans here. But as Jacob was mentioning, there's 3 types of nebulas in this. Do you want to rehash?
That's just hitting all 3. Yeah, reflection, you got dark, and you have emission. Each and every one of them are sort of like divided into this just one object, which is super cool.
So the yeah,
just a lot of material for those stars to form, to undergo some very weird processes and reach a mass in which you get that thermonuclear fusion.
So the emission nebula, that pink sphere that you can see kind of towards the center. The reflection nebula is that blue lobe on the top. And then the dark nebula are those gaps and bands that kind of cut across those 2 lobes that kind of give it a trifected.
That's a word at 5 a.m. That's fine. We're good.
Split into 3 parts, which is how it gets the name Trifid Nebula, as in tri, prefix for 3. Whoever thought of that, pretty nice,
Genius.
I guess. Yeah.
Literal
Spot
genius.
on. Yes. But anyway, I think it's really cool to be able to see all 3 nebulas in one. I particularly like dark nebulas the best because they give us the most detail in my mind. So those dark little combs cutting in are really neat. They give a lot of detail. They're very like dense, dark. I don't know, I just like dark nebulas.
Indubitably.
Yes. So that is the Trifid Nebula. We're gonna sign off on this one. Jacob, you can do.
I'm not gonna sign your name.
Yeah, you probably shouldn't.
I'm doing it.
Okay.
I'm running it. That's fine.
This is M20. So as you can see by the sign behind us, we are getting close to the end.
Wait till you see that
G. Wow, that was pretty good. Pretty good. Nice. Okay, so we're gonna go to M8 next, which is called the Lagoon Nebula. So we have another really cool object to look at. So marking them off the sheet. M8, the Lagoon Nebula. It's going to be about 5,200 light years away.
Nice. Personal favorite with this one too.
Why is it your personal favorite?
A lot of different reasons. I could go on, but it is almost hustle time, which is going to be fun.
Almost hustle time. Do we want to do any of these?
Oh.
Okay. Okay.
Oh, it's not
Sweet.
bad.
That looks pretty good. We'll wait for one other exposure, but you can see that there's gonna be some awesome pinks and blues and purples and bright stars in here, and also some dark nebulous aspects. The Lagoon Nebula is just big, bright in your face, and pretty awesome. I really like it. This one's technically an interstellar cloud. My bad, not star forming region. It's an interstellar cloud.
It's got some ionization going on,
Yeah.
which is kind of like similar to how the star forming regions sort of act with
true.
Things being ionized and small little pockets of brightness, but it's a very, very, it's a neat view. It's a little bit different. It's much more dense towards the center there, almost like when you overexpose the Orion Nebula.
Yeah. And this is in the constellation Sagittarius, in case we forgot to mention a couple moments earlier. But hey, look at that picture. It looks so good. Look at all those bright stars in the foreground. It just looks so amazing for 5:10 a.m. in the morning. Doing pretty good. These are some pretty views. So we're going to try M39 again. Let's see if we can grab that hiding open cluster. I believe this will be the time that we see it.
You believe? I believe.
Okay, that's pretty good. Usually you're a pessimist, so.
That's not true.
Okay, maybe. I don't know. We're gonna try for M39, but hey, while we're waiting,
coming.
Let's sign off on M8.
M8.
Yes.
All right, you ready for this?
Yes.
I'm so ready.
Hey, we got it. Nice. We can hear screams from outside from the telescope operators.
Wait, we
as
should
they
totally
finally
steal this
got
object. It wasn't even ours originally. Let's sign off on it right now.
Yeah, we're gonna sign off on it. Sorry, other group. This is our object now. Haha. But this is an open cluster. There's bright stars in here, kind of loosely packed together. That's about all I can say about this. M39.
It is an open star cluster, and boy, does it look open.
Yep, but it looks pretty open. So now we're going to get into what we call the hustle time, which is where we're going to zoom through globular clusters for the last section of this Messier Marathon. So the first one we have up is M28. And that is a globular cluster in Sagittarius. So we're going to be hanging around Sagittarius for a little while.
And a bunch of globs, and they're far, like
they are pretty far.
Further than 2 football fields far, which is crazy.
That's an accurate measurement
That's
for
very
sure.
true, yeah.
Yes. So this one's going to be about 17,900 light years away. Look at that glob, pretty good. But this one's really cool. We have a little fun fact about this one because it is famous for containing something called a millisecond pulsar, which means that there is a star in this cluster that spins every 3 milliseconds, which is just mind-blowingly fast. So good for that millisecond pulsar. Yeah.
It's zooming.
It really is zooming. Yes. So that's M28. Let's go ahead and sign off on that one, just so we don't forget.
I can even just leave them all and we could do some massive sign off.
No, we're gonna do it in time.
No,
So
we
I'll
can
do
do that.
M28 for us.
Cool. M22 will be our next friend up here in view. Another globular cluster in Sagittarius.
I kind of made the eye as the M, sorry.
And with M22, we are reaching 100 objects found.
Woo! Look at that. We'll need 10 more to go after this, which is
lot of objects.
pretty awesome. We're in the home stretch. This is exciting. So we're gonna go to M22.
M22, yeah, another globular star cluster, and
Another
the
one in
first
there.
one,
There we
right?
go. Yep. This is the first globular cluster ever discovered in 1665. It's a nice 10,000 light years away. Pretty cool.
It's far, but not far.
Yeah.
It's kind of like closer to us than some globs can be.
Yeah, but this one's honestly like really pretty.
It's
There's
very
so
pretty.
many stars in there. I like this one a lot. Okay.
Underrated.
Yeah.
Underrated.
It looks like we have a question. Do you have any stories about Sagittarius involving snake legs? The other group scarred me for life.
I don't think so, luckily,
No.
which honestly, I'm a little bit scarred too, to be honest, because there were some very, very strange, not even analogies, but just mentions of things and snakes and legs and muscles that
6 a.m. nightmare fuel for
it's-
sure.
Yeah. I mean,
Yeah.
5 nightmare fuel.
When we go to sleep.
If
after
I
this.
go to sleep,
That's
is
true. If is the big question. So no, we don't, which I guess you can decide is good or bad. So
for better or for worse.
yes.
That's it.
All right, so that was M22 globular in Sagittarius. We're gonna go to M69.
Another globular star cluster.
It's gonna be
Guess
pretty-
where? Sagittarius.
Sagittarius is gonna be a pretty nice one. We're gonna sign off on M22 while we're waiting.
Woohoo! Oh, you get the fancy signature and I get just 2 letters.
Sorry, that's
All
how
right.
you've done it this whole time.
I'm going to just hey, look what you've done.
I'm sorry. All right, I think that's it. It's a little glob in there. This one is the most metal-rich globular cluster. Apparently, it's very rich in iron. So no anemic globular cluster here. It's about 29,700 light years away, which is pretty far. But this is just another glob in Sagittarius. So pretty nice. We're pretty low in the sky right now.
And then on to another glob in
On to another
Sagittarius.
globular
M70.
cluster, M70.
M70.
Would you do the honors of signing off this
sure.
time? So we're moving the telescope. Again, we're kind of zooming through objects right now. We are fighting the imminent sunrise.
I gave you really large letters. M69.
Oh no. So yeah, and apparently the threat of Venus. Venus is quite bright in the early morning.
Venus is always looming.
That's true. All right,
At some point.
here's M70, that Sagittarius globular cluster. It's about 30,000 light years away, which is pretty far. It's just another globular cluster in the sky. Looks pretty good.
On to the next one.
On to the next one. Let me check some of these off. So we are going to go to M54 next, which is a globular cluster in which constellation?
Sagittarius.
Oh,
Yeah, that's
how
what it
did
is.
you know?
Just a very lucky guess, I guess.
So we're going to see what this one looks like. Did we sign up on M70? I don't think we did.
Probably not.
No, I will do
No.
that.
Oh, look at that. It's another globular star cluster and one almost in the exact same spot as the last one. That's really cool.
That is pretty cool.
A lot of stars.
Lots of
It's
stars.
a lot of stars. It's been heard and told all night.
Heard and
So,
told.
On to the next one.
Sure. M55.
M55.
Would you sign off on M54?
I will sign off on M54.
Perfect.
Let's do this.
We're hitting the objects really nice now. It is 5:16 a.m.
And we gotta beat that. We gotta beat the sun.
We gotta beat the sun. We're expecting to be done around 5:30 or so. Kind of depends. We might need to wait a little bit, stall for time, just because some
Something's
objects-
happening there.
Yeah, maybe a tree. I think
Maybe.
that might be a tree.
Glad we got
Yes,
a tree.
looks like a tree.
Multiple people.
But hey,
saying
we
tree.
can still see it, which is
All that
we
matters.
need. All we need. So this was M55, globular cluster in Sagittarius. It looks kind of like a loose globular.
Astronomical twilight has begun. So on to the next one here again.
All right.
M75 is
All right.
up next for us.
Yes, I will sign off on M55.
Oh, we're absolutely getting there.
If I can count my way to this object.
All right, so M75, another glob in our friend Sagittarius once again, and hopefully it's there. Just looks like a glob for us as these last bunch have. There we go, little glob out there.
Nice, look at
I'll
it.
sign this off for us. You go to the next one.
This
You
is
know.
a tiny little glob. We're gonna try for M15, which is a globular cluster in Pegasus, a very beautiful globular cluster, might I say. This one's pretty low, so we might need to wait just a little bit. But hey, there also could be trees in the way, but we're gonna see what we can get because we might as well try while we're up and excited right now. So we're gonna see what it looks like. The anticipation has begun. Ooh,
Oh, there it is, and it's beautiful.
look
It's
at
great.
that.
It's got a funny little
Look
star
at
near
that.
it.
Nice.
It's a cool little thing.
M15 is probably a favorite of Lowell Observatory telescopes.
I would say so,
Yeah.
for sure.
We like looking at this one through basically all of our telescopes. It looks really good through our 32-inch telescope. Also an update, we're at 105 objects now. We have 5 more to go for the 2022 Messier Marathon. We've done a stellar job, might I say,
was
so
horrible.
far. I thought it was great. Thank you very much.
Now 106. With that one.
Now
in
we're
front.
at 106 objects with M15. That's pretty exciting.
Make it 107.
Let's make it 107. Let's go to M2, which is a globular cluster in Aquarius. We are finally out of Sagittarius. I guess we were last time with Pegasus, but close enough. Did you sign off on M15?
I did.
Okay. Jacob's on a roll. He's already ahead.
I'm signing.
All right, we're gonna go to M2, a glob in Aquarius, which should be pretty neat. Let's see how this looks. Nice.
That's a globular star
That looks
cluster,
pretty
and that's
good.
also sunlight starting to show up a little bit there.
The background sky is getting a little bit lighter, so we can tell that astronomical twilight has begun, and the sun is slowly inching its way up the sky. That's the 17
Was that the 17? Oh,
Oh.
no, it's the 17.
something.
Something's in the way, and
Yes.
that's not the sun, but still,
The
it
sun
is.
is
It is. It's
coming.
coming.
Yes.
It absolutely is.
Okay, both is good.
Both.
Perfect.
Both. Yes.
Perfect. So we got M2.
We did
Let's
get
move to M72, a whole 70 objects into the future, the Messier catalog. We'll see how this one looks.
That is
Pretty low.
Very low.
Yes. Apparently we were pointing at the 17-inch plane wave, which is sometimes how we can get a little bit of glow. It kind of blocks some of that light.
Oh, that is very dim. But
it is dim, but it's there.
It's there. That's what matters.
That's very true. Look at that. M72 is a glob in Aquarius, globular cluster in Aquarius. So we've been hitting a lot of globular clusters lately, but hey, that's not a bad one. We're at 108 objects.
True. And we could switch it up a little bit because M73, our next object here, is not a globular cluster. It's an open cluster.
It's an open cluster. How exciting.
Also an Aquarius.
All right, let's see. It's right next door, so I have high hopes that we can see it. We shouldn't hopefully
Don't
not.
say that.
Shush. We have time. It's only 5:20.
Yes.
All right, we're gonna try for M73. This is it. Hey, look at those stars.
Those are stars. And I mean, it's in a little picture here. It's this like kind of weird little group there in that V shape. And maybe some other stars with it too.
Looks like a mini Dorito chip.
It is an asteroid.
Oh, okay.
At least that's what it's kind of listed as.
Yeah.
Here.
That's fair.
Yes.
All right, so we have one more object to go. It is 5:21 a.m. Now we might need to wait just a tiny bit for the Earth to rotate just a little bit more, but our last object will be M30, which is a globular cluster.
Globular cluster. You thought it was done.
You thought it was.
You thought it was over.
But this is in the constellation of Capricorn. So we're going to see how this looks. We might need to kind of stall a little bit, wait for time, just a couple more minutes. But we've done pretty awesome so far. This is like really exciting.
109.
We're at 109 objects. Oh. It looks like we'll have to wait a little bit. Just a little bit.
We'll have to wait a little bit.
Yeah.
This has been great.
This has
been cool. It's neat to be able to do a Messier Marathon period and pointing at the groundish. That's apparently where the telescope currently is.
Nice.
Which is always a problem. You know, you want to see the sky, not the ground.
That's very true.
And when the telescope's looking downwards,
that's true.
A little bit too far, then it's not where it should be. I don't know where I'm going with this. Very roundabout. I'm just very excited as we are sort of rounding out the entire list of Messier objects here with the 110th object here very soon.
So we can start to see as each exposure passes that the sky is getting a little bit darker. So I think once we get the faintest glimmer of a globular cluster, we can check it off our list. And
absolutely.
Yeah, so we should be there. Oh, it looks, I don't know. I thought I saw something, but maybe I'm just imagining it.
I think I see something. Move the 17.
Okay, nice. So we move the 17-inch telescope out of the way, which will help us view this object better so it's not orange/yellow anymore. So yeah, each exposure, we're just gonna wait to see if we can see just a little bit of a globular cluster. I think, oh, maybe I don't see it. I think I'm just imagining things now. I think I'm so excited to see M30.
I'm excited to see M32.
Yeah.
I'm also excited to stall because that's exactly what has to happen while we wait for this object to literally just come into existence for us, at least visually here. But it has been a wonderful night. I've at least been here for the entire thing. So it's been a very interesting just to see everything all go down and just been cool to see everyone sort of tag along and say hi and chat and chat with us, et cetera, et cetera, et cetera.
I think
it's been great. Yeah.
I think it's also fun in this early morning section because we get those early birds coming back from the beginning of the live stream to check in again at the very end.
Or the really wild people who are just here all along, you know.
That's true. So that's pretty interesting. Yeah. Good for them though. I don't think I could do it.
Absolutely. But in the meantime, I keep looking over to the side here because with all the other animals that we have, right?
Mm-hmm.
You know,
we have a new friend.
We have a new friend because you know there's always animals up here on Mars Hill just because it's kind of out in nature, and just so happens that we kind of share homes with a lot of things. And there's a mouse. There's a mouse that I saw running through here, and he's absolutely cute. And I made a friend while we were out here, just sort of looking at the sky, slowly going crazy just due to the later and later time. In fact, this is just about an hour away, hour and a half away from me being up at least for 24 hours straight, which is pretty wild. And
Jacob, what's the name of your new friend?
name my friend, my little friend, the mouse. I think Charles Messier is kind of a cool little.
What about Mousier?
Mousier?
That's
kind of horrible. No, actually, that's
I thought
okay.
it was cute.
It's kind of cute. It's
What
just
is-
pun names kind of hurt sometimes. You know, you get a pun name. Could you imagine being called a pun name? Could you imagine being named a pun name?
Jacob, what if your name is a pun name?
It's not. I'm just named after an artist,
Oh.
which is really full of myself.
What does the audience think? If you have names for Jacob's new mouse friend, put it in the chat. We'd be intrigued to hear what you have to say.
The little mice that run around here, they are adorable. They got these just big old heads and long tails. They just scurry around, and you can catch them outside pretty much anywhere. They're
So
all around there.
we can try to go back to some favorite objects. What are some of our favorite objects? that are
Really,
up
it
right
just
now?
depends on like what's up, because the whole sky has pretty much moved
It
since I've
does.
been here. And
It has.
my favorite objects, at least with like the galaxies a little bit earlier on, with 81 and 82, those are absolutely stunning. And I'm not sure.
I don't know. if
We could
can
go back
get
to
them.
Lagoon maybe.
Yeah, let's go back
Yeah,
to
let's go back to the
Lagoon.
lagoon, because the lagoon is definitely a personal favorite, and it being an interstellar cloud really is it's unique. It's neat.
Interstellar cloud. It just sounds so fancy. Interstellar cloud.
It's got a very royal name. It's
Very royal name. So it might look different from what we pictured earlier, just because the sky is slowly getting a little bit brighter. But it should still look pretty cool. So we're gonna keep our sights out for that. So yeah, returning to some favorite objects while we wait for the Earth to rotate, which is probably the most annoying thing that astronomers have to deal with.
Time.
Yes.
Oh goodness.
Oh, look at that. It looks awesome. Wow.
It's
Look
very
at all
pretty
those
there.
blues and purples.
Yeah.
So pretty. What a beautiful object.
It just looks swirly. That's like kind of like my favorite
Swirly.
descriptor of it. Is
Nice.
towards the center there, you kind of get like this weird sort of reflection effect. It almost looks like a reflection, sort of like there's some water inlaid in between those gaseous clouds.
Wow.
And it kind of like swirls all downwards. It's really
Okay.
cool, and all those little stars there just illuminating those gaseous pockets that are just all about the view. And the Lagoon Nebula is neat. It was technically the first object that I had taken data of when I was first learning how to use the CCD
Hey,
at NAU's campus here. So that's like one
that's
really
cool.
neat little thing. I still have the original like fit file of like
Wow.
the data that I had taken for this, and it's just a super cool thing to always like come back and revisit. It was good for that, because I believe I started to like learn that in like the late summer when this object started to just set a little bit. So we were like, let's get it before it goes, and that I did at least. So I love this thing. Sort of like sparked my enjoyment of using CCDs, even though sometimes like getting all those images and making one nice composite is something that just makes me want to tear my hair out completely. It's still a really neat thing, and that's kind of where it began for me, because it was just like, oh, this is how this all works. This is how like flats and darks and biases play into like the final imaging process, and a whole bunch of other weird, crazy space things. Sombrero.
Let's go to Sombrero.
We can give that a shot.
Let's
Why
hit up
not?
a galaxy.
We can get
So we're
another
gonna.
galaxy too. That is another one of my favorites too. I told someone a little earlier in the evening whenever we were looking at it through the 32, if it's still really nicely visible, which it should be, because it's right between, was it Corvus and Virgo, if I remember correctly.
M104 is Sombrero. Okay, it
Yeah,
looks
this
like you
is
guys got it.
Neat for a variety of different reasons. Some of them are even like historically significant to the observatory. here,
That's
which is
true.
really neat.
Sombrero Galaxy is one of them, isn't it?
Yeah, it is a location where the redshift of this object was discerned, and helped a lot of people understand that our universe is not really like the way that we previously thought, and that it was sort of in this state of constantly expanding through this really strange negative pressure known as dark energy.
Dark
which is
energy.
an absolute rabbit hole to dive down.
That's
so I'm not even
true.
going to bother going much into that. But it is a very, very beautiful object, and really just like being able to see this really uniform disk where in the center that core really does pop out. It's just really neat. And I believe it's about 31 million light years away. I don't have like any information or anything on this object
I don't know
on
off
me,
the top
but
of my head.
I think around like 31, 32 million light years is the like, general distance of this object. And usually when estimating distances, again, you have to take into account that they are volumetric sometimes. And even like little inconsistencies. There's a lot of like distances are discerned from like brightnesses and magnitudes, which it can be all like observationally just biased and really weird for us. But you know, humans are not really perfect at doing much of anything.
That's
So
true.
kind of do that. And M67 before it sets, if that's possible. Is
Yeah,
that possible?
let's do it.
People at the plane wave.
Yeah, let's do M67. And then we'll check back in on our elusive M30 object to see how that's going, because it is 5:30 a.m. So we want to be sure to check back. So let's try for M67. What is M67?
Open star cluster.
Oh,
Yeah.
okay. Hey, we should be able to see that.
Shouldn't be much of a crazy thing at all. Open clusters, again, very, very nice. They always just are all spread out. As Claire said a little bit earlier, Hubble doesn't really peep at them all too much. Tree.
Okay, it looks like there's a tree.
That one's,
okay.
yeah, that one is definitely behind the tree.
So we won't be able to see it,
Unfortunately.
but you can always rewind after we finish this live stream to see M67 when we got it earlier in the program. So that's definitely a possibility. Let's check back in an M30, our last object. It still might be a bit, but let's just check for fun. Let's see how it's doing. Yeah.
Fun thing to do.
Yeah. So we're gonna check back in that. If not, then we can go to some other favorite objects in the night sky while we wait for it. But yeah, this is kind of just the hardest part is the last object.
Still kind of ground there. Yeah, this one's the tough one,
Mhm.
no matter what, because it's sort of like starts to show itself as it gets much brighter out in the sky. At least sort of like compared to what we're used to throughout the entire night here. So a lot of little adjustments have to be made. And yeah, M30's just being a little bit rude, but what can we do? We are coercing it into showing up and letting us take a picture of it and then mark it all off.
Honestly, we may just get a fuzzy blob in a grayish background, which would honestly be great if we could see it like that.
And also par for the course for how this object has really been treating us, at least from the last couple of minutes here.
Very much so. I remember last year from the Messier Marathon that the last object was just so much fun to get. It was just like, yeah, this is a slightly brighter section of the night sky than the others, and this must be it. So it was fun.
Sometimes that's kind of what you have to do.
Sometimes
like, sometimes there's like the objects that barely just reach over the horizon, like some of the objects towards the south in particular, especially like during the fall, are just super cool. And yeah, TriFit again. We can
let's go to that nebula again. We're gonna stall for more time. The waiting game has begun.
TriFid with the nice selection of the different nebulae types. It's definitely a pretty thing to see.
Yes. The nebula with the big X pattern. Yep, that checks out with the TriFid. Yep. So we'll be able to see that in just a couple of moments. We're changing some of the camera settings to get the best view that we can in this early morning. So yeah, let's see how it looks. So we might need to jog the telescope.
That is an interesting position.
Yes, we can see the very tippy top of the nebula. So we're gonna do some fine tuning of the position of the telescope. So it might take us a couple of moments to do that, but it's cool to watch. Oh, looks like it's in the center now. So we'll wait just a couple of moments for it to come back into view. Change some of our settings. Thank you, telescope operators, for flying fast. This is pretty awesome.
I think I've seen Vesta before.
I have seen Vesta before.
I've seen Vesta before.
So there's
a
comment that I've never seen Vesta or Pallas before, but those aren't in the Messier catalog. You are right. There's nothing within our solar system that's in the Messier catalog. Even though the whole point was to technically find something in our solar system.
I kind of like mapped a thing that were like, it's like, oh, these are not comets. You don't take into consideration these.
Yeah.
TriFid though is beautiful as always, and even with the slowly rising sun, it still stands very beautifully amongst the background.
It is. Again, it's quite nice.
Just those I guess differences really in the color.
So beautiful.
Make this just such a neat thing to see visually. I've never really given it like a view through an optical, eyepiece or whatever, and been just blown away as much as I have like with a really nice photo.
Right.
Just because light gathering, the reds don't really want to get through,
Right.
and then the blues are also just kind of like fainter than some other blues really are.
Yeah.
But you can sort of see, and this is something that I have seen before, that X pattern that was being described by somebody in chat. Sort of like overlaying this weird sort of background glow that comes through at the very least, but it's still like very grayish, very neutral, more than super duper colorful and pretty as this, what is that, just only 13-second exposure.
That's pretty great.
Shows us, and that's not a whole lot of time, but good camera, good telescope, nice combo of the two makes it so that we don't have to like really, wait 20 years for something really pretty to come through.
Definitely.
Which is really a good thing, especially as we are getting towards our 110th object here in the Messier Marathon object list.
Yeah, we only have one more box to sign.
One more box to sign.
Which will be that M30 whenever we can catch a glimpse of that. Maybe we can check back in to that object.
Should we give it another shot?
Yeah, let's give it another shot. Why not? It's 5:35. What else can we do? We can't wait forever.
Hope. We can hope.
So we're gonna see. I don't know. We're gonna see. I don't know if I have high hopes. I'm just anticipating the object. No thoughts, just M30. Oh, come on, M30, show your beautiful globular cluster self. Might have to wait a little bit more. That's okay though. Maybe
slowly, ever so slowly.
Ever so slowly. I can't really see anything in there. We do have a question. Is the Seven Sisters star cluster in the Messier catalog? I believe it is.
45.
Yeah.
If I'm not mistaken. Yeah, 45 Pleiades, Seven Sisters, and that is set. I'm like pretty sure.
Let's see. It might be up. We'll wait to hear from our telescope operators.
Because that thing's usually setting a little bit earlier on in the evening now.
Yeah, it is.
Wes and John Compton got that thing, and they were here from like
quite early.
They were here at like 6 o'clock.
It is currently not up, but again, after this live stream is finished, you are welcome to rewind back to that object to see it again.
It's super pretty. It's
really
a cool
pretty.
thing to see. Like the nebulosity around the star is still just present. It's just crazy. Typically, the first object in a Messier Marathon.
I did not know that.
I didn't know that either. I guess
that kind of makes sense. It's like a nice bright one to like get your confidence up. Yeah.
And then you get just globular star clusters completely.
Yes.
They keep feeding it to you. Oh, something's happening.
Looks like there's some stuff, probably not the cluster we're looking at, some horizon objects.
Whatever that may be.
Yes.
Oh.
Interesting.
Oh.
I'm interesting. I'm
Do
very
the telescope people know what that is? Because
we are intrigued, to say the least.
It's moving.
Oh.
Alien.
Okay.
That's the first response. No idea.
We don't have any idea. So, hey, that's sometimes
maybe it'll
how it
lead
goes.
to something cool. Maybe
Yeah.
it'll lead to us seeing this 110th object, finally getting to where we need to be.
Do you know if globular clusters are able to be reached via video mode?
Via video mode. Sometimes.
Maybe.
But maybe for this guy.
Yeah.
Might be a little hard.
17-inch reflection. Okay.
Oh, that makes sense.
So this might be some reflecting light from the 17-inch plane wave, which is right next to the 14-inch plane
One of
wave
the other
that we are using.
telescopes,
Yes.
and that one's used mostly for CCD astrophotography right now, along with a spectrograph that's getting working.
Yeah, we're working on it, which will be awesome when it is up and running so that we can do live science for the public, which is kind of awesome. Like never really before done in such a way to like take spectra of the night sky and like immediately show it to people who come up to.
And it's a wild process, spectroscopy
Yeah.
it's mega important in just a lot of different aspects of astronomy right now. So excited for that.
Yes.
17 is kind of like it's got the cool stuff happening.
Yes.
And we are physically seeing the 17 most likely right here in this view. It's just, again, another telescope literally right next to the 14-inch plane wave that we were using to take these pictures and to, completely photograph everything that's been going on this entire evening. From the most beautiful of nebulae to the most globular star clusters of globular star clusters. And speaking of which, this last object here again, Messier 30,
Messier 30, come on.
110, a globular star cluster.
All in one night.
All in one night.
You know, that may not sound like much, but waiting for the Earth to rotate is a painful process sometimes when you're up for every minute of it.
You can, yeah. I can attest to that. I can very much so attest to that.
Yes. So kudos to you who have waited every single minute for us to see this last 110th object. We're so close, just waiting for it to peek out a little bit, just a little bit of a light, and then we can call it good for the morning.
Absolutely. We're seeing the Earth spin 10 seconds at a time here.
It's pretty cool to see, actually.
It is kind of new. There's like a anticipation happening.
There
with this.
is. We are getting closer.
We're getting closer.
Okay.
It's getting there.
I hope everyone who is watching is as excited as Jacob and I are, and I know the telescope operators are excited. I know when we see this object, there will be screams from outside.
There probably will be like some very loud screams, but that's
But
kind of
hey,
cool.
that's the energy we need for 5:40 a.m. in the morning.
That and a lot of caffeine.
That's true.
And some hash browns that I'm gonna make when I get home. First thing.
Nice.
I get home.
I'm gonna go to sleep. I think.
If I'm fully awake, yeah.
I'm gonna go to sleep. Yeah, that's what I'm doing. But hey,
It's getting darker.
I think we're getting out of the 17-inch view and into the actual night sky view, or
No more
morning
ground?
sky view.
No more ground.
This is interesting. Interesting indeed. So telescope operators, while we're waiting, if you could pull this up on the plane wave interface, just so we can show the viewers where we're looking in the night sky to give them an idea of literally, it is not even, it's not even in our little bubble of view. How? I've never seen that before.
Now you have.
Yeah. So yeah, we're technically looking somewhere in Capricorn. And where that little bullseye green and yellow circle is, that's technically where we are right now. So visibility is difficult at this moment, but hey, we're getting there.
It is literally inching its way towards view.
Yes, I'm so excited to see this. But anyway, recap on the night. What has been your favorite thing that we've looked at so far?
Us, like our group,
Anything.
I would definitely say Lagoon. Just because, again,
Lagoon
instant
pops
classic.
off, yeah.
Something that like really does like hit it with me. I'm like just blown away by the view of it always. Those are cool.
Yeah.
And even though there are like what almost feels like an infinite amount of those globular star clusters, those are awesome, as well as just like understanding the dynamics of them, how they operate, how they work, kind of what they do for the Milky Way, and how we understand how our own galaxy works. It's super important. And a lot of like astrophysics science is really just fantastically useful in really just understanding how those globs exist. And it's just neat. Is M51 Whirlpool still well positioned?
There's a question of if the Whirlpool is well positioned to perhaps look at it. It is. So
we know it's good.
let's go to the Whirlpool, I guess.
Whirlpool's neat.
Yeah.
Whirlpool's a neat galaxy.
Whirlpool's a fan favorite, I could say.
I think it was 24 million light years away, if I'm not mistaken. Something in that
Something like
ballpark.
that,
It's a fair distance, a really neat object. It's technically not even really like one thing, is it?
It is two objects smushed into one, I think.
I see the
Yes.
process happening here.
The Whirlpool is, there it is, nice.
Going back to that term, I like to say that the bigger galaxy is befriending the smaller, but the real, legitimate, no joke, astronomical term is galactic cannibalism. And that is currently happening between these two galaxies here, which would be Messier 51, again, Whirlpool Galaxy, that sort of like primary big spiral galaxy, and the smaller elliptical that seems to be becoming a little bit more assimilated into the primary target there.
Yeah. I like how you can see the very like dark little like connection between the two galaxies. It's just this string of gas, basically. It's really cool to look at.
It's cool even through like, again, eyepiece telescopes, being able to see
true.
this thing through like a 16-inch or a 24-inch. It still is like really something that pops itself through very nicely. And especially sort of the connection there that you were mentioning is something that you can see, at least I can see it, if you use your peripheral vision and sort of let your side eyes take in the light, as that's kind of what they're really good for. Whirlpool though, right next to, I believe it's like the handle of the Big Dipper around that area. You make like a weird triangle with some stars. Forget like the exact position there. Someone
Let's see. We're
has
gonna,
that.
we're
Yeah.
gonna pull it up here so we can see it.
Maybe
with our plane wave
I'm going
interface.
crazy because it's almost 6 a.m. now. But yeah, it's
Yeah, it looks like you were right. Wow.
Sweet. Yeah, you make the little triangle with those stars, Mizar, Alcor, and the other one there on the end. I can't really even read that. When you zoom in, it,
that does not help.
It brings
Yes.
more into view. We'll just
That star at the end.
That star at the
Yes.
end. Yeah, it's like a little right triangle. And do you have the Whirlpool Galaxy? I just remember that from like being able to like point things by hand a very long time ago, and
With the OG telescopes.
the originals before we got these Godo telescopes up
That's
here.
true. Yes.
But yeah,
Yeah.
absolutely.
It's pretty cool. Let's check back in M30.
M30.
perhaps?
It was at -2.3 degrees,
So
so just a
let's
little
see what it
below the
looks like.
horizon. And this was just about 5 minutes ago, I believe.
Maybe. I don't know.
Maybe.
I have no idea. But let's see for fun. Let's check it out. We're moving the telescope around, changing up some of the camera settings so that we don't accidentally blind any of you by a completely white screen, although that happens sometimes, which isn't a bad thing. Let's see. Do you see anything? I don't know.
I see things.
I see. Oh,
Weird things, like ground
yeah.
things. Nautical twilight has now begun, 546.
That's pretty interesting.
It is interesting. It was a
Scary.
huge gap between
Yeah.
objects here. But again, since there were so many globular star clusters and we were kind of unsure like whether or not we were going to be able to really hit all of them in time, that was definitely the speed run. But we're super close. Currently, this is a view of one of the trees that is on the tree line towards the east. So we are definitely
We're
getting
so
there.
close though.
We just have to have the telescope like sort of observationally climb the tree.
Yeah.
Which is happening live as you
can
see this thing
those,
moving.
Yeah, you can see those dark shadows shifting out of the field of view, which is literally the telescope observationally climbing up the tree.
And it is a very weird sight, that's for one, just because like it's kind of moving the sideways just because it is pointed pretty much towards the eastern horizon right now.
Yep, indeed. Indeed.
Which is not really a position these telescopes really ever go.
Yeah, not really.
Usually you don't want to like send them under like 20 degrees off the horizon.
Yeah.
So being originally like -2.3 is it makes the telescope cry.
Just a little bit.
Just a little bit. And people who do the technical work on it too, probably.
Yes, I'm sure that is not helpful for them. We're getting there. We're so close. Oh, man. Waiting for that little glimmer of a light. All right, we're gonna.
That is a high
we're gonna increase the exposure.
Seconds.
I'm a little nervous.
17 seconds.
I'm a little nervous.
I'm always nervous. There we go. M30.
That's where it is on our chart.
Our
that
target.
little box.
My hand is up there. You can't see it most likely. Probably not at all.
It's a picture of M30.
It is a picture.
The last globular cluster. Okay, so we have some brighter skies since we increased the exposure time. We're just waiting to see if we can see just a little bit of that globular cluster, just a little bit.
The dawn is on its way.
Mm-hmm. Indeed. Ugh, I can feel it. We're so close. My eyeballs can also feel it because they're starting to close involuntarily.
I am now making myself crave hash browns, like even more. A little bit of hot sauce on that. Sit there in bed underneath like a bunch of sheets because the low tonight it wasn't like as low as it has been, temperature wise.
It was below 20 degrees.
Below 20 degrees,
Yeah.
which is like sometimes pretty normal.
Yeah.
There's been nights where it gets like single digits or even negatives with wind chill or negatives just as a stale temperature.
Yeah.
So it's nice to be able to at least be out there in like 15, 20 degrees, but definitely not nice for the telescope operators who are currently just waiting for this to unfold.
Frigid. I can't imagine. Although we were just
I was gonna
So
say it's been a switch off type
Yes.
thing, and they will have the sun very soon.
that's true.
Which I don't know how much
Those
warmth
warming-
that'll bring really.
Not much for a little while, not until it gets higher up. But soon. I will hopefully be in bed by the time the sun is fully up. Maybe. Sunrise will be at 6:41 a.m., less than an hour. So again, we are currently in nautical twilight as of 5:46, so just about 3 minutes ago. So a little bit update on the astronomical situation going on. So we're still playing that waiting game to see if we can catch M30 for those of you who might have just joined. To see, basically just stalling for time until we can catch a glimpse of that last globular cluster in the constellation of Capricorn. And it is about 28,000 light years away, so pretty good distance. Pretty good indeed.
And in 10 minutes, I would have been up for 23 hours.
Wow.
23 hours.
Pretty
now.
impressive.
Not really,
Mm.
but sure. We'll call it impressive.
Nice. I like that. So yeah, let's see. We're changing some of the views again. We're down to 5 seconds for exposure time. Ooh, still a dark sky.
Dark sky.
Oh,
Maybe
come
we're
on.
underexposing those trees. You know how it is.
We are trying all that we can right now to catch that glimpse of M30. But we're gonna get there. We promise you. Or hopefully we can. I guess I shouldn't say promise.
Look what you've done.
I know. We will. I have
My
high
best
hopes.
friend. There he is.
Oh.
I saw him.
Jacob spotted
Charles Messier.
Charles Messier,
Charles Messier again.
the mascot of the 2022 Messier Marathon.
That mouse has the cutest eyes. I'm
Aw.
going to be completely honest
Aw.
with you.
Adorable.
I heard him scuttling. He's cheering us on.
I believe it. He's probably wondering why
Adopted the name, just trying.
we're here.
That's true. 1 degree below horizon still. So it's getting there.
We're getting there. Okay.
The scope is pointing above.
Okay. So we're still in that waiting game, but we're very, very close. It is currently 5:51 a.m. here in Flagstaff, Arizona.
Cheat a bit with our altitude for sure.
That's true. We
Yeah.
definitely do.
We're up here at the Open Deck Observatory, which is already at a high point on the campus.
We are pretty high up.
We're sort of looking from up kind of downwards, and,
Mhm.
and so we can definitely cheat these objects out a little bit, even when they're beyond the horizon, which is kind of a funny thing to think about. But is it geometry? Would that be geometry? I can't even really think right now.
Yeah, neither
That's
can I.
something for you.
It's been a long
Shapes
time.
and or paths and other things.
Math and shapes. Yes,
I gotta do enough of that daily, so
yeah,
it's kind of.
that's true. You are a physics major.
No, I'm not.
Oh, astronomy major.
Yes.
Same difference. Truth be told.
Kind of, yeah. Minus 1 class or
Yeah.
2 classes.
Interesting. Oh, apparently astronomy is not the same as physics, according to the telescope operators.
Well,
I
they're
guess
separate, but
they are separate.
As far as
but they're
as far
quite
as
related.
classes go,
They're quite related to
as
each
far as
other.
classes go,
You
there's a-
can't have one without the other. Well, you
I
can
mean,
have physics without
you
astronomy.
can,
Yeah.
absolutely, yeah.
But you can't have astronomy
Pretend the
without
stars
physics.
don't exist and stuff like that,
That's
and
true.
then life is good.
We could just ignore everything outside of Earth.
Everything's infinite and everything is what is it? Ideal, right? Cows are spheres. Parallel plate
Yeah.
capacitors are infinitely long and made out of perfect conducting material or whatever.
Those words are big.
Science.
I don't know. Yeah.
That's new. We got some new
We're
thing
getting a little
going
bit of
on
a
there.
shape towards the upper
What is the
corner.
shape? The shape.
We have some lingering mouse up there, a little mouse from the telescope.
Speaking of mouse.
Sky. Okay. That's pretty good. At least we're seeing some sky instead of flora and fauna of Flagstaff, Arizona. So
Are we seeing fauna?
I don't know.
There's got to be animals.
I don't know.
Birds, maybe some really birds that will brave the cold, I don't know. I guess we have really.
I'm pretty sure birds always have to brave the cold.
I mean, yeah, I see them flying in the snow and stuff. They're kind of living.
Don't they live outside? Basically.
No. Anyways, sky.
We're starting to see some of that sky poking through the trees.
So yeah, with those 5 seconds, we're seeing the Earth rotate, or 7 seconds now, it looks like. Pretty neat. Pretty neat indeed. Yeah, pretty cool. Anyway, back to physics and astronomy discussion.
I'm on spring break now. Do I have to?
That's true. It is spring break. It is officially Saturday morning.
And what a way to start it, really. Just
I
like
know.
an entire Messier marathon.
Yeah.
Goodness gracious.
I think it's a great way to start it.
Definitely is.
Better than doing homework.
I still gotta do homework.
Same
I
here.
absolutely still have to do
Same
homework.
here.
There is no rest for the scientist person who's becoming one, maybe?
The STEM major.
The STEM major, that's what it is.
Yeah. But anyway, we'd love to hear updates from the audience, seeing how they're doing at 5:54 a.m. Let
How you
us
feeling?
know. Let us know if you're drinking coffee or tea, or
Just waking up.
what your favorite object that we've seen so far, since we've gone through 109 of them. There's plenty to choose from. So we'd love to hear your thoughts about the Messier Marathon so far, as we just wait for M30 to pop through the sky. We're so close.
It is literally just right behind this tree here somewhere.
Yes. We're going to do it though.
Something's happening, some gain reduction.
We are changing some of the telescope settings, camera settings.
Yeah,
Yes.
absolutely. Settings are being changed.
Yes.
Gain was decreased so that things were not as bright pixel by pixel. And it's still moving through this tree, still climbing it, observational. Climbing, not really real.
Yeah,
If telescopes could climb, then that'd be terrifying.
I suppose. In
Yep,
a literal sense.
5:55 a.m.
Yes,
thoughts.
yeah, that's very true.
My brain is currently mush. My stomach is craving the sweet taste of hash browns.
Sweet.
I don't know.
Savory.
Savory
Salty. Potatoey.
flavors are fake.
Okay, hot take of the
They're
day.
not real.
Yeah, hot take of the day. Indeed, flavors are not
They're
real.
just your brain telling you things, and that's it.
I mean, you're not wrong.
Coffee or tea?
Ooh, I'm a coffee person.
Both.
Yeah, I guess I could say both.
I'm definitely both.
Coffee in the morning, English breakfast, tea at night, like a true Brit.
Like a true Brit.
Yes.
Said like a true Brit.
Yes.
I just do whichever, whenever. Either or. I had like a lot of caffeinated tea tonight for very obvious reasons.
Yes.
Didn't have coffee tonight though.
Hey, that's pretty impressive.
Usually that is like something that I do end up getting, but I think it was a little bit too sugary for like what I was feeling.
I mean, you can get coffee without sugar.
That's true, but like also no.
Oh. What?
I mean, black coffee's fine, like just straight up, but
I think straight coffee is delicious. Thank you very much.
if it's like the right kind, really. Because there are some like coffees and stuff that you get, especially sometimes like store-bought stuff that, straight up not the best in the world, but at the same time you don't have to have like crazy import coffee or whatever. Does anyone know around when we saw M67?
We are checking our
obviously-
database. We have a whole schedule here, so we might be
That
able
would have
to
been
pick it out.
Wesley and John Compton, so probably within 6 to 10, I believe that time frame, 8:45 to 9ish. So towards the latter half of Wesley
Yeah.
and John's time observing.
Yes, wait, yes, M67. Sorry.
Probably closer to 9. So this, yeah, a lot of hours ago now.
I think there's a sheet missing. That's probably why.
Yeah, absolutely.
Yeah, all right. Yeah, probably closer to 9 o'clock. Those little shapes kind of look weird to me. They look like skulls, personally.
I can see it down the bottom
Yeah.
left there with like little eyes. Also, I'm holding a, was this a DVD? Yeah. I can't even tell because like it's horrifying looking, but that's cool.
All right.
Who were the hosts at that time? Again,
I believe
Wesley
and John Compton.
Yeah.
Yes. For object M67, which is an open cluster.
Open cluster,
Okay,
yeah.
nice. Open cluster M67. So when we are done with this live stream at whatever time that we can see M30, this will be uploaded fully to YouTube, and you can watch it whenever you want. You can go and rewind to your very favorite object and relive that moment for however many times that you want to.
3 times.
Yeah. But that's something that will be available, and you can even watch last year's Messier Marathon, which was Lowell Observatory's first ever Messier Marathon, which was
I was here.
It was a learning
did
experience
that.
for sure, but it was really fun.
It was
Yeah.
really fun. I remember what did I eat? I like had like a full meal in front of me
Wow.
for a little portion of mine, I believe.
I don't remember a lot of it. I was at the 2 a.m. to 6 a.m. stretch again, and it was a lot of brain mush.
You just
Yeah.
love this slot.
I don't know. I think it's fun.
And it's good. I mean,
No one else
it's
wants to do
great.
it though.
You get to like you get to have this anticipation that just kills you at the very
Indeed.
end, waiting for M30 to just pop
Indeed.
up.
Come on, M30. We need you.
And
We
tonight was
want
like the
you.
perfect night too, because originally like we had a bunch of dates planned out because there's been just scattered weird little snowstorms that
That
have
is
just popped
true.
into existence. Currently being a James Bond on there planning to blow up the moon. Absolutely. That is Wesley. That is Wesley.
Yes, for that comet that just popped up.
I am going to aid Wesley in the explosion of the moon, the destruction of that horrid rock.
I wish you luck on that. Very intriguing endeavor. So we're lowering the gain a little bit on our telescope to not have so much brightness peeking in from that sky.
That's
It looks like
a
spooky
wild
skulls
guess.
still to me. It looks like maybe M30. Oh, I guess
It
we're just
could-
looking at
yeah.
we're just looking at cool shapes in between trees. Which not too bad. I bet this could be like an art piece photograph maybe. Looks very,
That would be a very strange,
I'm sure someone would buy it.
almost like a Boys of Canada cover.
Yeah, maybe. Very interesting. Interesting indeed. All right, M30. So for those of you who might have just joined in, M30 is our last object. We are waiting for it to peek in through the trees.
Happy 6 o'clock.
It is.
Happy 6 a.m.
That's true. It is 6 a.m. now.
Goodness.
In 41 minutes, the sun will have risen. That is the sunrise time. So we're fighting against that nautical twilight light.
As you do, fight the sun.
Yes.
It's great to fight the sun.
Yes.
Attack it while it's at night, nighttime, and life is good.
Yes. I remember this very weird conversation I had about the sun. This is a really weird conversation, but it was funny. And it was before an interview that I did. And it was just a bunch of people around kind of just talking to each other, warming up, feeling comfortable for the interviews that were about to come. And we had a discussion about how many bears it would take to defeat the sun. How many bears? Just like bear spaceship going to the sun.
7.
7?
Yep, lucky number.
Wow. Wow.
It'd have to be 7 really strong bears.
Very
You never
big
said anything about
bears.
strength
Okay, fair enough.
or size. Yeah, too.
Yeah.
Yeah, exactly.
Who knows?
I mean, they probably. I mean, you'd have like this size, and then they would just become stars.
Very interesting conversation though.
Something.
Yeah. How many bears does it take to defeat the sun?
It
That's
really
the
is 6.
new-
It is
the
really,
new-
really 6 in the morning right now. This is incredible.
Doing so good.
Definitely what comes to mind around this time.
Okay. So we're having a little trouble looking at M30.
We got not trouble. It doesn't look good. We're climbing a single tree. The existence of this one tree.
Okay, so we're just looking at one tree right now. Right.
Technically, the object is like
Come on,
there.
M30.
It's
yes.
there.
I mean, you're not wrong. We just can't see it.
And we won't be out for a while. Uh-oh.
Uh-oh.
10 days earlier
Okay,
than
so
last year, the sky will be much brighter. We get to see M30 compared to
Interesting.
last year.
Okay.
Ooh.
So flashback to last year, 2021 Messier Marathon. We did this about 10 days earlier. So the sky is currently much brighter than it was last year at this time. And M30 was tough to see last year, so we might not be able to see it, which is the unfortunate truth.
That's true, but we could always just do M30/tree and then sign off on it, because then we'd be right. Because we're seeing M30, not really.
I mean,
And trees
it's there.
Trees are always growing, and I do enjoy trees. They're
Yes,
cool.
trees are cool. There's conversation of cutting the tree down. Not right now. We don't have time for that. I think all of us are too tired
Climb
to
right up the tree and try to take
to cut a
picture of
tree.
it. Somebody like get out a camera with like a really, really long
All right.
zoom lens.
So telescope operators and background. What is the final verdict on this object? Because it is 6:04 a.m. we have been waiting for quite a while
Draw
now.
a tree on the board, like down here at the very bottom, or just
No,
like
on M30.
completely on M30.
Yeah,
Yes.
M30. Okay, so we're gonna draw a tree through M30. It looks like we're not gonna be able to get a clear view of it right now. Currently, our telescope says that we are on M30, but it is stuck behind a tree. So that is our reality. That's a good tree. It's pretty good.
Thank you.
All right, so I think that wraps up our very last object, even if it was a tree.
It's a tree.
It's a tree. But it is currently 6:04 a.m. in Flagstaff, Arizona, and the current temperature is probably around,
Cold.
yeah, very cold. But we want to thank you all. Oh, 18 degrees. Yes, quite cold. We want to thank you all for joining us, however long you've stayed. And if you're just tuning in, this has been quite a fun time. We're happy that Lowell Observatory could put on the second Messier Marathon for 2022. And for those of you members who joined in earlier in the evening, we hope you had a good time, and that's pretty great. So we saw 109 objects in a tree, which is pretty dang good.
The tree's an object. We saw
Yes.
110 objects. That's crazy.
I mean, you're not wrong. So we're gonna sign off. We're a little bit tired and loopy right now.
Absolutely.
But thank you all for joining us this last night and this morning for the Messier Marathon, and we hope you have a great rest of your morning. So goodbye.
Woohoo.